Welcome to a new course in which we learn everything you need to prepare and learn about Azure Fundamental Course. My name is Vladimir Živković and I'm certified Azure Solution Architect, and I'll be your guide in a new course where we will get acquainted with the ins and outs of Azure Fundamental Course that you'll encounter throughout your cloud career. In addition to the basic services, we will get acquainted in detail with other services related to Azure, all with a multitude of demos. If you plan to follow all the practical exercises with us, it is recommended that you create a free Azure account so that you can learn and understand what are we talking about. The course is designed according to chapters and is designed to introduce you to the service itself, from the basic to somewhat more complicated parts, for which it is necessary to repeat the demo several times, in order to practice and understand in detail what you want to achieve. That is, what is the goal of the exercise. Now that we have familiarized ourselves with everything that awaits us in the next few days, I suggest that we embark on our journey, and it's time to sail into the Azure cloud. Welcome to the new course in which you'll get to know the fundamental course of Microsoft, better known as AZ-900. In this course, we will cover all the most important areas that will help you to learn and prepare for the exam as easily as possible. And not only that, it also contains a lot of practical videos where you can familiarize yourself with the practical part that will help you in your later progress. The course also contains many training sections in which you will be able to get acquainted with the creation of the resources themselves, but with a detailed explanation of how they work. In addition, it would be a good idea to open a free account yourself and follow practice with us. As the course progresses, you will see for yourself that you can learn a lot through the theory and practical part, which will also prepare you for the later exams. I must mention that this course contains more than what is required when taking the fundamental certificate, so the knowledge gained will help you prepare for later challenges more easily. Let's continue to the new lecture. Microsoft Azure, formerly known as Windows Azure, is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft Managed Data Centers. It provides software as a service, SaaS, platform as a service, PaaS, and infrastructure as a service, IaaS, and support many different programming languages, tools, and programming frameworks. Azure was announced in October 2008, started with the codename Project Red Dog, and was released on February 1st, 2010 as Windows Azure before being renamed to Microsoft Azure on March 25, 2014. From its inception until today, Azure has come a long way, and today it is considered one of the most advanced cloud service providers, and according to its use and spread, it is in second place right behind the so far undisputed AWS. There are a large number of companies that have moved their businesses from their own premises to the cloud, and thus made huge savings in their budgets, and the funds that would be invested in equipment and manpower were used in the development of other familiar options. A large number of services and data centers spread around the world make Azure stable, light, and very pleasant to use on a daily basis, while it is up to us to choose the services we need. The current number of services on Azure is 200, and they are constantly developing and improving, and this is the case with Azure Fundamental Services. In short, if you need a business solution without additional investment in your own data center, software, and people, Azure is the solution. In the next chapter, we will see how to create a free Azure account on Azure Cloud. Azure certifications are a way to demonstrate and validate your knowledge of specialized cloud roles. Despite this, there are numerous Azure certifications available for you, and you may not be sure which certification best suits your needs. So there is a huge amount of documentation out there that can help you discover or find out your path to working in the cloud. Microsoft Azure is not the only cloud provider that has this type of certification, So you can do something similar in Amazon, Google and other providers. But we will stay here exclusively with Azure. So if you're interested in something else or are already familiar with certification, I suggest you that you skip this part. Azure is one of the most world popular cloud computing platforms and one of the market leaders in cloud computing. The demand of cloud-based solutions is constantly increasing, and most organizations and businesses, whether small or large, are moving their operations to the cloud to stay competitive. It also has a direct impact on the demand for cloud professionals. Microsoft awards certification to those who, in Microsoft's opinion, are the best candidates for a particular position. Microsoft certifications are valuable, and most employees prefer to have them on their resume if at all possible. Still, you should be honest and say the certifications are only part of the equation. Most employers will ask you a number of tasks that you have to solve practically. Opinions are divided, and in many specialized forums and groups you can read two groups of opinions. And about half of them believe that practical knowledge is more important than any theoretical knowledge, while the other half is of the opposite opinion. From personal experience, I believe that both opinions are equally important, so if you want to take all the certifications or certificates you want, and at the same time learn practical work, which is the best recommendation. Azure certifications are essential as you build a career in the cloud computing industry. Azure certifications are classified into three levels: fundamental, associate, and expert. There are also several specialized certifications such as SAP Workload or IoT Developer. These exams are used to validate your proficiency in the Azure cloud, and they are exclusively focused on the development of knowledge and skills related to current roles in the market. All Microsoft certificates are included in the Microsoft Learning Path. The first one is the fundamental certificates, and they are for the beginners who have started their journey into learning the cloud concept or concept of clouds. Also, people with no technical experience can start their cloud journey with these certifications. Association certification or associate certification are for you if you are already familiar with Azure. It is a good idea to take and get these certifications listed in your resume. Expert certifications are for people who have prior experience, deep understanding and knowledge at the associate level in Azure, so you can pass for expert. I already mentioned that there is specialized certificates and there is for certain roles. Detailed information about Microsoft certification and the path to expert certification can be found on the official website, as well as all other information about the certificate itself. Questions that can help you prepare for the exam, as well as a complete learning module with explanation and examples. However, the advice is to practically try everything you read or learn during the preparation of the exam. When it comes to the exam, it is not easy at all. Moreover, many comments on the already mentioned forums and groups lead to the conclusion that you have to be extremely prepared and even repeat the exam if you fail for the first time. You can take the exam at one of the Microsoft test centers or from home under the supervision of a proctor. It is important to point out that proctors are extremely strict and that any use of aids is not tolerated, not to mention the influence of external factors, as well as that you constantly have to be in the sight of the camera, so you should not even think about the attempt to cheat. The exam lasts depending on the difficulty of the certificate, and you will get to know all the other details as well as what is allowed and what you need to pay attention to during the exam application. Once you score more than 70% according to Microsoft criteria on the mentioned exam, you are considered to have passed and receive a certificate for the exam you registered. There is a fantastic integration of the obtained badges about which certificate you have, so you can post it on social networks. Another important thing is that when you pass the exam, the certificate is valid for a year, except for the fundamental one, which when passed are valid forever. You won't have to take exam again, but if you try something else beside these fundamental ones, then after 6 months you will receive an email incoming that you have to renew the validity of the same. But don't be afraid, you have 6 months to answer a certain number of questions without the proctor supervision, so you can take the exam every day until you win. If I haven't forgotten, 59% of the correct questions are necessary for the certification. After successfully passing the certification, your certificates will be extended for 1 year, and only after 1 year you will retake the exam for revalidation. What Microsoft introduced at the end of the last year are applied skills badges, where you can show the employer of your followers that you have mastered this knowledge with the practical knowledge in certain areas. From personal experience, I recommend that you try this option as well, and if you are successful, add the earned badges to your business profile. If you are a beginner, all this may sound extremely complicated to you, but once you go through everything, you will see that it's extremely easy, interesting and fun. All other information can be found on Microsoft official website, so make sure you find out more about it before embarking on your cloud adventure. If you've been wondering if there is anything else we didn't mention in the previous chapter, that is a good news, is the information that Microsoft has prepared 30 free uses of the Azure Cloud for all new users with a $200 credit that you can spend trying out various services. And not only that, but some services remain free for the next year and some for longer. It is important to note that by the decision of Azure itself, some of the more advanced services cannot be tried, but for what we will do in the first in this course, everything will be at your disposal. Access to the resources offered by Azure is done through the portal www.portal.azure.com, but an account must be created first. Creating an account is extremely simple and does not require more than 10 minutes, as we will see in our example. All you need is a Microsoft or GitHub account, a phone number and a credit card. It is important to point out that after 30 days from the moment of creating the account, it will be deactivated, so you must reactivate it and switch to the pay-as-you-go option if you wish, and then absolutely all services will be available to you. What is important to note is that bill will come to you on a monthly basis with all the data you have used and how many services you have used. It is extremely important to make sure that you delete the created resources after the end of the exercise, in order to avoid additional problems with accumulating costs, and you can see this during our course. It is also very important to mention that there is an option to control expenses and limit how much you are willing to spend on a monthly basis, so if you get close to that limit, you will receive a warning about the amount you specified. Using Azure Cloud services does not require upfront payment costs, and if you have licenses for existing services, you are offered the option that you can use them and save a significant amount of money. But if you are careless and you can make additional costs. So, as already mentioned in the previous chapter, we are here on azure.microsoft.com, and you will see we have two options to choose to create account. For the first option is a free account, Azure free account, or the second option is pay-as-you-go. If you didn't try Azure free account, you can click on sign up, or if you want to create a new account and already try Azure free account, you can choose pay-as-you-go. If you choose Azure free account, you will get and this is available only to new Azure customer, you will free monthly amounts of 20 plus popular services for 12 months, free monthly amounts of 65 plus always free services, access to full catalog of services up to free amount of, and $2,000 credits to try these services, and there is no upfront commitment. If you choose pay-as-you-go, you will get these options. Also, you can see free services and offers from Azure, and some are free for
12 months, and there is only for new customers only. You can see you have Windows virtual machine and Linux virtual machine are free for 12 months, and always free is Azure SQL database. Also Azure Blob Storage is free for 12 months, and so on. You can see more free services if you click here on see all free services. Also, you can learn more about Azure if you look and click on videos, documentations, tools, or expert help. Frequently asked questions is another great solution that Microsoft or Azure provided, so you can see all questions and answers are here. One of the most important thing before you do anything on Azure is to check is Azure available in your location. So there is a way, there is a lot of numbers, there is a lot of countries here, more than 140 countries or locations. Also, if you want to create a free account, you can click sign up here, and you can choose create new account. You can create new account with your email address, Microsoft account or GitHub account. So I will say my email address is this. I will click next. I will choose my password. You can choose I would like or check this box to receive information, tips and other offers from Microsoft products and services. Click next. I'm from Serbia, so I will choose this my country. I will choose my birthday. Click next, and we need to solve this puzzle. I will click next. Verification is complete. And after this you can put your first name here, last name, email address, phone number. You can use different phone number to verify identity, and that. After that you will click next, identify your verification card, and you will ready to start. If I can fill this form, but I will not get Azure free account because I have already my account, so I will stop here. But if you want to continue, you can just add your first name, your credit card number, and so on and so on, and you will get your free account open after you specified and fill this form. Okay, let's move on.
In this chapter, we will see what the Azure portal looks like, where we'll spend most of our time during this course. I will show you the most important services and explain what is where and how to get to the service through search or all service options, and most of all, we will stay in our main page. Let's hop to our Azure portal. And here we are in our Azure portal. I will show you how can you work in Azure portal. This is a free tour to Azure, as I like to say. So let's get started with simple explanations. First, as you can see, we have our front page, and in our front page there is something called Azure Services. This is the all Azure services that you recently use. You can access to these services individually, or simply if you click on virtual machines, it will take you to the virtual machine page, and from there you can create a new resource. Also, there is a resource that you create in this recent tab that you used in recent days, and as you can see, this is our last view. This is my Azure subscription and my resource group. Also, there is a favorite tab. If you have selected some resources to be your favorite, they will show here. All the list will be seen here. Then in the navigate option, there is shortcuts to subscription, resource group, for example, all resources, and dashboard. If I click on dashboard, I can see or create a new dashboard. I can choose from various options from custom. Then I can add some Azure inventory, and if I click on that Azure inventory, I will add my dashboard name, choose my scope, choose my subscription, and select my resource. Simply click on submit and it will show you on your front page. Then the next is tools. There is a shortcuts from Microsoft Learn, Azure Monitor, Microsoft Defender for Cloud, and Cost Management. Also, in Microsoft Learn, you can find everything about services in Azure. Also, there is something called useful links. You can view technical documentations, Azure migration tools, all Azure services. You can find an Azure expert, check for recent updates, or simply check on Quick Start Center. Also, there is an option to download Azure mobile app from Android and iOS users. If I go back to my right corner, this is my username, and with which I used to create my Azure account, and this is my main email address, as you can see, which is part of my subscription. You can choose to switch your directories if you have more than one. Use your permission, submit an idea to Azure. You can view your bill and edit your contact information. Also, there is 5 icons here. If you want to give the feedback to Microsoft, you can take your time and write a feedback to contact support. Or if you simply have some problem, you have options to contact support. Also, you can tell Microsoft about your experience. Then we have something called support and troubleshooting. You can search or describe your issue to get solution and support. Also, there is a health events and support resources with the links that you can find some good advices. If I click on this little cog here, I have these portal settings for my directories and subscriptions, and there is something called default directory. This is currently my default directory. I have only one. You can choose to, if you have more than one directory, there will be listed there. Also, there is something called appearance. You can choose your menu behavior, choose your color theme, choose your startup view, and select a startup directory from last visit to select a directory. Then, as you can see, you can change your contrast theme. Simply click on apply. Also, there is a language plus region. You can choose your language and regional format. You can choose from various languages, as you can see, from English and others, and in regional format you can choose your English and the rest. In my information, you can see your current email address. This is my current email address. You can add your new email address so you can update your services or security issues. Also, there is Azure support plan. You can select your plan to do on Azure to get personal tips. Also, there is something called signing in information. You can enable directory level idle timeout by checking this box. Also, you can choose to sign out if you inactive for never or 15 minutes and so on. There is a useful links in the bottom of this page. Also, there is a little bell. Of course, we don't have any notification for now because we didn't create any services, but when you create your service or have some update or some other information, there will be notification for you to know how can you do and what you need to do in this notification session tab. Then the final icon is something called Cloud Shell. If you click on Cloud Shell, you are requesting a Cloud Shell, and you can switch between PowerShell and CLI. Right from here, you can work with your command line. Then we have Copilot. As you can see, Copilot in Azure can help you to answer your questions, complete tasks, and maximize productivity. And you can select one to get started. For example, let me choose some of this suggestion, and if you click on this suggestion, Copilot will answer you whatever you need to know about Azure services. Let me click on Show Azure SQL Database is approaching their max storage capacity, and as you can see, Copilot is finding the right answer, and he is generating our response. It is very useful to use Copilot, and once the response finished with generating, you will get your information. But in the meantime, there is a search bar. You can search for resources, services, and documentation. If you type anything here, for example, storage account, there will be storage account shortcut, or there is a shortcut for recent services that you use. As you can see, Copilot is giving us an answer, and then you can follow these instructions to make your life easier. I will just simply scroll down just to see how this response is look like. I will now close my Copilot. And then, as I already said, there is a search, and there is this hamburger menu. This is our portal menu. You can create a resource or go to your favorites here. There is a home dashboard, and you can see all services. If I click on create a resource, I will go to Marketplace. But if I go to one of these favorites, I can simply go to listed services. Let's go to create a resource, and we are now in Marketplace, where you can see all popular Azure services. There are categories, and all Azure services are here in these categories. For example, if you click on databases, you will get all databases from here, and then if I click on home, I will get to our front page. So it's very easy and pleasant to use this service. If I go to Azure subscription, I can see first what is my monthly spending rate and forecast. Then I have you can see our subscription ID, directory, status, and so on. There is a cost management blade. If you click on cost management analysis or cost analysis, you can view your current spending. This is our actual cost. And then in these graphics, you can select service name, location, or resource group name and get more granular information about your services that you have been used in this session. Also, you can check your Azure subscription, check your monthly rate or monthly spending, choose your filter for everything that you need. You can add that filter and get more granular information about resources and spending. There is a useful option called budget. If I click on budget blade, I have option to create a budget and set alert to help monitor my cost. You can choose your subscription as a scope. You can add a filter. Then in budget details, you need to add a name for your budget. This name must be unique. Then you can choose a reset period for monthly, quarterly, and annually. I will choose monthly, and creation date, for example January, and expiration date is December 2026. Also, you need to give your budget amount threshold. Let's, for example, put $10, and then you can choose your alert condition. There is a two type of condition. One is actual spending and forecast spending. Actual is how much money did you spend so far, and forecast is forecast for that month, for example. Also, there is if you put 80% of your budget in actual cost, when you get an $8 of spending for that month, you will get a notification or alert recipient that you are actually your spending is right on that border of $10. Simply, when you are satisfied with alert condition and alert recipient, simply click on create and your budget will be created. Also, there is something called manage action group. You can create an action group for this budget. I have already created one, as you can see. If you click on create, you can choose a project detail, choose a region, go to notification, take an action, for example, choose between these various automation runbook, Azure Functions, Event Hub, ITSM, Logic App, Service Webhook, or Webhook. And when action group is triggered, action type will be triggered. Of course, there is a language that you can choose, and simply click on create to create your budget. Once the budget is created, you can see all information: name, reset period, scope, expiration date, creation date, budget, forecasted, evaluated spend, and progress of your budget. If I go to my SQL budget, I can edit this information. You can set alerts, or simply I can delete this budget. Click on yes, and this budget is deleted. As you can see, we have two notifications which inform us that budget was created and then budget was deleted. Also, there is something called advisor recommendation, and as you can see, we are refreshing our recommendation and we are successfully refreshed our information. There is some billing profile invoices where you can check all your billing properties. As you can see, this is my monthly billing profile invoices. Also, there is something called resources. You can track all your resource group resources, check your preview feature, check your usage and quotas. For I don't have any resource right now, but if you go to check your policies, and there is something called resource providers where you can register or unregister your providers in Microsoft Azure, but more about that later. Also, there is usage and quotas. You can check alerts for quotas and receive notifications, or simply see what is the current usage of your service that you use for your region. You can request a new quota. For example, if you need some more availability sets in Australia Central, you can request those increased quotas. So this is our notification, as you can see, and this is our tour de Azure. I hope this was helpful. Let's see what Azure are offer in their free services offer. As I already mentioned, if you go to this search bar and simply type free services, you will get this free services option. Let's click on free services, and we are getting all list of services that include monthly free amounts of 12 months. Service usage is billed paid to go rate, so you can reach the monthly limit. This is a various list of services which you can use in this Azure service free service tier. For example, you can use Windows virtual machine, Linux virtual machine, Azure Managed Disk, Azure Blob Storage. There is Azure Files, Key Vault, Azure Data, MySQL, as you can see, and our Azure Cosmos DB, AI Vision, Azure Load Balancing, for example. Then we have Container Registry, Service Bus, and so on. Also, there is an option to see services that always include monthly free amounts. For example, 100,000 cores for SQL service, and for Azure SQL database, and service usage is billed after you reach this monthly limit. Let me just scroll down to see how many services you have. If you can see, our SQL database offer 100,000 vCore seconds of SQL database serverless usage per month with 32 gigabytes of storage. You can create a SQL database very easy and use this free serverless usage per month. Let's go and click on create. And as you can see, we are now in our database window. If you click, there is an information. If you want to try Azure SQL database for free, simply you need to apply this offer, which is in preview. Also, we already mentioned that 100,000 vCore per second, 32 gigabytes of data, and 32 gigabytes of backup storage, free per month for the lifetime of the subscription. Simply click on apply offer, and if you don't want to use this, offer, simply click on remove offer and this offer will be removed. Also, you can now choose behavior when free offer limit is reached. You can auto-pause the database until next month or simply continue using database for additional charges. Database continue to be accessible after free offer limit is reached. And then additional usage beyond free offer amount for that month will be charged at general purpose serverless rate. I hope this is now much more clearer. Also, you can auto-pause the database until the next month when free offer limit is reached. The database will not be accessible until the beginning of next calendar month when free amount is renewed. And there will be no additional charges. In this way, you can save your money and your bill will be lesser than you want. Simply click on remove offer and this offer is removed. So as you can see, we don't have this option to auto-pause our database. If we go back to our free services, you can check all other options or all other service. It depends on your need, I will simply scroll down just to show you all the free services that you can use. Thank you for watching and I hope this was helpful. Moving to the cloud gives organizations of all shapes and sizes the ability to move faster, be more agile, and innovate their businesses. The shift to the cloud computing has completely transformed the way we work, communicate, and collaborate, and it's quickly becoming a necessity to stay competitive in today's digital world. If you are considering moving to the cloud-based services and solutions, it's important not only to understand the basics of cloud computing and how it can help you accelerate your digital transformation, but also its benefits and limitations. In today's ever-evolving business world, unlocking the true power of cloud technology is not just an option but an essential strategy. The cloud isn't just a tool, it is a dynamic force for change. Success is shaped with Cloud Continuum, a spectrum of capabilities and services that stretch from the public cloud to the edge and everything in between, seamlessly connected by networks that are at the forefront of the cloud and supported by advanced practices. At the heart of this transformation lies data and artificial intelligence. Data migration is only the first step. The cloud supports a greater ability to create a reliable data platform in different parts of the business. A modern data platform is a prerequisite for advancing AI and ML capabilities, including generative AI. The cloud is the driver, data is the driver, and artificial intelligence is the differentiator. In the pursuit of cloud excellence, adhere to basic practices that maximize the value of the cloud. Embrace the cloud as a transformative force to drive innovation and competitiveness. Cloud computing orchestrates technology and infrastructure, offering unparalleled flexibility and efficiency. Cloud computing uses remote service in huge data centers, segmenting physical servers into scalable virtual machines for independent application and OS functionality. Resource pooling consolidates compute resources for on-demand allocation, improving utilization and rapid scaling. Service models, AAS, PaaS, and SaaS, meet different needs. Delivery models, public, private, and hybrid, offer flexibility. Secure scalable data storage fosters global availability and collaboration. Robust network ensure low latency and secure connection. And security measures including encryption, access control, and threat detection. Scalability allows for the adjustment of resources for cost efficiency through a pay-as-you-go model. Global data centers provide low latency access, pushing businesses into the digital era. Now that we learn why we need cloud computing, it's time to find out what cloud computing is. Cloud computing is the availability on-demand computing system resources, especially data storage, cloud storage, and computing power without direct active management by the user. Large clouds often have functions spread across multiple locations, each of which is the data center. Cloud computing relies on resource sharing to achieve coherence and typically uses a pay-as-you-go model, which can help reduce capital costs, but can also lead to unexpected operation costs for users. A statement for the European Commission, published in 2012, argues that the breadth of scope offered by cloud computing makes the general definition elusive. While the definition of cloud computing is from 2011, the US National Institute for Standards and Technology has identified 5 essential characteristics. On-demand service. The consumer can unilaterally provide computing capabilities such as server, time, and network storage automatically as needed without the need for human interaction with each service provider. Wide network access. Capabilities are available over a network and access through standard mechanisms that promote the use of heterogeneous platforms by thin or thick clients, like mobile phones, tablets, laptops, and workstations. Consolidation of resources. A provider's computing resources are pooled to serve multiple consumers using a multi-tenant model with a variety of physical and virtual resources that are dynamically allocated and allocated according to consumer requirements. Fast elasticity. Capabilities can be elastically provided and released, in some cases automatically, to scale rapidly outward and inward in proportion to demand. To the consumer, the opportunities available to provide often seem limitless and can be appropriated in any quantity at any size and any time. Measured service. Cloud system automatically control the optimized resource utilization by using the ability to measure at some level of abstraction appropriate to the time of service, like storage, processing, bandwidth, and active user accounts. The use of resources can be tracked, controlled, and reported, providing transparency for both the provider and the consumer of the service use, although for some organizations the impact on revenue from large-scale use may affect profitability compared to the sunk cost of capital options. One of the main challenges of cloud computing compared to more traditional on-premises computing is data security and privacy. Cloud users entrust their sensitive data to third-party vendors who may not have adequate measure in place to protect it from unauthorized access, breaches, or leaks. Cloud users also face compliance risk if they have to comply with certain regulations or standards regarding data protection such as GDPR or HIPAA. Another challenge of cloud computing is reduced visibility and control. Cloud users may not have complete visibility into how their providers manage, configure, or optimize their cloud resources. They may also have a limited ability to customize or modify their cloud services according to their specific needs or preferences. A complete understanding of all technology may be impossible, especially given the scale of complexity and deliberately opacity of modern systems. However, there is a need to understand complex technologies and their interrelationship in order to have power and action within them. The metaphor of the cloud can be seen as problematic as cloud computing retains the aura of something nominal or numinous. It's something experienced without a precise understanding of what it is or how it works. In addition, cloud migration is a significant challenge. This process involves transferring data applications or workloads from one cloud environment to another, or from on-premises infrastructure to the cloud. Migrating to the cloud can be complicated, time-consuming, and expensive, especially when there are compatibility issues between different cloud platforms or architectures. If not carefully planned and executed, cloud migrations can lead to downtime, reduced performance, or even data loss. To reiterate, cloud computing or cloud computing is a term used to describe the delivery of on-demand cloud resources, hardware, storage, database, networking, and software to businesses and individuals over a network, usually the internet. Cloud computing allows organizations to access and store information without managing their own physical devices or IT infrastructure. In today's fast-paced digital world, it's essential for business to ensure that their mission-critical systems and applications are always available and accessible. Downtime, whether caused by hardware failures, software errors, or natural disasters, can have significant financial and reputational costs. That's why businesses need to implement strategies that ensure high availability, fault tolerance, and disaster recovery. High availability, or HA, is a characteristic of a system that aims to provide an agreed level of operational performance, usually uptime, for a period longer than normal. Highly available systems are designed to minimize or eliminate downtime caused by hardware or software failures, network interruptions, or other problems. The primary goal of high availability is to ensure the critical systems and applications are always available to end users, even in the event of a failure. To achieve high availability, businesses typically use redundant hardware, software, and network components such as servers, storage devices, switches, and routers. These components are configured in such a way that ensure that if one component fails, the other components automatically takes control, with minimal or no interference from end users. High availability systems also include monitoring and alert mechanisms that notify IT staff of any issues or potential failures, allowing them to take corrective actions before a downtime occurs. Fault tolerance is a measure of a system's ability to continue operating in the event of component failure, without any impact on end users. Unlike high availability, which is focused on minimizing downtime, fault tolerance aims to eliminate downtime altogether. Fault tolerance systems are designed to automatically detect failures and switch to redundant components without any interruption in operation. To achieve fault tolerance, businesses typically use hardware and software redundancy, including RAID arrays, dual power supplies, and redundant network connections. Fault tolerance systems also use a grouping or load balancing techniques to distribute the workload across multiple servers so that if one server fails, the other can continue to work without any downtime. Disaster recovery is a measure of a system ability to recover from a catastrophic events such as fire, flood, or earthquake that renders the primary data center unusable. Disaster recovery is focused on ensuring that critical systems and applications can be fully operational as quickly as possible with minimal data loss. To achieve disaster recovery, businesses typically employ a backup and recovery strategy that includes off-site backups, replication to a secondary data center, or cloud-based disaster recovery solutions. These solutions provide businesses with the ability to quickly rebuild critical systems and applications without relying on on-premises infrastructure. There may be some similarities between high availability, fault tolerance, and disaster recovery in the way that they are designed to ensure the critical systems and applications are always available. But there are also differences in their approaches and goals. High availability and fault tolerance focus on minimizing downtime and ensuring continuous operation, while disaster recovery focuses on rebuilding operation after a catastrophic event. High availability and fault tolerance require redundancy and overcoming mechanism to minimize downtime, which disaster recovery requires backups and replication to a secondary location or cloud infrastructure to ensure data availability in the event of disaster. High availability and fault tolerance are primary hardware-based solutions, while disaster recovery is often software-based. In conclusion, businesses must carefully consider their needs and requirements when choosing between high availability, fault tolerance, and disaster recovery solutions. While all three strategies are critical for ensuring the availability and accessibility of critical systems and applications, they differ in their approach and goals. By understanding the differences and benefits of these strategies, businesses can make informed decisions and implement the right solution to meet their needs. Scalability and elasticity are big words in cloud computing, and they are not twins, although they are often used interchangeably. When we talk about scalability, we are talking about the ability of your cloud services to grow with you. You plan for it, ensuring that your technology can handle the extra load as your business or project grows, whether it's data storage, processing power, or customer traffic. Elasticity, on the other hand, depends on flexibility. It's the cloud way of saying "I've got you," adapting to your needs in real time. Elasticity allows you and your cloud services to expand instantly to cope with traffic spikes and then shrinks again when things cool down, ensuring that you don't pay more than you need. Scalability refers to increasing the capacity of a system to efficiently manage an increased workload. This includes either building on the capabilities of existing resources, like scaling, or incorporating additional resources for load scaling. An increase may include an increase in memory, processing power, or storage within the current settings. In contrast, scaling spreads tasks across multiple mechanisms of service, optimizing overall system performance and reliability without compromising speed or quality of service. Scalability ensures that your project management tools can grow and adapt as your project increases in complexity and size. Elasticity is the ability of a system to automatically adjust resources levels to suit the workloads it faces at any given time. This smart adaptation ensures that resources are well spent during quiet periods and can be managed during high demands. By automatically increasing or decreasing resources, elasticity helps maintain optimal performance without unnecessary cost, making it go-to for business dealing with unpredictable or changing workloads. Cloud agility describes the rapid provision of computing resources through the cloud. Therefore, adopting secure cloud services and controlling your IT infrastructure there to be enable faster application delivery and drive business agility is cloud agility. The benefits of using the cloud include the increased business value and agility that cloud computing provides. The ability to quickly develop, test, and run software applications in the constant context of cloud computing is commonly described as agility. They may focus on other issues such as security, monitoring, and analysis rather than delivery and resource management. Agile is often used in the context of cloud computing to describe the rapid development, testing, and launch of applications that drive corporate expansion in a rapidly evolving IT environment. Cloud computing is a major element in enterprises' quest for greater agility and provides companies with the means to foster agility. Enterprise can use cloud computing to significantly reduce the time it takes to provision and outsource IT infrastructure, accelerating the delivery of IT projects that are critical to increasing sales or reducing costs. Unlike setting up a physical server, which can take days or weeks, a cloud server can be ordered and configured in minutes. Time to market is directly correlated with time to revenue. If you're trying to decide between using CapEx financing for data centers or colocation versus using OpEx financing to move your infrastructure to the modern cloud, you need to watch this lesson carefully. Most businesses today will need some sort of online presence. Options used to be extremely limited and expensive, and in fact, until the last few decades, the only option was to build your own data center or collocate your server to an external data center. In the 21st century, cloud computing has become a viable option for all businesses. Cloud technology is now widely adopted by businesses of all types and sizes due to its performance, security, maturity, and surprising affordability. Businesses have two types of cost around infrastructure of cloud: CapEx or OpEx. CapEx financing or capital expenditure means spending funds on real estate and even purchasing infrastructure such as building a data center. CapEx financing, by its very nature, requires startup capital for these large purchases, which limits many organizations in building data centers. Capital expenditures are accounted for in payments for goods and services and recorded on the balance sheet. Capital expenditures are amortized as assets age. On the other hand, OpEx financing or operational expenses is an expense incurred during the course of doing businesses. Colocation and cloud computing fall into this category. This means that cloud computing and OpEx funding are intertwined compared to a CapEx funding. Operation expenses are recorded in the income statement. Cloud computing is an example of operating cost or OpEx. OpEx spend money on products or services such as electricity, payroll, marketing, and even paper and printer cartridges. Simply put, it is expensive. It is an expense that is necessary for the day-to-day operation of the business. When we start talking about operational expenses, there is another contrasting term in the background, which is CapEx, capital expenditure. CapEx, these are funds savings that businesses spend on acquiring, upgrading, and maintaining physical assets such as land, hardware, furniture, buildings, etc. We can also say that these are costs for long-term benefits. CapEx is also considered a negative investment because its value decreases over time. These costs will now not allow you to deduct from taxes, but we must recoup them over time. For example, I bought a machine A, and after 2 years it has to be replaced because the version is outdated, but A works fine. Now I have bought a new version, machine B. Since A here has to be replaced with B, even before machine A deducts itself from taxes, this leads to another negative investment by the company. So sometimes it is difficult to identify the real cost and value of assets for a company. On the other hand, OpEx or operational expenditure, this is spending money on products or services that will be used immediately. This is not an upfront cost. We pay for the products services that we use. Business expenses are full tax deductible and can be deducted from income. Operating expenses reflects the cost of doing businesses as the benefits and value are immediate and can be easily identified. If the operating costs are too high, we can quickly reduce consumption by switching to different products. This would be easy because we haven't invested much more. One of the main advantages of the cloud, that is OpEx, is that there is no need for long-term investments. If the infrastructure requirements are reduced between the time you buy the hardware and the time the hardware reaches the end of its life, then we are going to end up with a lot of negative investments. Thus, with the help of the cloud, we can eliminate the need to purchase infrastructure by choosing the appropriate service model. We can increase or decrease resources at any time. Another advantage is that OpEx is completely tax-free from the same year we bought it. When you compare CapEx or OpEx for cloud computing, a private cloud funded by OpEx is the best option for most companies, especially during turbulent times. This can save your company money in the long run by not having to buy expensive servers and IT equipment or staff. It can also save money by not having to buy land to build your own data center. A private cloud is a great location to host your company's IT assets, and managed private cloud is a great option to consider when choosing the cost of a private cloud funded by OpEx. There are a large number of benefits that can offer us if a company or individual decided to move their businesses to the cloud. In this chapter, we will mention only a few, but it is impossible to write a complete list. Hardware savings. Most traditional system settings have a large hardware component as needed. These basically have a relatively large server which can often sit in a room dedicated to its accommodation. All this hardware costs money, but upfront in terms of purchase and over time in terms of maintenance. Electricity is required, as well as cooling, and this is becoming more and more expensive. Software savings. Also installation costs a considerable amount with frequently required modification to the building, and that space that the server requires can be taken up by something more productive for your businesses, so it's a higher cost. When you make a decision to go with cloud computing, all this physical equipment disappears, carrying with it all that financial outlay. On top of this, all the updates that your business will inevitably need are taken care of by your cloud provider, so that more money and hassle are saved. As I already mentioned, there is software savings. As with hardware, software needs to be updated. In fact, much more. These updates can be very costly for the internal system, but this area can be one of the biggest financial benefits of cloud computing. In addition to those savings, your business will enjoy additional benefits such as immediate and direct employees' access to all the necessary software, which means savings in terms of fewer printed copies required. Software is becoming more and more important, coming into more and more productive areas as the Internet of Things grows rapidly. IoT software development will consequently be a larger and more expensive area when you need to stay on top. If you can rely on another body to take care of this for you, so much the better. Finally, the most importantly, you must have a support, and they are met 24/7 365 via email, instant messaging, even Microsoft Voice, so downtime is minimized. Expensive software technicians should not be kept on the payroll, which is a significant financial savings. It is precisely because of the savings it enables, as well as other advantages, that SaaS is showing such remarkable growth. Pay-as-you-go, both hardware and software service can be delivered on a pay-as-you-go basis. This is of great benefits to business, easing the burden of buying equipment and software in bulk. An additional advantage here is that you will often only pay the amount used, that is, you will have coverage that is adapted to the size of your business. What's more, if there are aspects of the service that you don't use, you can usually choose to discard the part of the package with little waiting time. For example, small business phone service providers will offer packages that differ in content from large business service providers, and will give customers a range of options from the basic chat, text and meeting package upwards. Energy saving. Electricity is expensive and prices are rising. Why pay to power a room full of energy-hungry equipment when you can transfer all of this to the cloud? Using a cloud-based system makes sense from an energy purchase perspective and from an environmental perspective. The multi-client security model results in lower energy cost per unit, thanks to economies of scale. Your business will benefit from these savings. When it comes to the environment, cloud-based services can be beneficial. In-house servers are underutilized and inefficient. Cloud-based services are usually adapt and anticipating demand, so they are optimized for peaks. This results in a more efficient use of energy and consequently a greener profile. Imagine if all free videos were stored on a multitude of local servers across the country. Now visualize all the energy that would have to go into powering and cooling those servers. Now consider a single cloud-based server that delivers those videos to a large number of customers. That's green thinking. Reduce manpower costs. As mentioned earlier, when you start using cloud-based systems, you need to retain IT professionals. On your staff is immediately eliminated. Software and hardware specialists are expensive to keep on the payroll. They have to go through training to stay at the top of their game. This may include the additional cost of bringing in other professionals. The whole thing can be a huge financial outlay because IT specialists are not cheap. This is an overview of the situation in the world. For many businesses, staff is a huge expense. A call center, for example, depends on a high level of staff to provide services. A hosted contact center service will enjoy reduced cost thanks to the fact that it will eliminate the need for a technical department full of the brim expensive cable specialists and who knows what else. No cabling, no cost. Better data storage. The use of cloud computing and cloud integration means a higher level of data security. That's because cloud-based service providers are security professionals. They will use the most comprehensive and up-to-date security solutions. What are the financial advantages of cloud computing? By protecting your businesses from ever-increasing costs that make you need to stay on top of data breach threats. Data breaches are costing US companies more than ever before. In 2022, the average cost of a data breach rose to $4.35 million. Of course, the cost of your business reputation is immeasurable. All of this careful cultivation of customer confidence was blown away at a careless moment. As the volume of customer data that your business accumulates grows and the need of compliance becomes more severe, the need to be aware of the increasing range is intersections where data is shared, such as touchpoints in the customer journey. If you allow cloud computer to help with this, your life will be made easier at all. Increase productivity. By increasing your company's collaborative potential, your cost in relation to productivity will decrease. A cloud-based system will provide the same service to all staff no matter where they are located. This means that your business can benefit from teams working all over the world, using the same system and the same data. This applies to a number of business models. For example, when an e-commerce operation is considering how to set up an affiliate program, it's worth considering how a cloud-based system will allow affiliates to have a greater potential to collaborate with the business and with each other. This is because cloud-based services are more adapted for use by remote elements. Also, when it comes to installing new software by modernizing application in the cloud, it can happen throughout the company in a matter of hours. In a house system can take days, and all the problems that arise must be solved by you and your IT experts. With the cloud-based systems, problems need to be solved by the service provider. Better scaling. As your business grows, you need to know that the system it uses will grow in capability accordingly. If you purchase an internal system, you may not find that you outgrow its capacity relatively quickly. This is followed by expensive and wasteful discarding and replacements. With a cloud-based service, your growing needs are met by a truly resilient and adaptable business assistant provider. This will lead to your business paying for a system that is set up at the right level, rather than struggling to keep up with your company's growth and not too big for your needs. You also won't have to rely on uneven and unreliable growth forecast. Just upgrade your service when needed. You can also temporarily increase the size to meet short-term peak levels of demand. Disaster recovery. It's not pleasant to think about it, but sooner or later your business will no doubt experience some kind of data-related disaster. When this happens, you will have to significant costs. Cost in terms of the help of IT specialists. If the data requires a lot of updating, your IT staff will have to devote their resources to this task, at the expense of other areas that are their daily duties, such as maintenance, staff training, etc. Cost in terms of downtime. Imagine that all profits disappears while your business lies affected. And think of your competitors who descend to steal your customers with all the joy of hungry predators. By using cloud-based systems, your business will have access to better data recovery service than in a conventional on-premise system. Another advantage is that a cloud-based system will be able to route user traffic more efficiently to avoid problems in one specific sector of your business. Facilitation of testing. Using cloud-based services make testing new procedures much easier, simpler and cheaper. Testing such as data analysis is easier to perform in a cloud-based system. For example, cloud computing gives them the ability to test a new platform before actually implementing it. This helps to establish reliability in a secure format that protects the company from any unintended consequences. Consumption-based pricing, also called pay-as-you-go, custom billing, or usage-based pricing, refers to a pricing model in which the price of a product or service is determined based on the use or consumption of that product or service. In this model, customers are only charged for what they actually use rather than a fixed or predetermined fee. Consumption-based pricing has become popular due to its flexibility and cost-effectiveness in a variety of industries. It offers businesses and customers a more transparent and equitable approach to collection, as they are charged according to their specific use. In this pricing model, businesses track and quantify the use of consumption of a product or a service by their customer. This is usually done through measurement of or tracking systems that collect data on the amount of resources used of their or service consumed. This usage data is then used to calculate the corresponding cost. Cloud service providers often use consumption-based pricing model to charge customers based on the amount of resources they use, such as storage space, computing power, or data transfer. This module allows users to scale their usage as needed and pay only for the resources they consume. Software as a service, for example, many SaaS companies offer subscription-based pricing where customers pay a recurring fee based on the number of users or features included in the plan. However, some SaaS providers have begun to adopt consumption-based pricing models, allowing customers to pay for the exact amount of services they use. This model can be especially useful for customers with variable levels of use. Also, utilities such as electricity, water, or gas suppliers have been using consumption-based pricing for years. Customers are charged based on their actual usage, promoting efficient use of resources and allowing users to have control over their accounts. Some telecommunications providers apply usage-based pricing for data usage or voice calls. This allows customers to pay based on their actual spending rather than predetermined plans or package. The IoT or Internet of Things industry often adopts consumption-based pricing model as devices within the IoT ecosystem generate data that needs to be processed, stored, and transmitted. By charging customers based on their data usage, IoT service providers can align cost with usage and provide more flexibility for customers. These are just a few examples of industry and sectors where consumption-based pricing is applied. The flexibility of this pricing model makes it suitable for businesses that want to align cost with actual usage and provide their customers with more customized pricing options. I will also mention a few benefits of the consumption model. First one is improved customer retention. Consumption-based pricing allows customers to dynamically adjust their spending based on their needs, any budget, which can increase customer satisfaction and improve retention. By accurately measuring and charging customers for using their products or services, businesses can minimize revenue leakage and optimize their pricing strategies. Consumption pricing gives customers the freedom of experiment and testing different combinations and revenue and pricing models that are repeated. This pricing model creates an approach focused on partnership between the seller and his customer, aligning their interest toward achieving customer success. Consumption-based pricing can challenge businesses to anticipate and stabilize their revenue streams. Since customers are charged based on usage, revenue can vary based on consumer spending patterns. This uncertainty can make financial planning and forecasting difficult for businesses. Implementing and managing consumption-based pricing can be complex, especially when multiple variables need to be taken into account, such as scope of use, tiers, and different pricing models. Determining the right pricing structure and accurately tracking usage can be challenging for businesses. For some customers, consumption-based pricing model may be unpredictable or difficult to understand, leading to concerns about fairness and trust. Businesses need to ensure transparency in their pricing methodology and provide clear communication to build trust with their customers. Consumption-based pricing often requires businesses to have the right infrastructure in place to accurately track and measure usage, scaling and tracking and billing system to handle potentially large amounts of usage. Data can introduce complexity and require investments in technology and resources. Usage-based pricing can lead to lower profit margins, especially if there are significant fluctuations in customer spending. Businesses should carefully monitor and manage their costs to ensure profitability and avoid taking on new customers that are not economically viable to use. Consumption pricing models can encourage customers to focus on optimizing usage to minimize cost. This can lead to customers actively looking for ways to reduce usage, which can inadvertently reduce revenue for the business. As AI continues to grow, more and more companies are adopting consumption-based pricing models to monetize their AI services. One emerging trend is the use of the machine learning to help businesses understand how customers use their products or services and then adjust prices accordingly. The shift of cloud-based IT infrastructure is also driving the adoption of consumption-based pricing models, allowing businesses to move away from large capital expenditures and instead pay for services as they use them. Consumption-based pricing finds a variety of applications in a variety of industries, offering benefits such as improved customer retention, revenue optimization, and financial efficiency. However, it presents challenges such as predictability issues, pricing complexity, and concern about customer perception and trust. As businesses face these challenges, current trends point to increasing adoption of consumption-based models, driven to the rise of AI services into the shift of cloud-based IT infrastructure. The changing requirements suggest continuous exploration and innovative approaches, such as using machine learning to adjust prices based on customer usage patterns. Traditionally, before cloud computing came on the scene, most organizations had to build internal server rooms to run their networks and software. These servers cost a huge amount of money to acquire, maintain, and secure. The internal server handled all the organization's data computing needs, from email management to the various software subscriptions that the company had acquired. Cloud computing, on the other hand, eliminates the need for internal servers and server rooms by allowing you to access remote servers that house your networks and software. You only need to pay for cloud computing services that cover all of your computing requirements instead of paying for a server room. Most cloud computing services offer a wide range of tools at a fraction of the cost because they can split the cost among their different clients. IaaS, PaaS, and SaaS as a part of cloud computing. Computing is a generic term for what is a really complex concept. It's the same with cloud computing. Cloud computing can be divided into three basic subcategories. Infrastructure as a service, or IaaS. You place your entire network infrastructure on remote servers. This can include virtual machine and storage space for your application and data. Platform as a service, or PaaS, where a certain portion of your IT infrastructure is outsourced to a service provider to gain access to greater computing capacity. Software as a service, or SaaS. You get access to specific software without having to update the software. The vendor deals with upgrades, maintenance, and other issues related to the software itself. IaaS, PaaS, and SaaS are examples of cloud computing where different parts of your IT infrastructure are hosted on the server clouds located in remote location. Now that you have a basic understanding of cloud computing, IaaS, SaaS, and PaaS, let's take a closer look of these subcategories. First, infrastructure as a service, or IaaS. Traditionally, organizations had to construct and deploy these huge servers at the local level that could support their IT infrastructure. Modern server costs are estimated at $1,500 per month for a single rack, not counting the cost of human resources for the maintenance of these servers. The idea is simple. Instead of getting your own servers, you rent servers in a remote location that are maintained by your service provider. The entire IT infrastructure is housed on these servers with state-of-the-art security and multiple protocols that make sure your network never go down as a service. IaaS. Traditionally, organizations had to construct and deploy these huge servers at the local level that could support their IT infrastructure. Modern servers costs are estimated at $1,050 per month for a single rack, not counting the cost of human resources for the maintenance of these servers. Let's take a look at some benefits of IaaS. Performance improvement. Your chosen cloud service provider will, of course, have a multiple and much more robust infrastructure than what you could afford. The industry standard is that you have redundancy rates up to 99% to make sure your networks never break down and that the host is constantly investing in improving their technology and hiring experts to maintaining your servers. There are fewer problems in functionality, and you also get more data processing power due to infrastructure superiority. Since your network can process data much faster, you can use better software, work more efficiently, and make decisions much faster than your competitors. If you're working with private servers, you can expect far more efficiency improvements than you thought possible. Scalability is much easier. As you grow and expand your business, you need access to more infrastructure resources than before. Instead of getting more hardware for an internal server room, you can ask your service provider for more server space than before. This is a far more cost-effective model than expanding your own server capacity, which also takes less time. The flexibility offered by IaaS is unparalleled and allows you to change scales with much more fluidity than expanding the interior space. It is a great advantage to have someone with the space and capacity that will allow you to expand your organization network infrastructure without too many problems that arise in the process. If that wasn't obvious enough, using IaaS is much more cost-effective method of setting up IT infrastructure than investing in your own servers. Service providers have enough space to spread their cost between each of their clients in order to reduce the financial burden of setting up and maintaining server rooms. Let's talk about platform as a service. You can think of PaaS, or platform as a service, as a kind of specialization within an IaaS model, where IaaS only gives you access to servers that you can use as you wish. The PaaS model gives you access to all of the computer frameworks, hardware, software, tools, and everything. The purpose of PaaS is to help ease the application development lifecycle from prototype development, testing process, all the way to application deployment and scaling. You have all the tools you need to complete it. Most PaaS models are also equipped with licensed software and tools that you need to complete it. For all kinds of work, of course. Common PaaS applications include application development, business analytics, and more. Think of it as a ready-to-handle environment with built-in tools to help you complete your projects without the hassle of building one yourself like you would with IaaS. Benefits of PaaS include short time to market, since you don't have to manage the licensing of the tool or the maintenance of the server. You can immediately move on to the completion of various projects. The service provider will take full responsibility for the maintenance and operation of your systems, while providing you with the access to licensed analytics and development tools. You just have to focus on making sure that your projects meet the stipulated deadlines. With the elimination of logical uncertainties and access to a server that can process huge amounts of information, you can expect greater productivity and efficiency. This shortens the lead time and accelerates the development lifecycle for a shorter time to market. It also reduces development cost. There are no resources that you will have to pay for in full because all services are covered by the cost you will pay as a part of your package. Even expanding the space of your server or getting new tools is more affordable compared to working with internal servers. This can significantly reduce your overall development costs. Cross-platform development is easier. One of the main benefits of PaaS is access to tools that help you develop apps for different platforms at the same time, whether you want to develop applications for mobile devices, computers, different operating systems, or other types of devices. It's much more easier to develop them through PaaS than through your own servers. Unleashes internal sources. There are many organizations that use PaaS solely for development or to run business analytics. This allows them to maintain internal servers that they dedicate to their day-to-day work while devoting application development only to the servers they have hired through PaaS. This reduces the pressure on your internal hardware and resources to run two streamlined workflows in parallel without any delays. And the last one is software as a service, or SaaS. Software as a service is the ultimate type of cloud computing that focuses on delivering applications rather than application development or IT infrastructure. The most common SaaS application, as mentioned earlier, is Netflix, which operates on a subscription-based model, whereby Netflix subscriber can access the app over the internet on their personal devices in exchange for monthly payments. This does not necessarily mean that you, as the creator of the application, can use this model to deliver your application. Instead, your service provider may give you access to cloud application on their servers. Licensing fees are covered as part of your subscription and generally less expensive than just getting licenses, which is why many organizations use SaaS instead of getting their own subscription. The advantage of SaaS include automatic updates. Your service provider will manage all updates and will make sure that software continues to work without your intervention. All you have to do is to keep track of your payments, and host will take care of the rest. Some service providers even offer training of how to use the software to its full potential. Cost advantages and flexibility. Your service provider will charge you a fraction of the cost you would have to pay if you had a subscription yourself. A server owner typically invests in group subscriptions that are shared between customers and even allows you to scale up to acquire new functionalities as your organization grows without much additional cost. Shorter time to benefit. Service providers pre-configure all software depending on what functions they need to give you. Ready-made software equipped only with those tools that you will need. This makes it easy to integrate your software so that it becomes part of your workflows. In the conclusion, IaaS, PaaS, and SaaS are all great alternatives to getting your own service and subscriptions. Low cost, ease of integration, greater flexibility and reliability of working with remote servers give us a greater degree of freedom and efficiency compared to internal servers. Given the potential of the cloud computing and the various outsourcing options associated with it, it should come as no surprise that IaaS, SaaS, and PaaS have become commonplace in the average user's world. Cloud security is critical for organizations to protect their business data, reduce data theft, and meet compliance requirements. To protect your data in the cloud, including Microsoft Azure, you need to consider a shared responsibility model where the cloud providers perform some security tasks while the client manages all others. These tasks vary depending on whether the hosted workload is deployed using software as a service or SaaS, platform as a service, PaaS, or infrastructure as a service, IaaS. The shared responsibility model is a cloud security framework that describes the security obligations and responsibilities of cloud vendors and customers to ensure accountability. In this arrangement, cloud providers are responsible for cloud security while clients take care of cloud security. For example, when customers run their workloads on Azure Virtual Machine or VM, Microsoft provides the underlying computing service infrastructure, including the hypervisor, server hardware, and physical objects. Users are responsible for updating guest operating system and deployment security patches. Simply put, cloud security is a shared responsibility between cloud providers and customers. For all types of cloud deployments, you own your data and identities. You are responsible for protecting the security of your data and identity, on-premises resources, and cloud components that you control. The cloud components that you control vary depending on the type of service. Regardless of the type of application, you have the following responsibility: data, endpoints, account, and access management. The cloud offers significant advantage for solving long-standing information security challenges. In an on-premises environment, organizations are likely to have unfulfilled responsibilities and limited resources available to invest in security, creating an environment where attackers can exploit vulnerabilities at all levels. In a cloud-enabled approach, you are also able to deploy cloud-based security capabilities for greater efficiency and use cloud intelligence to improve threat detection and response times. By shifting responsibilities to a cloud provider, organizations can gain greater security coverage, allowing them to relocate security resources and budget to other business priorities. Responsibilities towards SaaS. In SaaS application, for example, Exchange Online, SharePoint Online, or Teams, Microsoft is responsible for securing the application and network control, operating system, physical host, physical networks, and the physical data center. In contrast, users are responsible for information and data classification, device security, and account and identities, for example, password complexity and multi-factor authentication or MFA. In addition, Microsoft and customers share this responsibility for identity and infrastructure of the directory. To illustrate, let's make the example of MFA. Microsoft ensured that MFA service is up and running, while clients are responsible for enabling MFA for users. As a result, healthy and adaptable MFA policies that apply to Microsoft Entra ID customers will ensure secure access to business, application, and data. Responsibilities to PaaS. In a PaaS application, for example, Azure SQL or web apps, Microsoft manages the security of the operating system, physical host, physical networks, and the physical data center. Users are responsible for the classification of information and data, device security, accounts, and identities. The common responsibilities of a PaaS include directory, identity and infrastructure, applications, and network controls. For example, Azure SQL users have granular control over identity, security, and access. Azure SQL clients can also configure allowed and restricted networks. Responsibilities to IaaS. In an IaaS application, for example Azure VM, customer security responsibilities increase and include 7 of 10 responsibilities defined in Microsoft Shared Responsibility model. Microsoft is only responsible for securing the physical host, networks, and data centers. Users are responsible for securing the operating system, network control, applications, directory identity and infrastructure, accounts and identity, devices and information, and security. Shared responsibilities for all types of services. In all SaaS, PaaS, and IaaS implementations, Microsoft is always responsible for securing the physical layer of the service. Microsoft is dedicated to the security of physical host, networks, and data centers. Similarly, in SaaS, PaaS, and IaaS implementations, customers are always responsible for securing data and identity. In other words, customers ensure the information, data, devices, accounts, and identities are secure. In the table in front of your screen, you can see the division of responsibilities by on-premise, IaaS, PaaS, and SaaS, which is responsibility and what is Microsoft responsibility, what is your as a customer, and what is a shared responsibility. Now that we learn most of the basics of cloud computing, it's time to get acquainted with deployment models. Cloud deployment models define how cloud services are delivered, managed, and accessed. The choice of model affects the flexibility of your organization, cost, efficiency, and security position. With global cloud spending expected to exceed $500 billion by 2027, it's critical to make informed decisions about which model best suits your needs. First is public cloud. The public cloud is the most widely accepted deployment model where services over Internet are provided by third-party providers such as Amazon Web Service or AWS, Microsoft Azure, and Google Cloud. These services are shared across multiple organizations, making the public cloud an ideal choice for businesses looking for scalability and cost effectiveness. Key features: scalability. Public clouds offer virtually unlimited scalability, allowing businesses to quickly expand or contract resources in response to changing demands. Cost effectiveness. With a pay-as-you-go model, public clouds reduce capital expenditure, allowing businesses to optimize cost based on actual usage. Maintenance free. A cloud provider manages all maintenance, updates, security, allowing organizations to focus on their core business activities. A recent study by Gartner found that 80% of organizations that adopted the public cloud achieved significant saving in the first year. Public clouds are ideal for organizations that want to implement scalable, cost-effective solutions with minimal management costs. Common use cases include web hosting, SaaS applications, and development environments. A private cloud is a cloud environment dedicated exclusively to a single organization. The infrastructure can be hosted on premises or managed by a third-party provider, offering enhanced control and security. Key features is I already said enhanced security. With dedicated resources, private cloud provides a higher level of security and compliance, making them suitable for industries with stringent regulatory requirements. Customization. Private clouds offer greater flexibility in configuring resources and services to meet specific business needs. And control. Organizations maintain full control over cloud environment, including data management, security policies, and infrastructure management. IDC reports that 70% of large enterprises have adopted private cloud solutions to meet stringent compliance and security requirements. Private clouds are typically used by large enterprises, financial institutions, healthcare professionals, and government agencies that require a high level of control, customization, and security. Then we have a hybrid cloud. A hybrid cloud combines elements of a public and private cloud, allowing organizations to take advantage of both. This model provides flexibility, allowing data and applications to be shared between environments based on business needs. Key features is flexibility. Hybrid clouds allow organizations to store sensitive data and critical workloads in a private cloud while using the public cloud for less critical operations. Scalability with control. Enterprises can scale resources in the public cloud while maintaining control over core operations in the private cloud. Seamless integration. Hybrid cloud environments can integrate seamlessly with existing IT infrastructure, providing a balanced approach to cloud adoption. Flexa report shows that 92% of enterprises have adopted a multi-cloud strategy, with hybrid cloud being a key component. Hybrid clouds are ideal for organizations that require the scalability of public clouds but need to maintain control over certain operations. Typical use cases include disaster recovery, data archiving, and application with available workloads. And the last one is community cloud. A community cloud is a collaborative cloud environment shared by several organizations with common goals of regulatory requirements. This model is often used by industries with common interests, such as financial services, healthcare, or government. Key features. In the community cloud, you have shared infrastructure. Community clouds allow multiple organizations to share resources, reducing cost while adhering to industry-specific regulations. Collaboration. Organizations within the same industry can collaborate more efficiently by sharing data, applications, and services in the community cloud. Compliance. Community clouds are often designed to meet specific compliance standards, making them ideal for regulatory industries. According to Deloitte survey, 58% of healthcare organizations are using clouds in the community to improve and meet regulatory standards. Community clouds are suitable for organizations in highly regulated industries that need to collaborate while maintaining compliance. Common use cases include research collaboration, health data sharing, and government services. Choosing the right cloud deployment model is more than a technical decision. It is a strategic choice that affects the agility, security, and long-term growth of your organization. Whether you are learning toward public cloud scalability, private cloud control, hybrid model flexibility, or the collaboration offered by community cloud, each options offer different benefits. As the cloud adoption continues to accelerate, understanding these deployment models will position your business to harness the full potential of the cloud. Azure has a number of different pricing tiers. Don't worry about cost when you get started. Azure offers a free tier for the first 12 months, although the tools you can access are limited. This gives you a risk-free opportunity to explore Azure and see if it's a good fit for your needs. Azure offers a variety of pricing models, including pay-as-you-go, spot pricing, and reserve instances. These options give you the flexibility to expand your tools and cloud storage as needed, while still allowing you to commit to a fractional price. Azure also breaks down prices depending on the service you need, with specific pricing models for VM, features, networking, and storage. Azure has two free tiers, a 12-month tier and a 30-day free tier. Some devices are free for an indefinite period of time. Some services are free, so we will mention them. Development services like Azure App Service, Azure DevOps Service, Dev Test Labs, messaging, routing and automation like Event Grid, Azure Automation or Load Balancer, data management and search, Data Factory Catalog and Azure Search, networkings, inbound data transfer that is infinite and outbound data transfer up to 15 gigabytes, virtual networks and traffic between virtual networks, serverless and containers, Service Fabric, Azure Container Instances, AKS, Azure Functions up to 1 million free requests. The first free offer allows you to use a more limited set of services for 12 months. However, make sure to stay within the service limits for each of these services. Otherwise, you will charge a fee. For example, you can only use Windows VM for 750 hours. Service limits are the maximum number of resources or operations that you can use in a subscription. These can be hard limits, which means you can exceed them, or soft limits, which means you can request an increase in the limit. Services that you can use for free for 12 months include computer services, Windows and Linux VMs, database services like SQL and Cosmos DB, storage services, Azure Managed Disk, Blob Storage and Azure Files, some IE and analytical services. The second free offer allows you to try all the services that are not offered as a part for free services. If you exceeded the service limits for the first free tier, Azure will provide you with $200 credit that will be deducted from your first monthly bill. Be careful when using these free services. You will be charged if you use any offer outside of this list. For example, if you're using Azure Kubernetes Service or AKS but want to deploy the containers, you will be charged for VMs and container instances that are deployed. Azure pay-as-you-go model allows customers to pay as they use the product. This means that you are charged for the services you use all the way to the other. So there is no need to worry about long-term commitment or paying for services you don't use. This might be appealing if you have to commit to the product. It also allows you to increase or decrease as needed, which means you can increase or decrease that use of Azure services based on your needs. This makes it an ideal option for handling unpredictable workloads or when you're not sure how much capacity you need. With spot pricing, you can buy unused computing power, sometimes up to 90% discount compared to the price paid. But this comes with the uncertainty that the spots are often interrupted at short notice. You should only consider this option if your project can tolerate interruptions. Reserved virtual machine instances, or RVMI, are pre-purchased region-specific virtual machines that last for 1 to 3 years. For a longer commitment, you'll get up to 72% of Azure pay-as-you-go pricing. You can replace or cancel reserved instances before the deadline, although a cancellation fee will be charged for the later. If your organization knows what Azure services it needs and in what amounts and has set a budget, this option is probably best for you. There are a lot of Azure services that you have yet to check out because we have only mentioned the most common. If you want to see more prices or search for different regions of the world, Azure keeps their prices up to date on their pages. If your organization has its own Microsoft license for your on-prem data center, Azure Hybrid is for you. It allows you to bring your own license, which means you can transfer your Windows Server or SQL Server licenses to the cloud. So, How does this get you discount? If you already have a Windows or SQL server and want to run an Azure VM, your server will track your Microsoft software licensing price and provide an hourly discount for the VM. This benefit applies to anyone using SQL Server VM, Windows Server VM, or Azure SQL Database Server. Depending on your version of Microsoft SQL Server or Windows Service, you can get up to 3 years of free security updates. No need to renew your license either. Azure invests a lot of saving in its offer, so you can control cost in Azure Cost Management, create a budget, use the Azure Price Calculator, Cost Analyzer, and several other tools that can significantly help you plan your cost in a potential move to a cloud environment. In this chapter, we will get acquainted with the concept of geography, regions, data centers, and pair regions. Azure geography or Azure geography is an area of the world that contains at least one Azure region. For example, India is geography, USA is geography. Similarly, the United States and the United Kingdom are geographic locations. As of this course, there are 60 regions and over 3,000 data centers, and that number is constantly growing. We also have a geography called Azure Government, and this geography is available only to federal, state, local, and tribal governments of the United States and their partners. It's not available for general use. Azure Government offers the broadest level of certification so that even the most critical government requirements are met. This geography is specifically for the use by the US government, so all of its operations are controlled by inspected and approved US citizens. Well, regulated data such as financial, health, or credit information may not be allowed to leave the country. Your organization is legally required to store such data in the same country in which operations are conducted. So, if you choose a geography such as UK, for example, Azure ensures that your data is not stored outside of UK. Similarly, if you select the United States, data remains within the States. You have the complete control over which geographic areas you want your data and applications to be applied. You can be assured that Microsoft will not store customer data outside of the geographic area you specified except for certain non-regional services. Simply put, Azure geography is an area of the world that contains one or more Azure regions. Azure region is a very important concept because every time you create an Azure resource, such as virtual machine for example, you need to specify the region in which you want the resource. In this case, the virtual machines to be created. An Azure region can be also paired with another Azure region, and there are several advantages to this pairing. An Azure region may also have an availability zone. An Azure region is a set of data centers that are connected over a dedicated network with low latency. How many data centers are in a region? We don't have a fixed number. That varies. There are regions of different sizes. A region can consist of only one data center or multiple data centers. The point is that an Azure region is a group of one or more Azure data center. An Azure data center is a single physical building that contains thousands of physical servers with their own power, cooling, and networking infrastructure. These data centers are located all over the world. As of November 2020, there are over 160 plus Azure data centers worldwide. These data centers are the building blocks of the global Azure infrastructure. You have the flexibility to deploy your applications and data to any Azure region you want. You can even deploy to multiple regions to provide resiliency to multiple regions. Resiliency is the ability of a software to respond to problems in one of its components and still provide the best possible service. Some regions are paired with another region, with both regions usually located in the same geopolitical area. Pairing regions provides resilience during catastrophic failures of the region. Region matching is mainly used for geo-redundant storage, GRS, and other services, Azure services that depend on Azure Storage for application. These are the simplest terms, and I did it with the intention of not confusing you. in the continuation of the course, but also in your learning and progression through cloud and Azure. You will get to know them and learn them in detail during the creation of resources, which you will be able to see through our demos. If you go to datacenters.microsoft.com, you have the option to see all or Azure data centers in the world. So you can explore the lobby and see how this data centers looks like. As you can see, you can see and watch a video of Microsoft data centers. Then you can check your cloud security. As you can see, cloud security is fundamental to every aspect of Microsoft Global Data Center. And you can even take a free tour from one of the Microsoft data center. Then in this interactive video, which you can find on Microsoft website, you can also go directly and choose a quality of this video. You can also take a free tour or go to operation room, for example, right from here. And the operation room, as you can see, you can explore your operation room, and in this room Microsoft supports all necessary things to keep their data center working. You can use your keys to see how it looks like, but if you go on the global map of Microsoft data center, you can see where is they located and how they looks like. You can take a free tour, which we already see how can it looks like. Then you can view a map. You can even check a legend, filter all the regions and see for yourself how it looks like. But it depends where are you located, so you can choose whatever region you want. If you, for example, check our one of the data center, for example Japan East, you can see all necessary information with availability zones, where is located, what is data residency, when it's opened, and what is disaster recovery, and so on. There are 3 availability zones, as you can see, and this is a region with availability zones. Data residency, stored and rest in Japan. Now you can see all details for all data centers and in all regions. Also you can filter a region and check more in more detail, and you can check this legend and check geographies. These blue dots are regions, as you can see. Then you can check for networking, where is point of presence network, where is WAN links, for example, and you can check sustainable projects like wind, solar energy, and so on. So Microsoft takes care of everything. So the big part is ecological presence in their data center. And then you can check this geography and regional pair A and B and see the whole list of this data center. For example, in Asia Pacific, our regional pair A is East Asia, Hong Kong Special Administrative Region, and region pair is Southeast Asia, which is located in Singapore, for example. Then we have Australia East, regional pair is Australia Southeast, and the only is Brazil Southeast, Brazil South, sorry, and South Central US. This is the only regional pair where it is not located in the same region or the same geography. So you need to take care on this information and remember this information for your exam. Also, this is something called pair regions, and you can check Azure cross-region replication. This is very important when you're working with data. So you can see that you have East US, West US, East US 2 with Central US 2, and then there is US Department of Defense and US government, which are not Azure Commercials region. As you can see, US Department of Defense East and pair region is US Department of Defense Central. So this is how can you learn everything about this chapter. Once we define the terms, it's time to get acquainted with others, such as availability zones, resource groups, Azure Resource Manager, subscription, group management, etc. So let's start in order. Azure availability zones are physically and logically separated data centers with their own independent power, source, network and cooling. Connected to a network with extremely low latency, they become the building block for delivering high availability applications. Many Azure regions provide availability zones, which are separate groups of data centers within a region. Availability zones are close enough to have low latency relationship with other availability zones. They are connected by a high performance network with a return latency of less than 2 milliseconds. However, availability zones are far enough apart to reduce the likelihood that more than one zone will be affected by logical outages or weather. Availability zones have independent power, cooling and networking infrastructure. They are designed so that if one zone experiences an outage, the remaining zones support regional services, capacity and high availability. They help keep your data in sync and accessible when things go wrong. Data centers locations are selected using rigorous criteria to assess vulnerability risk. This process identifies any significant risk specific to the data center and takes into account common risk between availability zones. When you deploy to an Azure region that contains availability zone, you can use multiple availability zones together. By using multiple availability zones, you can store separate copies of your application and data within separate physical data centers in a large metropolis. There are two ways what Azure services use availability zone. Zone resources are pinned to a specific availability zone, so you can combine multiple zonal deployments in different zones to meet high reliability requirements, and you're responsible for managing data replication and distributing requests across zones. If there is an outage in one availability zone, you are responsible for switching to another availability zone. Resources that are redundant in zones are distributed across multiple availability zones. Microsoft manages the propagation of requests across zones and the replication of data across zones. If there is an outage in a single availability zone, Microsoft automatically manages the fault rollover. Microsoft aims to deploy the updates for Azure services in a single availability zone at a time. This approach reduces the impact that updates can have on the active workload, as the workload can continue to run in other zones while the update is in progress. Setting up an availability zone for a resource is very easy. If I, for example, go to virtual machines and click on Create Azure Virtual Machine, I have an option to add availability zone. Here, as you can see, if you hover your mouse onto this little cloud, you can see that explanation that said you can optionally specify an availability zone in which you want to deploy your VM. You can choose, for example, to store this machine in zone 1, zone 2 or zone 3, or you can choose all 3 zones, as you can see. Based on your zone selection, Azure will place 3 virtual machines, one in each selected zones. Then you can uncheck these options, and if you go to zone option or availability zone option, you can choose between no infrastructure redundancy required. If I choose this option, there will be no option for zone available zones. Also, if I choose availability zone, you can physically separate your resources within an Azure region. There is self-selected zones. You can choose up to 3 availability zones that I'll already show you, or simply click on Azure selected zone. This is in preview, and Azure will assign the best zone for your needs. Also, there is something called virtual machine scale set and availability set, but just wanted to show you availability options for availability zone. Thank you for watching. A resource group is a logical container in which Azure resources such as web applications, databases, and storage accounts are deployed and managed. A resource group is a container that contains connected resources for an Azure solution. A resource group can include all resources for a solution or only those resources that you want to manage as a group. You decide how you want to allocate resources to a resource group based on what makes the most sense for your organization. In general, add resources that share the same life cycle to the same resource group so that you can easily deploy, update, and delete them as a group. The scope of a resource group is also used through the Azure portal to create views that span multiple resources, like Metrics Blade provides metric information like CPU resources to user, Blade deployments display the deployment history of ARM templates, or Bicep target as that resource group, which includes portal deployment. The policy label provides information related to the policies that apply to the resource group. Diagnostic settings, Blade provides the ability to diagnose errors or view alerts. A resource group stores metadata about resources. Therefore, when you specify the location for a resource group, you specify where the metadata is stored. For compliance reasons, you may need to ensure that your data is stored in a specific region. Note that the resources within a resource group can be of different regions. Resources are instances of Azure services that you create, such as virtual machine, application services, storage account, SQL databases, functional applications, and so on. These are all Azure services. Every time you create an instance of a service, you create a resource. There are hundreds of up-to-date services. You can see complete list of Azure services by going to portal.azure.com, all services. You need to log in to your Azure portal, otherwise you will be redirected to the login page. On the left, you can see services such as on your marketplace. You can see service categories such as general, compute, networking, storage, etc. For example, if you want to create a storage account for data storage, click on the storage category and you will see all the storage services. Each time you create a resource, you must also specify a resource group. There is a two-way how can you configure your resource group. One is you can go to resource group and click on create option. Then you will choose your subscription, add a resource group name, for example, let's add RG1, and choose your region. Then there is an option to add a tag if you want, but I won't add a tag. Let's go to click on review and create and simply click on create. And after some time, your resource group is created, as you can see in our notification. If I simply refresh this one, there soon will be my resource group. Let's try again, and here it is. Here is my new created resource group. Directly from here I can create a resource. Simply click on create and you can add a resource from the marketplace. The second one is if you, for example, go to virtual machine, click on create virtual machine, you can choose existing resource group or simply try to create a new one. You can add RG2 and click on OK, and this VM will be in your RG2. So you can do it directly from a resource or from here, choosing resource group, or from here, from this menu, choosing resource group. If I go to my resource group, I can now delete my RG1. Simply click on delete resource group. This resource group is empty, there is no resource here. Then I can copy the name of resource group, paste it here, and click on delete, and this resource group will be deleted. So Azure is deleting our resource group 1, and after some time, because we don't have any resource here, our resource group will be deleted. If I go back to our resource group, as you can see, we don't have any resource group RG1 that we created earlier because we just delete our resource group. Thank you for watching, and this is how can you create your resource group. Azure Resource Manager is a scheduling and management service for Azure. It provides a management layer that allows you to create, update, and delete resources in your Azure account. You can use management features such as access control, locks, and tags to secure and organize your resources after deployment. When you send a request through any of the Azure API, tools, or SDK, Resource Manager receives that request. It authenticates and authorizes the request before forwarding it to the appropriate Azure service. Because all requests are processed through the same API, you see consistent results and capabilities across all the different tools. Focus on the resource group. One of the key concepts of Azure Resource Manager is known as the resource group. A resource group, as you already know, is a logical container that contains associated resources for an application or a specific workload. ARM, or Azure Resource Manager, allows you to create and manage these groups, making it easy to organize, deploy, and monitor your resources, consistently add in a controlled manner. Declarative language. Azure ARM, or Azure Resource Manager, using a JSON-based declarative language to define the infrastructure and configuration of your resources. This means that you describe what you want your Azure resources to look like, and ARM takes care of the basic details of provisioning and managing, ensuring that your desired state is maintained. Azure Resource Manager plays a key role in centralized management within the Azure ecosystem. Acting as a centralized control hub, it facilitates seamless monitoring and resources synchronously. This approach simplifies the management of complex applications and different environments, simplifying the overall operational process. Azure Resource Manager also integrates with Azure Role-Based Access Control, or RBAC system. This integration allows organizations to exercise granular control over the management of resources within their Azure subscription. RBAC capabilities are critical in maintaining ARM security measures and ensuring compliance, especially in multi-user and multi-resource scenarios. Resource dependencies often came into play when it comes to complex multi-tier application in Azure. Azure Resource Manager takes a close look at these dependencies, ensures that resources are provisioned and updated in the correct order, thereby minimizing deployment errors and improving resource consistency. This careful handling of resource dependencies is valuable to ARM functionality. In the architecture of Resource Manager, the components and mechanisms at play are the building blocks that empower Azure Resource Management capabilities. Understanding these architectural elements is essential to unleashing the full potential of ARM and optimizing the deployment, management, and scalability of resources in the Azure cloud. So in this chapter, we will examine the architecture and components of Azure Resource Manager, exploring the inner features that makes it a cornerstone of effective cloud management and deployment. Resource providers. Azure Resource Manager relies on the resource providers, who are responsible for managing specific types of Azure resources, including virtual machines, storage, and networking. These providers connect to APIs that ARM uses to interact with manage those resources. Templates. ARM or Azure Resource Manager templates are JSON files that define the resources you want to deploy, their configurations, and any dependencies between them. Templates are a fundamental aspect of ARM's infrastructure as a code approach, allowing you to define your infrastructure in a consistent version-controlled manner. The Azure Resource Manager API is an interface through which users interact with ARM. IT managers can programmatically create and update and manage resources, resource group, and deployments. The API is available through the Azure portal, Azure PowerShell, Azure CLI, and various SDK. As we already seen, Azure Resource Manager serves as the backbone for managing Azure resources in one place, which is an essential role in the efficient orchestration of cloud operations. By functioning as a hub, ARM simplifies the deployment of management of a range of resources spread across different Azure subscriptions. ARM simplifies the process of creating, modifying, and deleting resources through a central dashboard, negating the need to navigate through a maze of different services and interfaces. This centralization brings multiple benefits, most notably improved operational efficiency. ARM significantly reduces the challenges of managing different resources by offering a standardized interface for a simpler approach to resource handling. What's more, it empowers control by ensuring the changes and operations are executed consistently and securely regardless of the specific resource type of Azure service. We will have a detailed introduction to Azure Resource Manager in the later part of the course when we'll get acquainted with ARM in detail. Microsoft provides a hierarchy of organizations, subscriptions, licenses, and user accounts for consistent use of identity and billing across its cloud offerings, like Microsoft 365 in Microsoft Office 365, Microsoft Azure, Microsoft Dynamics 365. An organization is a business that uses a Microsoft cloud offerings, which are typically identified by one or more public domain name, system domain names, DNS, such as contoso.com. An organization is a container for subscription. A subscription is an agreement with Microsoft for the use of one or more Microsoft cloud platforms or services, for which fees are calculated based on the per user license fee or the consumption of cloud-based resources. Microsoft Software as a Service or SaaS based cloud offerings like Microsoft 365 and Dynamics 365 charge per user license fees. Microsoft Platform as a Service, PaaS, and Infrastructure as a Service cloud Azure offerings are built based on cloud resource consumption. You can also use a trial subscription, but the subscription expires after a certain period of time or spending cost. Then you can convert a trial subscription to paid one. It links user account and resources created by those user accounts. Each subscription has limits or quotas on the amount of resources you can create and use. Organization can use subscription to manage cost and resources created by users, teams, or projects. Azure subscriptions are a logical unit of Azure services that are associated with an Azure account. To take advantage of Azure cloud-based services, you must have a subscription, as it serves as a single unit of account for the Azure resources used in that account. An Azure subscription associated with a single account is the one that was used to create the subscription and the one that is used for billing purposes. As a part of a subscription, resources can be provided an instance of many Azure products and services. You can have one then more subscription, often for billing purposes, because each subscription generates its own set of billing reports and invoices. the person who creates an Azure subscription becomes a global administrator for that subscription and has the full access to every aspect of that subscription. So separate subscriptions can also be a way to create a division of responsibilities for Azure services. The tenant represents the organization. It is a dedicated instance of the Microsoft Entra ID that an organization or application developer receives at the beginning of a relationship with Microsoft. If there are only a few subscriptions in your organization, then it's relatively easy to manage them independently. However, there are usually many employees in the organization and there be many applications. If all of these employees are provided with Azure subscription and if they start creating Azure resources at will, it can soon become difficult to control, manage, and keep track of who is creating what, and eventually costs can spiral out of control. Azure has 4 levels of management to organize, secure, manage, and track costs. The following lecture will make it clear. So, we have our top group of the hierarchy. All subscriptions in management group automatically inherit the terms or settings specified at the management group level. So the management group is like a container for all your subscriptions. Just as there can be multiple subscriptions, there also can be multiple management groups in an organization. Also, for whatever reason, let's say our organization that we want to allow Azure resources to be created only in the eastern region, for example in the United States. One simple way to do this is to create such policy at the level of the IT management group, for example, and this policy is then automatically applied to all management groups and subscriptions that are children of the IT management group. Descendants will not be able to change the security policy in any way. And it is also applicable to all resources under those subscriptions. Thus, obviously management becomes much easier. Management settings, such as policies and role-based access control, can be applied at any level of management. The level you choose determines how widely the setting is applied. Lower levels inherit settings from higher levels. For example, when you apply a policy to a subscription, then policy also applies to all resource groups and resources in that subscription. In general, it makes sense to apply critical settings at higher level and project-specific settings at lower levels. The subscription is located under the management group. It links user account and resources created by those user accounts. Each subscription has limits or quotas on the amount of resources you can create and use. Organization can use subscription to manage costs and resources created by users, teams, or projects. A resource group, as the name implies, is a group of connected Azure resources. It's basically a logical container where Azure resources such as web applications, databases, and storage accounts are deployed and managed. An Azure resource is any instance of a service that you create. For example, a virtual machine, Azure SQL database, a storage account, etc. I'm again in my Azure portal, and if you go to our search bar, you can search for management groups and simply click on management groups. Then, as you can see, this is my default directory. This is my management groups, and here I have, as you can see, I will type management groups, simply click on management groups, and then we are in our default directory. This is my tenant root group, and from this group I can manage with all subscriptions, create a new resource groups, or create new management groups, sorry. If I click on management groups, you can see that I have my Azure subscription. This is my only one and active resource group, Azure subscription, and then I can create a new management group, add new subscription, rename a group, and etc. If I go back and click on create, I can create a management group. First, I need to add management group ID that cannot be updated after this creation, and this management group will be a child of tenant root group. as you remember from our theoretical part. You can add whatever name you want, for example prod, and management group display name you have option to add, for example, production group. Let's click on submit, and we are updating our group. And after some time, if we check our notifications, we will see that we have new management group called production group, and this group is a part of our tenant group. If I go inside our production group, click on add subscription, I have option to move this existing subscription to a child group, and this is my group. If you have more than one subscription, you can choose that subscription, but we have only one. And if you update our subscription, you can see that our production group contains this Azure subscription that we just moved. If I go and create another new child management group, let's add, for example, development group. We can copy our display name to our management group name display. Let's add devs and development group here. Click on submit. We will have another new created group, but we need to be patient. And after some time, we have our development and prod group. If I go inside our development group, I can move my existing subscription. Simply click on that subscription, choose subscription that you want, and click on save or submit. And my Azure subscription 1 is now part of this development group. Let's go back to our tenant root group. Click on refresh, and Azure subscription is now part of my development group. You can see you can have this type ID of your management group. Also, you can add subscription or choose your subscription to move back to our tenant root group, and after that our only subscription is now part of our tenant root group. Also, you have option to delete management groups, and in the overview menu you can also see how many parent management groups, how many child management groups, or total subscription do you have for this tenant root group. Also, there is an ID that you can see for our tenant root group, Azure subscription 1, and devs and prod, and how many subscriptions does our group contains. If I go, for example, to our subscriptions, you can see subscription by Blade. Also, there is a resource group and the resources. You can check activity log. You can add a role-based access control to this tenant management group, for example, but we will talk more about RBAC later in this course. And then we have a lot of options here, as you can see, just like with anything with RBAC. And then you can even see a cost management, choose your policy here for this management group, and so on. Let's go back to overview, and now I can see these three dots here. You can move, create child group from here, add subscription here, or simply delete this development group. If I click here and add a name for our management group, this will be a child of development group. For example, you can add devs1 and click on submit, and this group will be child group of our development group, as you can see. Even then, you can move your subscription to that child group in development group. So you can do forth and back with these subscriptions, management group, child management groups, and resources and resource groups. Also, if I want, I can now move this again directly from these three dots, and I can also we already saw how can we create a child group from here, or go inside our development group, for example. And if we go to our devs group, we can delete our group right from here. Simply click on delete and click on yes, and we are deleting our devs1 group. Then if you go back to our development group and refresh our page, you can see that we don't have any child group for development group. If you refresh here, there is no our child group. Then we can delete our development group and we can delete our production group. So this is how can you work with management groups. It's very easy and very interesting to organize these groups in your organization. In addition to regular Azure regions, there are also sovereign regions designed specifically for government and entities that need a unified data protection environment. Sovereign regions include Azure Government in the United States, Azure China operated by 21 VNET, and Azure Germany. Each provides a physically isolated instance of Azure that ensures data residency in that country, compliance with on-premises requirements, and secure connectivity. The key differences between Azure sovereign regions include an independent network that is separate from the global Azure network, ensuring that data does not flow through the public internet. Certificates of conformity that meets the needs of the sovereign host country. Exclusive access to vetted staff who have passed background checks in accordance with the requirements of the region. Example, Azure Government provides service to US federal, state, local, and tribal government agencies with dedicated instance requirements and higher level of compliance. The choice between Azure regions, regional pairs, and sovereign regions will largely depend on the requirements of the business or application in terms of scalability, compliance, latency, and redundancy. Understanding the differences between these options allow organizations to make informed decisions about deploying and managing their cloud resources. Azure sovereign regions such as Azure Germany, for example, Azure China, and Azure Government are designed to serve customers with strict residency and data compliance requirements and are typically limited to those tenants. Compute is often encountered in modern computing concepts such as cloud computing and big data, which are used to refer to resources used or served in server and data center spaces. In assistive computing, as well as cloud computing and big data, the resources used to process data are referred to as computing resources provided by processors working together in clusters. Computing resources are essentially time maps that are given to those clients who need it so they can have access to the allocated CPU in the system. The partners of a computer resource are a memory resource, network resource, and I/O resource. All computer activities require a combination of the above with the computer as one of the most important and ubiquitous in any activity. Azure Compute is a set of cloud computing services provided by Microsoft Azure that offer scalable and flexible solutions for running applications and workloads in the cloud. It provides services such as virtual machine, containers, serverless computing, and batch processing to meet a wide range of computing requirements. Azure Compute enables customers to quickly provision, deploy, and manage virtualized instances, leading to better resource utilization and cost optimization. It offers high availability and application performance through built-in capabilities such as autoscaling, load balancing, and monitoring. It supports a variety of operating system, programming languages, and development frameworks, allowing for easy migration and development of application. Azure Compute enables organizations to innovate and scale their IT infrastructure, accelerating digital transformation and commercial growth in the cloud. The list of services that belongs to Azure Compute is quite large, and we will mention a few of them: virtual machine scale sets, Azure App Service, Azure Functions, Azure Container Instances, Azure Kubernetes Service, Azure Batch, and Azure Dedicated Host. Azure VM is a scalable computing solution provided by Microsoft. It allows users to create, manage virtual instances on Windows or Linux operating system in the cloud. They are available in a variety of sizes and configuration to meet a wide range of workloads requirements, including compute, memory, and storage. Users can easily provision, scale, and customize virtual machine based on the requirements of their application, ensuring optimal performance and cost effectiveness. Azure VMs enable organizations to quickly install and execute applications, extend on-premises infrastructure, and achieve seamless hybrid cloud integration. Azure Virtual Scale Sets allow us to automatically scale our application based on requirements. It is perfect for achieving higher availability and distributing workloads across numerous virtual machines. You can create scaling rules that automatically change the number of VM instances based on CPU, consumption, or other parameters. Scale Sets provides easy management and deployment of identical VMs, ensuring consistent performance and reliability. Scale Sets, which includes load balancing and health monitoring, help optimize resources utilization and improve application availability. Azure App Service is a platform as a service, or PaaS, offered for hosting web applications and APIs. It simplifies the process of deploying, managing, and scaling application by eliminating the need for infrastructure management. Azure App Service supports a variety of programming languages and frameworks including .NET, Java, Node.js, and PHP to meet a wide range of application development needs. It includes automatic scalability, continuous deployment, built-in monitoring, and connectivity to Azure DevOps to simplify application lifecycle management. Azure application is highly available and secure, providing consistent performance and compliance with industry requirements. It allows developers to focus on code while Azure manages the underlying infrastructure, making it an excellent choice for building and delivering modern web applications in the cloud. Azure Functions is a serverless computing solution that allows developers to execute code in response to events without having to manage the infrastructure. It allows you to create event-driven applications and execute code snippets or functions in a variety of programming languages, including C#, Java, JavaScript, Python, and more. Azure features allow developers to create scalable and cost-effective solutions by paying only for the resources needed during execution. It supports a diverse set of triggers, including HTTP requests, timers, queues, and events in the event network, enabling seamless connection to the Azure services and external systems. Azure features enable the rapid creation and deployment of microservices, data processing activities, and automation processes, allowing developers to focus on creating creative solutions instead of worrying about server management. Azure Container Instances, or ACI, is a serverless container service that allows users to run containers without managing the underlying infrastructure. It offers a fast and flexible approach for deploying containerized application, allowing developers to focus on writing and publishing code rather than managing the server. ACI allows users to run containers with a single command and downgrade them up or down based on requirements. It supports both Linux and Windows containers, making it suitable for a diverse set of applications. ACI works easily with other Azure services and includes capabilities such as autoscaling, networking, and access control, making it easy to create and maintain containerized applications in the cloud. Azure Kubernetes Service, or AKS, is a managed Kubernetes service that allows you to install, manage, and scale Kubernetes-based containerized application. It simplifies the process of constructing and managing Kubernetes cluster by abstracting the complexity of infrastructure management. AKS enables customers to effortlessly deploy and manage containerized application without having to secure or maintain Kubernetes control plane components. AKS provides capabilities such as autonomous scaling, self-healing, and integrated monitoring to improve reliability and efficiency. It seamlessly connects to other Azure services, enabling the deployment of a microservices architecture and the modernization of existing applications. AKS enables organizations to accelerate their transition to cloud-based application development and deployment while promoting agility, scalability, and creativity. Azure Batch is a cloud-based service designed to run large-scale parallel and high-performance computing, or HPC applications. It enables users to efficiently provision and manage on-demand scalable computing resources to meet the needs of batch processing activities. It can handle a variety of workloads, including data processing, graphics, and simulations on both Windows and Linux platforms. Customers can use Azure Batch to run compute-intensive processes without having to manage the infrastructure, which optimizes resource utilization and reduces cost. Azure Batch works seamlessly with other Azure services, providing easy transport, storage, and management of data. It enables organization to accelerate time to result and gain faster insight by leveraging distributed computing capabilities. Azure Dedicated Hosts allows organization to run virtual machines on dedicated physical servers. It isolates and controls the underlying hardware, enabling compliance with regulatory or special licenses. Dedicated hosts allow users to deploy virtual machines in single-tenant environments, providing predictable performance and security. It can run a variety of operating systems and workloads, including Windows and Linux, database servers, and business applications. Dedicated hosts provide flexibility in instance types, size, and configurations, allowing organizations to tailor their environment to unique needs. Overall, Azure Dedicated Hosts offer a reliable and flexible alternative to hosting virtualized workload in the cloud. We can create and run virtual machines in the cloud using the Microsoft Azure Virtual Machine service without the need to manage the infrastructure. Perhaps we will set up the necessary OS in a VM, such as Linux, Windows, or Mac. A virtual machine is like a physical computer, but it is actually a digital version of it. In fact, it is not so different from physical computers because they also have memory, CPU, as well as disk to store our data or various files. And another interesting thing is that they can also connect to the internet. Thus, we can say that VM is actually a software-defined computer that exists only as a code, but is present on physical servers. A virtual machine can back up our existing operating system. This is one of the important uses of the VM, to be able to back up the existing operating system that we are using. Applications are built and deployed in the cloud, and a virtual machine can be used in it to create and deploy applications in the cloud. Virtual machines can be used to run a variety of applications and software on operating systems that were not originally built for them. There are many applications and software that are not made for some operating system, but in such cases, virtual machines are used to overcome such problems. Azure DevTest Labs use a virtual machine to test and run a variety of software in addition to the existing OS. They've actually set up a new environment that makes it easier for developers to deploy a dev test scenario. Another way that a virtual machine is used is whenever any new operating system appears, firstly it is tested on the virtual machine for its proper testing and operation. There are some important points that you need to know before creating a VM in Azure. We should decide on the name of the application resource we are working on. The application we are working on and the name of the resource for this should be properly specified. The second step is to decide what the location of our VM is. This means the location where our resources are kept. The size of VM is then decided depending on our workload. The VM works on which operating system to decide on as well. We should know all the VM configurations that we create on Azure. In Azure, we create resources that are spread across different regions, and that region is called location. Typically, the process is known as location determination. This means that the location of the VM determines where the virtual hard disks are stored. There are a variety of methods to get a list of location. The first method is when we create a VM, we can select a location from the list given in the Azure portal. A list of regions or locations is given in the Azure portal from which you can select any location from a given list. Azure PowerShell is another method from which we can use the get az location command to select the location of our VM. Here we need to use a PowerShell to know which site is available and which is not available to create our VM. The size of the VM is also an important factor in which the operation of our virtual machines depends. As we mentioned before, the size of the VM depends on the type of work we are working on. If the workload is very large, then we need to choose a multiple VM sizes according to it so that the work is smooth and feasible. Various factors such as our storage capacity and processing power depend on the size of our VM. The larger the VM size, the better and more usable these factors are. Hourly fees are paid to Azure, which is based on the operating system and the size of the VM. Virtual hard disks are used to store operating system and data in a virtual machine. The most important operating job of virtual hard drives is that they help select an image to install the OS. Azure gives us a lot of market images from which we can use different types of Windows Server operating system. Images from the market can also be identified by the offer, SKU, and image publisher. There are different methods by which we can find the details of an image. The first method is that we can see the values directly from the Azure portal. When we select an image to use, the image details are automatically specified. The second method is that we can use Azure PowerShell and use get azvm image publisher. This helps us to know the specification of the image we have to choose. Extension of virtual machines play an important role in various working methods. The main task of a VM is to give the VM additional capabilities in deployment and configuration, as well as a variety of tasks. Extension can help with the various tasks listed below. Manage and implement configurations. It helps the VM to deploy it properly, and there is another component known as DSC, Desired State Extension, that helps the VM manage environments. Run script. There is a component known as CSA, Custom Script Extension, that helps us configure different workload on the VM, and this process is done by running our script. The next chapter will be devoted to creating a VM and explaining, and then once the resource is created, we will look at the basic parts as well as the process of logging into our virtual machine itself. Welcome back, and in this chapter I will show you how can create a virtual machine in detail, in a great detail. So we are now in our Azure portal, and if I go to our virtual machine, I will click, this is our Azure services, the most used one. Also you can use a search to search your VM or use this favorites or go to Marketplace to create a VM. The first thing I want to do is to create a resource group. I will choose my subscription. Choose my resource group. Choose my region. And click on Create. Our resource group is created. I will go inside my resource group. This is empty resource group. Let me click on Create. And from Marketplace, I will search my virtual machine. And then we will choose Microsoft as a publisher virtual machine. Click on Create Virtual Machine. Also, if you want, you can see all publisher type, product type, publisher name right from your Marketplace. We already know how to do this, but let's concentrate on how to create our virtual machine. I will choose the name of my VM. Then, if you look at our right corner, you can see the estimated monthly cost of our VM. You can see our basic costs, the price of disk. Basic costs include image and size. You can see how much is the data and so on. I will again click on VM to create a VM. Then, as I already told you, we need to choose our subscription. Our resource group is automatically selected because we choose to create a VM directly from our resource group. And then I will add a name for my VM, and we need to add all these instance details, choose a region, choose our availability option, and so on. But let's go step by step. As I hover my mouse on this little balloon, you can see all the explanation about virtual machine name. We need to add a unique name, choose a region where we want our machine to be located, and from this drop-down menu you can select various locations all over the world. First, let's add a name, for example VM1000. This is a unique name, everything is good, and we can carry on. Then in our region, I can choose my region, and you can choose whatever region you want. Of course, I will use the region that is close to my residence. I will choose North Europe, for example. Then in availability option, you have option to choose availability zone. There is two zone option. First one is self-selected zone. You can choose up to 3 availability zone and 1 VM per zone, or auto select zone. This is a preview, or simply choose no infrastructure redundancy required. Also, Azure selected zone, it is in preview, where you can choose let Azure to assign you to the best zone of your need. As you can see. Also, I will choose no infrastructure redundancy required, so we don't have option to choose our availability zone. Also, in this security type, you can choose standard, the basic level of security, confidential virtual machine, and trusted launch virtual machine. It protects against persistent and advanced attacks on Gen 2 virtual machine with configurable features like secure boot and virtual TPM or trusted platform module. Then confidential virtual machine. On the top of trusted launch, confidential VM offers a higher security, and trusted launch virtual machine is selected by default. Then we need to use an image. There is some images that you already see, like Windows Server 2022 Data Center. We have Azure Edition Hot Patch or Azure Edition Simple 2019, and we have Ubuntu Server, Oracle Linux, SUSE Linux Enterprise, Red Hat or RHEL, Debian, and so on. You can also choose Windows 11 Pro or Windows 10, Windows 11 Pro or Windows 10 Pro. So if you need more images, you can go to and click See All Images to go to Marketplace and select the one you need. When you choose your image, for example Windows Server 2022 Data Center, there is an estimated monthly cost something above 100. If I check this box to run with Azure Spot Discount, I will get an estimated account and I can choose my eviction type. Capacity only. My VM will be evicted when Azure excess capacity disappears, and price or capacity. My VM will be evicted from Azure excess capacity disappears or cost exceed your specified max price. And the eviction policy is stop or delocate or to delete this VM. As you can see, our estimated monthly cost is only $31.57 if you use a run with Azure Spot Discount. Then you have enter a price greater than or equal to hardware cost, and if you hover your mouse on this little balloon, you can read additional information about Azure Spot and eviction policy. I will uncheck this option, and then we need to choose our size. Of course, if you click on See All Images, you will go to Marketplace, where you can find various publishers and various images, and then you can select whatever you need. But for this demo, I will stick with Windows Server 2022 Data Center. Let's go back to our VM. Simply click on Create Virtual Machine, and the next thing I want to do is to choose my size. The actual size is standard DS1 version 2 with one virtual CPU and 3.5 gigabytes of memory, and you can see a price in dollars per month. I recently used this size, DS2 version 3 and B1S. This is recommended by publisher, and if I click on See All Images, I will get a list of all possible VMs that I can use for this VM size that I can use in this demo, for example, or for this VM. There is a various series of this VM, of this image size, so you can choose between virtual CPU, RAM, data disk, monthly price, and so on, by type, and so on. Also, there is a category, there is a filter, so you can choose by virtual CPU, by RAM, by display cost, and so on. We are now using the most used by Azure. Then if we scroll down, there is an administrator account, so we need to add, this is required, we need to add our username and password, and then we need to confirm our password. I will add my username as Azure user. Then we need to specify our password. I will confirm my password. And password and confirm must match, as you can see. So Azure will automatically add this red X, and you need to add to confirm your password, and it must be exactly as the same as the first password typed. Then we have inbound port rules. We need to select which virtual machine network ports are accessible from the public internet. And in the networking tab we can go even more granular. So you can choose from none or simply allow selected ports, and you can choose between HTTP 80, HTTPS 443, SH22 and SSH22 and RDP remote desktop 3389 remote desktop protocol. If you have a license, you can save up to 49% with a license that you already own using Azure Hybrid Benefit. If you check this little box, you can use an existing Windows Server license. As you can see, our estimated price is almost 30% lower. And if you confirm that you have eligible Windows Server license and software, you will apply this Azure Hybrid Benefit. I don't have Windows Server license with software assurance on Windows Server subscription, so I will uncheck this box and I will click on Next to go to Disk. In the Disk tab, we have this VM disk encryption. I can choose my OS disk size. This image is default. It's 127 gigabytes. OS disk type you can choose, of course, by image size from 127 to 2 terabytes or P40 mark. Then the OS disk type you can choose from locally redundant storage. Data is replicated with a single data center with premium SSD, standard SSD and standard HDD, and zone redundant storage where data is replicated to 3 zones, and there is premium SSD and standard SSD. Of course, for all this offer you have a little explanation. For example, premium SSD is best for production and performance sensitive workloads, standard SSD is best for web service, and standard HDD is best for backups for LRS. For ZRS, premium is best for workload production that needs storage resiliency against zone failures, and standard SSD is best for web servers, and so on. So you can choose whatever OS disk type you want. We will leave this as you can see, our estimated monthly cost will slightly go down if you choose slower SSD or HDD drive, but with premium SSD you'll get the best performance for sensitive workloads and for production. So if you have some web servers, lightly use enterprise application and dev test, you can use this standard SSD locally redundant storage. Then if you check this box, you can delete with VM. This disk will be deleted when you delete your VM. Key management is platform managed key, and UltraDisk is not supported with this VM size, but if you want to use this enable UltraDisk compatibility, you will have to choose some bigger VM size. Then you can add data disk for VM1000. You can create and attach a new disk or attach an existing disk. If you have existing disk, simply click on attach disk. If you want to create a new disk, simply click on other option. Then you will have option to add a name. Then source type you can choose from snapshot, storage blob, or empty disk, none. You can choose the size of your new disk from 1024 gigabytes premium SSD LRS to P80 performance tier. You can see storage type. You can choose from premium SSD, LRS, standard SSD, standard HDD, or ZRS, premium SSD, and standard SSD. I'm satisfied with this offer, and then I will choose my path or manage key, which is encrypted, and then you can enable share disk. If you want, I will choose no, and if you check this box, you will delete this disk when you're deleting your VM. I will not create and attach a new disk. I will simply go to networking. In the networking tab, I have an option to change the name or create a new virtual network. As you can see, VM1000-VNET is the default name for this virtual network. Also, there is a new default subnet 10.0.0.0/24, and public IP is VM1000/IP. If I click on create new, I have option to change the name of this virtual network. I can even change the address range, change my subnet name, change my address range, and so on. Once that I'm satisfied, I will simply click on OK. But let's not touch these default options. And then we have something called network NIC, network interface card, and NSG, which are basic. You can choose select inbound ports, of course, enable accelerating network, and choose load balancing option to create Azure load balancing or application gateway. In the management option, you can add Microsoft Defender for Cloud for this server. You can simply check this box if you want to log in with Microsoft Enter ID, and role-based access assignment or virtual machine administrator login or virtual machine user login is required when you're using Microsoft Enter ID. Also, you have option to enable shutdown, enable backup, guest OS is patch orchestration option, and so on. I already told you that if you want to use Microsoft Defender for Cloud, you need to have a premium offer for this, but for now this machine is protected by Microsoft Defender for Cloud for free plan. And then if you go to monitoring, you can choose alerts to enable recommended alert rules, percentage CPU, available memory, and so on. And then you can choose to be notified by email, mobile app notification, resource manager role, and so on. You can use an existing action group and add one of these or all alert rules. You can also configure alert rules. You can choose to disable boot diagnostics or enable with custom storage account, but with the default option, which is recommended, you can enable with managed storage account. If you enable this, you won't be able to use boot diagnostics. Also, you can enable OS guest diagnostics and so on. In the advanced option, you have option to choose an extension to install. If you click right here, you can install an extension or search for appropriate option. For example, custom script extension. I will click on next. Then you need to browse a script file which is required and simply click on create. And your custom script will be installed when your machine is created. There is some VM application with, if you want to install user data, and you can enable user data. You can choose proximity placement group to group Azure resources physically closer together in the same region, and you can have this capacity reservation to reserve capacity for your virtual machine needs, and so on. This is an advanced options, so I will not get into much detail. Then if I click on next, you can add your tag, name and value pair, and finally I will click on review and create. And if we go to monitoring, we need to enable this, and we need to uncheck our alerts, and finally we will be able to review and create this VM. Let me click on create, but first you need to, validation is passed. We have one standard DS1 version 2. You can see hourly price and other settings that we added when we choose to create our virtual machine. Finally, this is an hourly price. Finally, I will click on create, but you have this warning that you have set RDP port open to internet, and this is only recommended for testing. If you want to change the settings, go back to basic tab and simply uncheck your 3389 or RDP port. And finally, we are ready to go and create our first VM. And as you can see, it's very easy to create VM, but I wanted to show you all the possibility that you have when you're creating VM. And we are officially creating our first VM. And our deployment is in progress. After some time, our deployment is complete, and we can go to our resource. If you want, you can check your overview. You can delete your machine or redeploy machine, or even download these deployment details. If you want, you can see your template. You can download your template or deploy it again. This is a JSON file. Later in this course we will have extensive chapters about templates, and we're officially in our VM 1000, our virtual machine. If you go to overview, you can see that we have our resource group, status is running. Also, you can connect to our VM via Bastion or RDP file. You can restart, stop machine. Also, you can start machine, you can capture image or restore point. You can delete this machine. You can see our status is running, where is located, what is our operating system, the size of our VM, public IP address, VNet or subnet, DNS name is not configured, health state and time where this machine created. Also in the properties you can see all of this with more information, and if you need some information you can simply go to properties and scroll down and see everything. This is our VNet, and then if you go to settings in address space, this is our address space, and this is our subnet, our default subnet. And if you go back to our VM 1000, you can even configure your DNS name if you want. Health state is not active. Currently we don't have any information, and this was the time of our creation of this VM. Also you can view this in JSON files if you want. We have something called resource ID, and that's it. This is resource JSON, JavaScript object notation. As I already told you, in the properties you have some more information about VM networking. This is the private IP and this is the public IP of our VM, our size, source image, disk, auto shutdown is not enabled, Azure Spot we are not using, and so on. If you go to our VM, you can see that we have 6 resources. The first one is virtual machine, the second one is public IP address, then we have network security groups or NSG, then we have virtual network, network interface and disk. All these 6 resources is a part of one VM. In the chapter when we learn about tags, I show you how can you assign tags for all of these resources with the bulk assigning tags, and as you can see, we can see our location for all of these 6 resources, and all resources, all 6 resources is a part of our VM. If you go back to our VM, we can now go to connect. I will now click on connect, then I will download my RDP file. You can see our public IP address, admin username, port 3389, this is our RDP file, and when you click on download RDP, it will download RDP file. As you can see, I will now click on this RDP file and simple double click, and in remote desktop connection you have option to connect to our remote computer. I will click on connect, automatically it added our username, and we need to add our password that we specified during the creation of our VM. I will add my password, and then I will click on OK. Then on yes. I want to connect despite these certificate errors, and we are officially connected to our VM, and from this VM we can do whatever we want. So we need to wait, just like regular VM, to boot up, and after that the server manager will start automatically, and if you want you can add some roles and features and so on. We will know with this in later part of this course, But for now, this is how can you create your VM and connect your VM with the use of RDP. This is our Windows server, just to remind you. And finally, our Windows server is ready, and we're waiting for Server Manager to load, to boot up. I will click on Yes on Networks. I will allow this network, and this is our Server Manager dashboard. We need to wait for this Server Manager to load up. And if I minimize this window, there are several categories of virtual machines that we can choose from when creating this resource. And in addition, we can choose the series themselves. Virtual machines are divided into general purpose, compute optimized, memory optimized, storage optimized, GPU, and high performance compute, or HPC. General purpose is a balanced ratio of processor and memory, ideal for testing and development, small and medium sizes databases, and web servers with low-medium traffic. These include the BSV2 series as well as the BS series, the BS series and AV2 standard. Compute optimized, a high ratio of processor to memory, good for medium traffic web servers, network devices, group processes, and application servers. These include F series, FS version 2 series, and that's it. Memory optimized, a high memory to core ratio, great for relational database servers, medium to large caches, and in-memory analytics. This includes E and M series. Storage optimized, high disk and I/O bandwidth, ideal for big data, SQL and NoSQL databases, and this is where the series belongs. GPU, specialized virtual machine, designed for heavy graphics rendering and video editing, available with 10 or more GPUs. There's a lot of N series here. High performance compute, or HPC, the fastest and the most powerful CPU virtual machine with optional high bandwidth network interfaces, or RDMA, and this is H series. Azure charges for the number of full minutes when our virtual machine is running, so we are not charged for additional seconds. There are two types of images that can be used in Azure: a VM image and an OS image. An image for a VM includes the operating system and ADI attached to the virtual machine when the image is created. Also, in the marketplace, we can find a large number of images when we create a virtual machine, and it depends on our needs which one we choose. Go to our Azure portal and click on virtual machine and choose to create a new virtual machine. There is an option for images, or sizes. You can choose your image, for example Windows and distributions of Linux, and there is also a size. So if you click on standard all sizes, you can choose your VM or image size. Then when you pick up your size of your VM, there is an also ratio with virtual CPU and RAM. Also, there is an option to see data disk, how many data disks can you use with that size, max IOPS, local storage in gigabytes, premium disk, and cost. So, cost is strictly depending on which size of your virtual machine you choose. Of course, you can see all VMs by series, and you can even go even more further, add a filter and choose your category. For example, this is a general purpose, This is most used by Azure users. Also, you can select these filters and choose by virtual CPU, RAM, cost monthly or hourly, and you can also add a filter and choose some new category to list all your data, all your virtual machines. Also, you can choose to group by series, and no grouping. And at the end of this screen, you can see cost per month. So this is how can you select and see all the VM sizes and images with prices. Now that you know how to create a virtual machine, let's go and how to connect to our virtual machine. Let's see how can we install something called IIS or Internet Information Services. So in this chapter, when we create a virtual machine, we can stay logged in, or you can log in again, and then you can do something called installation of Internet Information Services, which is a role. And let's see how can we do this. It's very easy. So it is something that you will encounter through your cloud career. This is our virtual machine that we created. And if you remember, if we go to Connect Blade, we will download this RDP file. Double click on this RDP file, you will add your username and password, and after this VM boot up, you will be able to and Server Manager boot up, you will be able to work with your VM. There is something called virtual Server Manager, and with the help of this Server Manager, you can configure your local server. For example, you can add a role and feature for this server. You can create a server group. You can connect this server to the cloud, or add some role to this server. Let's click on Add Roles and Features. Then a new window will pop up. Let's click on Next. Let's choose our role-based or feature-based installation. Next. Then this is our VM. Click on Next. And you need to select one or more roles to install on the selected server. As you can see, there is a lot of roles. But for now, I will choose this web server, IIS, or Internet Information Services. You can choose that, and finally let's click on Add Features. Click on Next again, and finally I will click on Next, again Next, Next. You can see what we are installing, and finally let's click on Install, and we are starting installation. And as you can see, this is installation. Our destination server is VM1000, so this is our virtual machine or our server. You can track feature installation and see what are we installing on our VM. So it takes for 1 or 2 minutes to install this Internet Information Services role to our server, and let's see how can we do that and what happens when we finish this installation. You can track the progress on your screen. I will not stopping my video, so my recording, so you can see the whole process of how this installation progress is running. If you close this window, you can see that we have this IIS and file as a storage installed roles and server groups. We have two roles, one server groups and servers total 1. Let's now copy public IP address of our virtual machine. I'm in my Azure portal again, and then if you open a new window, copy this public IP address, you can see that we installed Internet Information Services on our Windows server. So this is how can you install Internet Information Services on your virtual machine. Azure Load Balancer runs on layer 4 of the Open System Interconnection or OSI model. It's the only point of contact for customers. The load balancer distributes the incoming streams that arrive at the front end of the load balancer to the backup set instances. These flows are in accordance with the configured load balancing rules and health probes. Backend instances of a set can be Azure Virtual Machine or instances in a virtual machine scale set. A public load balancer can provide outbound connections for virtual machines or VMs within your virtual network. These connections are made by translating their private IP addresses into public IP addresses. Public load balancers are used to balance traffic on your VMs. A public load balancers are used to balance, as I already mentioned, the internet traffic on your VMs. An internal or private load balancers is used in scenarios where private IP addresses are only needed on the front end. Internal load balancers are used to balance traffic within a virtual network. The load balancing front end can be accessed from the local network in a hybrid scenario. A public load balancer maps the public IP addresses and incoming traffic port to the VM private IP and port. The load balancer maps the traffic in reverse for response traffic from the VM. You can distribute certain types of traffic across multiple VMs or services by applying load balancing rules. For example, you can distribute the load of web request traffic across multiple web servers. An internal load balancer distributes traffic to resources located within a virtual network. Azure restricts access to front-end IP addresses of a VNet that are balanced. Front-end IP addresses and virtual networks are never directly exposed to the internet endpoint, which means that internal load balancer cannot accept incoming traffic from the internet. Internal business applications run in Azure and are accessed from Azure or on-premises resources. Both types of balancers using a basic and standard SKU, stock keeping unit. A backend pool is a group of virtual machine or instances in a virtual machine set that serves an incoming request. To scale cost effectively to accommodate large amounts of incoming traffic, computer guidelines generally recommend adding multiple instances to the backend set. The load balancer is instantly reconfigured via automatic reconfiguration when you increase or decrease instances. Adding or removing a VM from the backend stack reconfigures the load balancer without any other operation. The scope of a backend pool is each virtual machine in a virtual network. Backend assemblies support adding instances over a network interface or IP addresses. VM do not need a public IP address to be attached to a backup set of a public load balancer. Virtual machine can be plugged into a backend set of load balancer even if they are in a stop state. You can also configure multiple backend stacks with different instance groups for a single load balancer. By creating multiple load balancing rules, each targeting a different backend set, you can configure traffic to be distributed to different sets of backend resources on the port and front-end load balancer protocol. Health probe is used to determine the health status of instances in the backend group. When creating a load balancer, configure health probes to use the load balancer. This health probe option determines whether the instance is healthy and can receive traffic. You can define an unhealthy threshold for your health trials. When the probe doesn't respond, the load balancer stops sending new connections to unhealthy instances. The failure of the probe does not affect the existing connections. A load balancer provides different types of health checks for endpoints like TCP, HTTP, and HTTPS. Basic load balancer does not support HTTPS health probe types for endpoints. The basic load balancer closes all TCP connections. A load balancer rule is used to define how incoming traffic is distributed to all instances within a backend set. A load balancing rule maps a given IP configuration and port of the front end to multiple backend IP addresses and ports. Load balancer rules are for inbound traffic only. An inbound net rule forwards incoming traffic sent to a combination of IP addresses and front-end ports. Traffic is sent to a specific virtual machine or instance in the backend set. Port forwarding is done with the same hash-based distribution as load balancing. An inbound rule configures an outbound network address translation or NAT for all virtual machines or instances identified by the backend set. This rule allows instances in the background to communicate or go to the internet or other endpoints. A load balancing rule is used to define how incoming traffic is distributed to all instances within a backend set. A load balancing rule maps a given IP configuration and port of the front end to multiple backend IP addresses and ports. The load balancing rules are for inbound traffic only. And that's it. Many Azure regions provide availability zones, which are separate groups of data centers within the region. Availability zones are close enough to have low latency relationship with other availability zones. They are connected by a high-performance network with a return latency of less than 2 milliseconds. However, availability zones are far enough apart to reduce the likelihood that more than one zone will be affected by local outages or weather. Availability zones have independent power, cooling, and networking infrastructure. They are designed so that if one zone experiences an outage, the remaining zones support regional services capacity and high availability. They help keep your data in sync and accessible when things go wrong. Data center locations are selected using rigorous criteria to assess vulnerability risk. The process identifies any significant risk specific to the data center and takes into account common risk between availability zones. Each data center is assigned to a physical zone. Physical zones are mapped to logical zones in your Azure subscription, and different subscriptions may have a different mapping order. Azure subscriptions are automatically assigned their mapping at the time that subscription is created. Because of this, the zone mapping for one subscription may be different for other subscription. For example, subscription A may have physical zone X mapped to logical zone 1, while subscription B may have physical zone X mapped to logical zone 3 instead. Microsoft aims to deploy updates for Azure services in a single availability zone at a time. This approach reduces the impact that updates can be on the active workload, as the workload can continue to run in other zones while the update is in progress. Azure provides the broadest global footprint of any cloud provider and is rapidly opening up new regions and availability zones. Azure has availability zone in each country or region where Azure manages the data center. Some services may have a limited support for availability zones. For example, some may only support availability zone for specific levels, regions, or SKU. If you go to our Azure portal and, for example, choose our virtual machine as a resource that we want to create, let's click on Create, go to Azure Virtual Machine. Then, after you set up your subscription, choose your resource group or create a new one, add a name for your VM, choose your region. There is an option for availability options, as you can see, and from this drop-down menu you can choose to have no infrastructure redundancy required. Then you can choose availability zone. This is physically separate your resource from within an Azure region. And in the next chapter we will get to know with virtual machine scale set and availability zone. But for now, if I choose availability zone, you can see that I have these zone options. First one is self-selected zones. You can choose up to 3 availability zone and 1 VM per zone. For example, you can choose availability zone from this drop-down menu. By default, it is checked this box for zone 1, and you can uncheck this zone 1 and check zone 2, and exactly the same for zone 3. Then there is a new offer which is still in preview. If you check this option, you can let Azure to assign the best zone for your needs. As you can see, we can work with this availability zone. We can choose or change anything because Azure is now selecting this zone for us. So this is how can you create an availability zone or choose to create availability zone in your Azure portal. This is just for our virtual machine. You can do this for almost every resource that you are creating. Availability sets are logical groupings of VMs that reduce the chance of correlated failures crashing connected VMs at the same time. Availability set place VM or virtual machine in different fault domains for better reliability, which is especially useful if the region doesn't support availability zones. When you use availability set, you create 2 or more VMs with an availability set. Using 2 or more VMs is an availability set helps highly available application and meets 99.95% Azure Service Level Agreement or SLA. There is no additional cost for using availability set. You only pay for each VM instance you create. Availability sets offer improved VM to VM latency compared to availability zones, as virtual machines in availability sets are located in close proximity. Availability sets have fault isolation for many possible failures, minimizing individual points of failure and offering high availability. Availability sets are still subject to certain common infrastructure failures, such as data center network failures, which can affect multiple fault domains. Each VM in your availability set is assigned an update domain and fault domain by underlying the Azure platform. Each availability set can be configured with up to 3 fault domains and 20 update domains. These configurations can be changed after the availability set is created. Update domain refers to group of virtual machine and underlying physical hardware that can be rebooted and reset at the same time. When we have 5 virtual machines or more are configured within a single availability set with 5 update domain, the 6th virtual machine is placed in the same update domain as the first virtual machine. The 7th in the same update domain as the second virtual machine, and so on. The order of the update domain that is restarted may not occur consecutively during plain maintenance, but only one update domain is restarted at a time. The rebooted update domain is given 30 minutes to recover before maintenance can begin on the other update domain. Fault domains define a group of virtual machines that share a common power source and network switch. By default, virtual machines configured within your availability set are separated into up to 3 fault domains. While putting your virtual machine in an availability pool doesn't protect your application from operating systems or application-specific failures, it does limit the impact of potential physical hardware failures, network outages, or power outages. VMs are also aligned with disk fault domains. This alignment ensures that all managed disks are attached to the VM that are within the same fault domains. Only VMs with managed disk can be created in Manage Availability Set. The number of managed disk fault domains varies depending on the region, 2 or 3 managed disk fault domains per region. Under certain circumstances, 2 VMs in the same availability set may share a fault domain. You can verify a shared fault domain by going on your availability set and checking the fault domain column. A shared error domain can be caused by completing the following sequence when you deploy a VM. Set up first VM, stop, disconnect the first VM, and set up another VM. Under these circumstances, the operating system disk of the second VM may be created in the same fault domain as the first VM, so the 2 VMs will be in the same fault domain. To avoid this issue, Microsoft recommends that you do not stop or deallocate VMs between deployments. If you go to our Azure portal and in the search bar try to type availability sets, you can see that we can use this service. So let's click on this link. Let's click on create availability set, and we need to select our Azure subscription, create a new resource group, or simply choose a new one from this drop-down menu. I will choose my existing resource group, for example. Then I need to add a name for this instance. Also, you can create a new one if you want. Let's add a name for our instance. Then I will choose my region. I'm satisfied with North Europe. And then you can choose your fault domains, up to 3 fault domain, as you remember. But in this North Europe region, I can choose only 2. Then update domain can go up to 20. And in our theoretical part, we are explain in detail what is fault and what is update domain. If we choose, for example, East US, you can see that I can move this slider to 3 update domains. So it really depends on a region, what you choose, and then you can choose your fault and update domains. Then you can use to align your managed disk. You can choose if you want that option, and we will have 3 fault domains and 6 update domains, for example. Then I will go to next, to our advanced option. You can choose to allow this proximity placement group if you want to your VMs be closer together. And then let's click on review and create. After validation is passed, let's click on create to create our availability set. Our availability set is almost complete. Our resource is created, and if I go inside this resource, I don't have any machine that I join on this availability set. But if you have add some of your virtual machine, for example, there will be machine name, status, colocation status, and fault domain, the number 10, for example, and the number of your update domain. The next machine will be fault domain, for example, 1, and update domain 2. Let's go to our virtual machine. Let's create a new one. I will choose my resource group, for example, choose my subscription. This is all required when you're creating a resource. Also, you can create a new one if you don't have existing resource group. Then we need to add some instance details like VM name, choose a region, you can choose your region. It must be in the same region as our availability set. And then in the availability option, if you remember from the previous chapter, we already saw what we can do with our availability zone. And now I will choose my availability set, and if you scroll down you can create a new one right from here or add existing one. Also you can specify your update and full domain. I have this availability set, which is a separate resource already created, and I will simply add this availability set, choose my image as a Windows Server 2022 Data Center Azure Edition. You can choose between these images or simply go to Marketplace and choose whatever you want. I choose my Ubuntu server. Size, I'm satisfied with my size. Let's use this password as authentication type, and then I will add my username, add my password, confirm my password. I will choose my inbound port. Now we have SSH22 because this is our Ubuntu server, Linux Ubuntu. And finally, you can choose your HTTP 80 port, and then after you create your VM, the name of your VM will be shown here as a status, colocation status, full domain, and update domain. So this VM will be part of this availability set. This is how can you create and work with your availability set, which is a separate resource in Azure offers. And the number of fault and update domain will be shown here. Azure Virtual Machine Scale Sets, or VMSS, allow you to create a managed group of virtual machines with load balance. The number of VM instances can be automatically increased or decreased in response to a request of a defined schedule. Scale Sets provides a following benefits: easy creation and management of multiple VMs, ensure high availability and resiliency of your application, to automatically increase as demand for resources changes, and works on a large scale. With flexible orchestration, Azure provides a unique experience across the entire Azure VM ecosystem. Flexible orchestration offers guarantees of high availability up to 1000 VMs by spreading VMs to fault domains in a region or within an availability zone. To provide redundancy and improve performance, applications are typically distributed across multiple instances. Users can access your application through a load balancer that distributes requests to one of the application instances. If you need to perform maintenance or update an application instance, your customers must be distributed to another available application instance. To keep with additional customer demands, you may need to increase the number of application instances that run your application. Azure Virtual Machine Scale Set provides management capabilities for applications running on many VMs, auto-scaling resources, and load balancing traffic. There are a number of benefits that VMSS brings, such as easy creation and management with multiple VMs, provide high availability and resiliency of applications, allow your application to automatically increase as demand for resources changes, etc. Its scale sets support up to 1000 instances for standard market images and custom images via Azure Compute Gallery, formerly known as Share Image Gallery. If you create a scale set by using a managed image, the limit is 600 VM instances. Let's go to the portal and create a VMSS with an explanation of the procedure and adding a manual rule for creating a new virtual machine. And once again we are in our Azure portal, and in the search bar I will type VMSS. So you can directly from here click on this link and click on create to create our virtual machine scale sets. Then you will choose your subscription. I can choose my resource group. If you don't have your resource group, simply click on create new and create a new one. Add a name and click on OK. Then in the scale set details, we need to provide some additional information like VM scale set name, choose our region, and choose our availability zone. Then I will specify AZVMSS, for example. It must be unique name. Then you can choose your region. I will choose VM01, for example, for our availability zone. And then in the orchestration mode, you have two options to choose: flexible, to achieve high availability at scale with identical or multiple VM types, and uniform, optimized for large scale workloads. Let's choose this flexible, and then security type is trusted VMs. I will leave that as it is. And in the scaling, you can choose your scaling mode manually, update the capacity, maintain a fixed amount of instances. Then you can add auto-scaling based on CPU metrics or any schedule, and no scaling profile such as manual attach VM after deployment. You can choose your instance count, add your predictive auto-scaling, enable this forecast. Just check this box if you want, and then you have this option for scaling policy, and this is an option that you can work with. I added my image, Windows Server 2022 Azure Edition. This is our size of our VM, and just like in some of our previous chapter, in the administrative account you need to specify your username and password. I will add my username that I'll be using in this set of chapters. Then my password, I always use the same username and password just to make it simpler for me. Then if you go to spot, you can save your money if you use this spot option. I already explained what is a spot. And then you can scale with VM discounted and so on. Let's go to disk. In the disk option, there is an option that is default by Microsoft. So our OS disk size is image default 127 GB, and then we have this OS type. I will choose standard HDD, locally redundant storage. In the networking, this is our virtual network that will be created, that is already created, and then you have this option to create your VM, add a name, add a resource group, and specify address range and subnet. This is our network interface that will be created with this scale set, and it will create public IP address. And in the load balancing option, you can choose from load balancer and application gateway. Let's go to management, health. You can enable application health monitoring if you want. Then let's go to advanced. You can choose your spreading algorithm, allocation policy, to max or fixed spreading, and you can add some additional information. But let's make it simple. Let's choose our max spreading, and finally let's go to tags and review and create, and we are waiting for our validation. And after that, if we click on create, we will create our virtual machine scale set. So this is all the settings that we added throughout this wizard. Our deployment is in progress. And our resource is complete. Our deployment is complete. I will go to my resource. If you can see, in the overview blade, we have some basic information like the name of our resource group, status, location. You can see that we are using availability zone. We are located in North Europe Zone 1. Also, you can start, restart, stop, or hibernate this VM, or reimage, or delete it. Then in the subscription, you can move this virtual machine scale set to another resource group or subscription. We have our subscription ID, operating system, size of our VM, virtual network, orchestration mode, and time where our machine is created. Also, as you already know, in the properties menu, you have some additional information about your VM. And then, if you go to instances, you can see that we have one instance. This is our AZ VMSS 1000, and status is creating, type is VM, provisioning state is VM, and you can see the standard size. And you can also, if you click on these three dots, add some more information. If you go to networking, you have option to add load balancing and create load balancing right from here, from your VMSS. You need to add your load balancer name, choose the type public or internal, protocol TCP or UDP, and then you will need to add load balancing rule, and so on. Finally, you will click on create and create this load balancer, but this time, as you can see, this is our VMSS LB, public LP, and if you click on create, we are creating our load balancer. So, right from virtual machine scale set, you can create a load balancer in the networking blade. Our load balancer is created. If I click on our load balancer, this is our created load balancer, and if you go to settings, you can see that we have something called front-end IP address, backend pools. In the backend pool, there is already created this backend pool. We have health probe and load balancing rule, so Azure is automatically created everything that we need for our load balancer. If I go back to my virtual machine scale set, we have public IP of our public load balancer. If you go to instances, you can see that our VMSS is running, and finally we have now public IP address, and this is the public IP address of our load balancer, because this VMSS is part of this structure, architecture. Let's go to networking settings. You can see we have balancing. There is something called application groups. We have network manager. If you want, you can work from network manager. But if you go to settings, there is disk. If you click on disk, you see that we have OS disk. In the extension application, you can add your application. We have some automatic application health windows. This is our health application, and then In the operating system, you will see some more information about our VMSS, and that's it. Then, if I go to size, you can scale your virtual machine if you want. Your VMSS, you can choose the size that you want. Simply check your VM and click on size. Click on resize. Also, there is something called manual scale or custom scale. Autoscale is a built-in feature that helps application perform the best changes on demand. And then in the manual scale, you can maintain a fixed scale up to 1000 VMs. In the custom scale, you have option to add a rule to this autoscale and add the scale condition. If I click to add scale condition, you can choose your scale mode based on metrics or scale to a specific instance count. For example, if I choose scale based on metrics, I can add a rule. Scale is based on a metric trigger, as you can see, but if there is no rule, there will be no scale. So if you click on add a rule, you will choose your metric source. My VM scale set is our metric source, but you can choose from various lists. Then in the metric space, I will choose virtual machine host. Metric names is %CPU, for example, but you can choose by different metric triggers or metric name. And then in the percentage, our average percentage is 22.87%, and if you enable this metric divide by instance count, you can choose with this operator. Every time when metric threshold goes beyond 70%, there is a trigger that will scale an action, and duration of 5 minutes, and time game average statistic and aggregation will add, let's add 50%, for example. There will be automatic creation of our new Azure VM scale set, because this trigger based on this rule will be activated and our VM will be created by default. Also, there is an option to increase account when this go below 30%, and click on OK. Then in instance count, you need to add minimum is 2 VMs, 4 is maximum, and default is 1. After you specified everything that you want to scale based on metrics, you need to save this rule, and then this rule will be active, but you need to add some activity on your VM. And now if you go to instances, I will check my instance and click on upgrade to add this rule to our VMSS based on scale metric. So every time when activity and goes beyond 50%, we will just click on upgrade. We will have a new AZ VMSS created by default, thanks to this rule. And every time that this activity goes below 30%, there will be automatic cooldown, and that created VM will be deleted by this rule. As you can see, our new VM, our new AZ VMSS is being created, and provisioning state is in created version, and we have standard DS1 v2, so we have 2 VMSS thanks to this rule. It's very easy to scale your to add some scaling rules, and there is an option to every time when you have some more activity to add this auto scaling rule based on trigger, and once that is specified in your settings, this is how a virtual machine skill set will be running. So there is a couple of minutes that this virtual machine skill set needs to Azure Web App or Azure App Service. Allows you to build and host web apps, mobile backends, and RESTful APIs in the programming language of your choice without infrastructure management. It offers auto-scaling and high availability support both for Windows and Linux, and allows automated deployment from GitHub, Azure DevOps, or any Git repo. An app service or application service adds power to Microsoft Azure to your application, including enhanced security, load balancing, auto-scaling, and automated management. In addition, you can take advantage of its DevOps capabilities, such as continuous deployment from Azure DevOps, GitHub, Docker Hub, and other sources, package management, staging environments, custom domains, and TLS SSL certificates. With App Service, you pay for the Azure computing resources you use. The computing resources you use are determined by the App Service plan on which you run your apps. Azure App Service is a fully managed platform as a service or PaaS offered for developers or administrators. It offers a large number of options, so we will mention only a few. The choice of a large number of languages and frameworks, a managed production environment, the application service automatically patches and maintains the OS and language frameworks for you, the ability to use Docker containers and containers, DevOps optimization, easy connection with SaaS application, and data stored on the premises, security, application authentication, integration with the Java tools and Visual Studio Code, etc. App Service can also host web app natively on Linux for supported groups of apps. It can also run custom Linux container, also known as a web application for containers. The application service on Linux supports a large number of language-specific embedded images. You need just to apply your code. Supported languages include Node.js, Java, PHP, Python, and .NET Core. Deprecated runtimes are periodically removed from the blades for creating and configuring web applications on the portal. These runtimes are hidden from the portal when they are deprecated by the maintenance organization or are found to have significant vulnerabilities. These options are hidden to guide clients to the last runtimes, where they will be most successful. When the deprecated runtime is hidden from the portal, any of your existing sites that you use that version will continue to work. If runtime has been completely removed from App Service, your Azure subscription holders will receive an email notification prior to the removal. App Service environment is a feature of Azure App Service that provides a fully isolated and dedicated environment for running app services applications with enhanced security at scale. Unlike offering app service with the support infrastructure is shared with an app service environment, computing is dedicated to a single customer. The app service always runs in the app service plan. In addition, Azure features also have the option to run an application in the service plan. An application service plan defines a set of computing resources to run a web application. When you create an application service plan in a specific region, for example West Europe, a set of the compute resources is created for that plan in that region. Any application that you place in this application service plan run on these computing resources as defined by your application service plan. Each application service plan defines operating system. You can choose between Windows or Linux, a region, for example West US or East US, number of VM instances, size of VM instances, small, medium or large, and price level. Free, shared, basic, standard, premium, premium version 2, premium version 3, isolated and isolated version 2. The pricing level depends and it determines what feature of the app service you get and how much you pay for the plan. The pricing levels available for your app service plan depend on the operating system selected at the time of the creation. These are categories of price levels: shared plan or shared compute. Free and shared are two basic tiers that you can run, and you can run the app on the same Azure VM as the other app service apps, including those of other clients. These tiers allocate CPU quotas to each application running on shared resources, and the resource cannot be reduced. These levels are intended to be used for development and testing purposes only. Dedicated or dedicated computing, the basic, standard, premium or premium version 2 and premium version 3 tiers run applications on dedicated Azure VMs. Only applications in the same application service plan share the same computing resources. The higher the tier, the more VM instances are available for you to scale. And then we have isolated, which contains isolated and isolated version 2 levels run dedicated Azure VMs on dedicated Azure Virtual Network. They provide network isolation in addition to computer isolation to your applications. They provide maximum scaling capabilities. Each level also provides a specific subset of app service features, and these features include custom domains and TLS SSL certificates, autoscaling, deployment slots, backups, traffic manager integration, and more. The higher the level, the more features are available. If you go to our Azure portal and click on App Services, there is an option to create web app, static web app with database, and WordPress on App Service. Let's click on the first option, choose our subscription and resource group, and then we need to add an instance detail, or also you can create your resource group if you don't have one, but this name must be unique. Also, there is an option to move this slider, and you can now add your unique name, and .azurewebsite.net will be our unique name. You can choose to publish a code or container or create a static web app. Operating system, you can choose between Linux or Windows, and then you can choose your region. I will choose my code. I will choose my runtime stack. Let's choose, as you can see, there is a various options. I will choose my .NET 8 LTS. This is run on Windows operating system. If you, for example, choose Java, then it runs on Linux, but you can run it also on Windows. But I will back to the .NET 8 LTS version, and this is our runtime stack, and this will run on Windows. Then in the region, if you want, you can choose your Canada Central, for example, and this is our app service plan. You need to determine the location, features, cost, and compute resources that will be associated with our app. So this is a default plan. If you have your plan already, you can choose from this drop-down menu, or simply click on Create New to create a new plan. Simply give the name of that plan and click on OK. And then if you explore these pricing plans, you will see that we have popular options and some are legacy options. You have also production and dev test for less demanding workload. I will choose this standard S1 plan, and this is the popular plans, so you can save your time and choose one option from here. And then if you go to next, you can create a database, SQL. Let's go to deployment. You can add continuous deployment. If you enable this, then you can authorize with your GitHub account, choose your organization, repository and branch, and simply configure your workflow configuration. And in the authentication settings, you can also enable this option. Let's disable our continuous deployment. And then in the networking, I will enable this public access, and you can also enable network injection if you want. In the monitor and scale, by default there will be enable application insight. I will choose to no to my application insight, and then you can enable Defender for the app service, but there will be additional cost. And let's go on tags, review and create, and finally I will click on create to create our web app service. You can see all details and details for app service plan that we specified through this wizard. If you want, you can download the template for automation. So once that you download this template, then you can create a new web app just like this one. Our deployment is in progress. And after some time, our deployment is complete. If we go to a resource, in the overview option, you can see that we have our resource group, our status of our web app is running. You can stop this web app, restart this web app, delete, download, publish profile and so on. Our location is Canada Central. This is our subscription ID. You can add your tag if you want. There is our domain, default domain, our app service plan, standard one. If we copy this link and paste it here, you can see that our web app is running and waiting for our content. So our web app is ready to host some of our code, and then operating system in Windows, health check is not configured. If you go to our app service plan, you can also scale your app service plan. You can see that we have some additional graphics here for CPU percentage, memory percentage, data in and data out. So you can track the activity on your plan. Also you can delete this plan. And then in the properties, you can see all additional information, and our application insight needs to be enabled because we are choose to not enable this option when we created our resource. Also, there is a monitoring, logs, capabilities, notification and recommendation option that you can also use. This is our virtual IP address. This is our outbound address and additional outbound IP address. If I go to app service plan, we are now again in our app service plan, just where we already been. In the quotas, you can see the file system usage across our app service plan and apps. The threshold is 50 gigabytes and usage is only 9 kilobytes. Then you can change your app service plan. Simply in the app service plan, click on change app service plan, and then you can create new service plan to this resource group, or choose to delete this service plan, and then simply choose your service plan and click on select. The service plans are here, so you can drop an eye and see more details. There is some additional information here. In the development tools, there is an app service editor. If you open this editor, you can create or paste your code directly from here in this editor. and this is very useful if you want to test something or you have a small website that you want to be hosted here. And this editor provides an in-browser experience. As you can see, we have this root files and working files. Simply you can create a new file and add some, for example, HTML code, and this is our app editor. So we are getting the same address that we already see. If I click on right click, you can add new file folder, upload files, and then you can, for example, add default.html and add some message here, and if you type this address of our app service /default.html, that message will be shown into your browser. If you go to deployment, we have something called deployment slots. Deployment slots are live apps with their own hostname. You can click on add slots, for example slot 1, and then you can close settings from our app or do not close settings if you click to create a new slot. But be aware, you must have a minimum standard application app service plan if you want to use your deployment slots. If you go to deployment center, in the source option you can choose continuous deployment for your GitHub account, Bitbucket, local Git, or Azure repos, or manual deployment push from external Git. Then if you choose GitHub, you need to authorize. Our build is .NET, runtime stack, and version is 8.0. Then choose your subscription, choose your identity, and this is how can you connect and deploy and build a code from GitHub. In the deployment slot there is something called production and development slot. In this first step, in production, if you have some code, and in the second slot you will have some development code, and then you need to swap this slot fast. Simply click on swap, choose source, choose your target, and if you click on start swap, these slots will change their number. This slot 1 will be in the production slot, and this app 1011 will be our development slot. So this is how you can rotate your slots, and every deployment slot has its own address and code. This is very useful if you're developing some new options in your application, and then after some testing you can simply add the new option with the new code in this slot 1 and simply swap this slot, and there will be no interruption in the work of your application. This is very convenient if you're a developer. But this is something you must know for the exam. Also, in the setting option, there is something called environment variables. You can add these variables to your application. You can also choose your authentication type for your app, and scale up service plan or scale out service plan. So as you can see, it's very easy to work with app service, app service, and you can do almost everything that you want. Our slots are swapped. This is our environment variable app setting, and you have something called connection string. With the connection string option, you can collaborate with your application. And now, as you can see, if we hit on refresh, we have option to split this traffic between two slots. In software engineering, containerization is an operating system level virtualization of application level virtualization across multiple network resources, so that software application can run in isolated user spaces called containers in any cloud or non-cloud environment, regardless of type or vendor. Each container is essentially a fully functional and portable cloud or non-cloud computing environment that surround the application and keep it independent of the other environments running in parallel. Individually, each container simulates a different software application and runs isolated processes by merging related configuration files, libraries, and dependencies. But together, multiple containers share a common operating system core. Recently, containerization technology has been widely adopted on cloud computing platforms such as Amazon Web Services, Microsoft Azure, Google Cloud Platform, and IBM Cloud. There are two types of container: OS and applications. Container clusters need to be managed. This includes functionality to create cluster, upgrade software or repair it, load balance between existing instances, scale by starting or stopping instances to accommodate their number of users, logging activity, and monitoring of produced logs of the application itself by querying sensors. Implementations of such open source software include OCD and Rancher. A large number of companies provide container cluster management as a managed service, such as Amazon, Google, and Microsoft. Containers are technologies that allow application to be packaged and isolated within entire execution environment, all the file necessary to run. This makes it easy to move the contained application between environments like development, testing, production, etc., while maintaining full functionality. Containers are also an important part of IT security. By building security in the container pipeline and defending the infrastructure, containers remain reliable, scalable, and trustworthy. You can also easily move a containerized application between public, private, and hybrid cloud environments and data centers or on-premises with consistent behavior and functionality. Imagine you are developing an app. You do your work on a laptop and your environment has a specific configuration. Other developers may have slightly different configurations. The application that you develop relies on this configuration and depends on specific libraries, dependencies, and files. Meanwhile, your enterprise has development and production environments that are standardized with their own configurations and their own sets of support files. You want to emulate these environments as much as possible locally, but without all the additional cost of recreating the server environment. So how do you make your application work in these environments? Pass quality assurance and get the application deployed without major headache, rewriting and fixing. Answer is containers. The container in which your application resides has the necessary libraries, dependencies and files so that you can move it through production without unpleasant side effects. In fact, container image content created using open source tools can be considered an installation of a Linux distribution because it comes complete with RPM packages, configuration files, etc. But distributed container image is much easier than installing new copies of operating system. Virtualization allows you to operate your operating system, Windows or Linux, to run simultaneously on a single hardware system. Containers share the same operating system kernel and isolate application processes from the rest of the system. For example, ARM Linux system run ARM Linux containers. x86 Linux system run x86 Linux containers, and so on. Linux containers are extremely portable, but they must be compatible with underlying system. What does it mean? Virtualization uses a hypervisor to emulate a hardware, which allows multiple operating systems to run side by side. It's not as easy as using a container. When you have a limited resources with limited capabilities, you need lightweight applications that can be distributed. Linux containers run natively on the operating system, shared across all your containers, so your application and services remain lightweight and run quickly in parallel. Linux containers are another revolutionary leap in the way we develop, deploy, and manage applications. Linux containers images provide portability and version control, helping to ensure that what works on developer's laptop also works in production. A special type of a container image called the golden image creates a consistent, reliable basis for system configuration. Compared to VMs, running a Linux container requires less resources, has a standard interface like start-stop, environment variables, etc., retain the isolation of the application, and it's easier to manage as part of the larger application, like multiple containers. In addition, this multi-container application can be orchestrated across multiple clouds. This year, 78% of small and medium-sized businesses have adopted Kubernetes to manage containerized applications. Cloud developers and DevOps engineers may be familiar with the complexities of running containerized application on a massive scale. Sometimes challenges can arise in networking, orchestration, security, monitoring, storage, even compliance. Instead of running Kubernetes, the usual Kubernetes tools, there is an easy way to manage containerized application. This is where Azure Kubernetes Service, or AKS, comes in. It helps manage all containerized application deployed on Azure Kubernetes with ease. With capabilities such as enhanced networking, built-in monitoring, and Azure DevOps pipelines, Azure Kubernetes Service simplifies the management of containerized application in the Azure cloud through integration. It is compatible with both Windows and Linux nodes and provides high availability through automatic scaling and self-healing. AKS provides efficiency and reliability for a range of application workloads in multiple cloud settings, enhancing cloud-based development. The Azure Kubernetes Service makes it easy to set up and manage Kubernetes clusters on Azure. AKS relieves developer and administrators of important duties such as maintenance and health monitoring. Users can manage agent nodes when using AKS and pay for them. There is no cost to automatically deploy Kubernetes master nodes, plus additional capabilities can be configured with Microsoft Entra ID, such as advanced networking, monitoring, and interaction. In addition, AKS clusters can be created through Azure Portal or Azure CLI. This is another primary option that AKS offers. As containers are increasingly prioritized for managing, deploying, and packaging applications in the cloud, Azure Container Instance can serve as a reliable option, and it helps to bypass the management of a virtual machine. Because Azure VMs have a lot of overhead, container instances are useful because they start in seconds. By using the cache of widely used images of the underlying operating system, ACI or Azure Container Instances speed up the deployment of images, whether they are images imported from Windows or Linux containers from Docker registries. Azure Container Instances, or ACI, use container groups and amalgamation of containers that run on a single host. In a group of containers, containers share storage capacity, local networks, resources, and lifecycle. It's similar to Kubernetes. AKS uses Kubernetes scalability features. Horizontal Module Autoscaling or HPA allow users to automatically scale and modify the number of modules in a deployment based on the CPU utilization or other selected parameters. Alternately, AKS capsules can be scaled manually. What about pricing? Azure Container Instances charges user for the working time of each group of containers. These groups are a set of virtual CPU and memory resources that can be used by one or more containers. AKS charges for virtual machine that power worker nodes and storage of networking resources consumed by clusters. Azure Kubernetes Service pricing maintains a hosted Kubernetes environment at no cost. Users are free to determine what type of virtual machine will be used in cluster, how many nodes are needed, and how long they will run to estimate cost. In security for both of these services, Azure Virtual Networks provide private and secure networking for Azure resources, and on-premises applications are available through ACI. In addition, group of containers can be deployed in virtual network with Azure Container Instances or ACI, enabling secure communication between ACI containers. It also applies other group of containers in the same subnet, local resources accessed by ExpressRoute or VPN Gateway, and database in an equivalent virtual network. With Azure features such as network security groups and managed cluster updates, AKS combines all the features of the native Kubernetes security service. Regular maintenance of software module is essential for security. AKS automatically makes it easy to run clusters on the most up-to-date version of Kubernetes and operating system, including security updates. In addition, AKS secure traffic under a sensitive password. Customers can seek Azure Kubernetes consulting support to receive insight and guidance from experts to get the most of their Kubernetes deployment in Microsoft Azure. Also, there is a possibility during the creation of AKS service to enable integration with Azure Container Instances service when we get additional containers or virtual nodes which are hosted in the same resource group as the AKS cluster. In the picture in front of you, you can see the difference between Azure Kubernetes service and Azure instances, container instances. Containers and virtual machines, or VMs, are two approaches to packaging computing environments that combine different IT components and isolate them from the rest of the system. The main difference between the two is which components are isolated, which in turn affects the scope and portability of each access. A container is a unit of software that contains all the components and functionalities needed to run an application. Most modern applications consist of multiple containers, each of which performs a specific function. Containers are typically measured per megabyte and do not use a hypervisor and are generally considered a faster, more agile way to handle process isolation. One of the most important factors to contribute to the success of the container is portability. Similar to the interconnection of Lego bricks, the individual containers can be easily swapped and moved to different environments. Once an application and its dependencies are packaged in a container, it can be deployed whether or wherever it is needed. For example, a developer or administrator laptop, a data center, the cloud, or the edge, with the expectation that it will function exactly the same. Docker is an open source platform for building, deploying, and managing containerized applications, has played a major role in the evolution of container technology over the years. Virtual machines play a key role in the cloud computing, mimicking physical computers and running operating systems in isolated instances. Multiple VMs are typically hosted on a single server, with a hypervisor acting as a lightweight software layer positioned between the physical host and the VM. This hypervisor efficiently manages access to resources, allowing virtual machine to function as different server while offering improved flexibility and agility. It initially gained popularity in the 2000s due to its consolidation and cost-saving initiatives, and the use of VMs has evolved over time. Organizations have matured their VM implementations, expanding beyond consolidation to embrace different use cases. This includes providing on-demand resources for application and optimizing access to expensive resources such as GPUs. VM also served as the foundation of many early cloud computing environments, facilitating resource virtualization and supporting more release and isolation that is more client running systems that share the same resources. Virtual machines contain their own operating system, allowing them to perform multiple resource-intensive functions at the same time. The increased resources available to VM allow them to abstract, share, duplicate, and emulate entire servers, operating systems, desktop, databases, and networks. The real question is how virtual machines work and how container works. Software called hypervisor separates resources from their physical machines so that can be shared and dedicated to VMs. When a user issues a VM instruction that requires additional resources from the physical environment, the hypervisor forwards the request to the physical system and caches the changes. VM looks and acts like a physical server, which can multiply the disadvantages of application dependencies and large operating system footprints, a footprint that is generally not required to run a single application or microservice. Everything inside the container is packaged and sent using the container image, a file that includes all libraries and dependencies. Container images files are similar to software installation packages such as RPM in Linux, but those that only need a compatible kernel and container execution time to run the application regardless of which OS was used to create the container or where the libraries within the container originated from. Because the containers are so small, there are usually hundreds of them loosely connected together, which is why container orchestration platforms such as, for example, Red Hat OpenShift and Kubernetes are used to secure and manage them. There is a few useful programs that can you help to create a virtual machine on your laptop. One of them is Oracle Virtual Box Manager. So if you want, you can create your simply VM, but first you need to download the image and then you need to create your virtual machine. I will not go to the process of creating a VM. I just wanted to show you that I have these VMs here. One is VM1, this is Ubuntu VM, and I have the second one is Ubuntu Server. If I, for example, click on this VM and click on Start, this VM will power up, and as you can see, after some time it will starting to boot our device with this Linux operating system, and after some time I will be able to log in to my VM with my username and password, and as you can see, I'm able to work just like this is a real VM. So I can, for example, run a terminal from here and then run some command to update my system, and this is how it works. So as you can see, with the help of this Oracle VirtualBox, I can create my VMs. You can create virtual machine based on Windows image and based on Ubuntu desktop image, or for example Windows Server. Let me try again, just to show you how it looks like to update your virtual machine, which is of course separated and isolated from your Windows operating system. Of course, I run this Ubuntu virtual machine on my Windows laptop. Also, I run some of my virtual machines on my macOS. So this is how can you install work with your virtual machines. Also, you can update your machine work like this is a normal VM. Thank you for watching, and I hope this was helpful. I'm sure you heard of Docker in the previous chapters, so it's time to get to know what Docker is. Docker is a set of platform as a service or PaaS products that use OS level virtualization to deliver software in packages called containers. The service has both free and premium levels. The software that hosts the containers is called the Docker engine, and it was first released in 2013 and developed by Docker Incorporated. Docker is a tool used to automate the placement of application in lightweight containers so that application can run efficiently in a variety of isolated environments. Containers are isolated from each other and bring together their own software, libraries, and configuration files. They can communicate with each other through well-defined channels because all containers share the service of a single operating system core. They use fewer resources than the virtual machine. Docker can package an application and its dependencies into a virtual container that can run on a Linux, Windows, or Mac OS computer. This allows the application to run in a variety of locations, such as on-premises, public, or private cloud. When running on Linux, Docker uses Linux kernel resource isolation features such as C groups or kernel namespaces and a union-capable file such as overlay fs to allow containers to run within a single Linux instance, avoiding the overhead of running and maintaining virtual machine. Docker on macOS uses a Linux virtual machine to run containers. Because Docker containers are lightweight, a single server on virtual machine can run several containers at a time. A 2018 analysis found that a typical Docker use case involves running 8 containers per host, and that a quarter of the organization analyzed are running 18 or more per host. It can also be installed on a single board computer such as Raspberry Pi. Linux kernel support for namespaces generally isolate the app view from the operating environment, including process trees, network user IDs, and mounted file system, while kernel C groups provide resource limitation for memory and CPU. Docker implements a high-level API to provide lightweight containers that run processes in isolation. The Docker registry is a repository for Docker images. Docker clients connect to registries to download or pull images for use or upload push images that they have created themselves. Registries can be public or private. The main public registry is the Docker Hub. Docker Hub is the default registry where Docker searches for images. Docker registries also allow you to create event-based notification. Azure Container Registry, as we see in the previous chapter, allows you to create, store, and manage container images and artifacts in a private registry for all types of container deployments. You can use Azure Container Registry with existing pipelines to develop and deploy containers. You can use Azure Container Registry task to create container images in Azure on demand, or automate builds that run source code updates, base container images, updates, or timers. Azure Container Registry is a managed registry service based on the open source Docker Registry 2.0. You can create and maintain Azure Container Registry to store and manage container images and related artifacts. Also, you can build on demand or fully automate builds with triggers such as source code commits and base image updates. In this chapter, I will show you how can you create an image-based resource. So let's create our Azure Container instances that we have talked about in some of our previous chapters. I will go to my resource, to my marketplace, and right from here I will type Azure Container Instances. We need to choose our instance by Microsoft Publisher and click on Create. We need to specify our subscription, our resource group. I have existing resource group. If you don't have, simply click on Create New and you will create a new group, resource group. Then we need to specify our container name. Choose my region. If I want, I can specify availability zone. You can choose SKU before standard and premium, and then in the image source you have something called quick start images. From image drop down menu you can choose between 3 images: Hello World on Linux, Nginx Alpine on Linux, and some from Windows, sample web server or sample Linux web server. I will choose my Hello World image. Also, if you have something called Azure Container Registry, you can add this image. Choose a container registry, of course, choose your image and choose your tag. Also, Azure Container Registry is a separate resource that hosts images in Azure Cloud. And you have some other registry if you want. You can add this My Docker images from Docker Hub that will use the container registry, and the latest version of the image will be pulled from that resource. Then, when you specified our images, you can choose to spot container, and spot containers to get a discount, and spot containers are not available in North Europe region. If you choose some other region, then you can check this box. Then after we specified our image, we need to change size of our container. You can see that we have option to specify from 1 to 4 CPU containers, cores, and you can specify from 1 to 16 gigabytes of memory, and if you want you can choose your GPU type, but that is very expensive option, so I will not use this GPU for now. Then you can choose your networking type. In public it will create a public IP address for your container instance. Private will allow you to choose a new or existing virtual network for your container instance, and none will not create either public IP or virtual networks, but you will still be able to access your container using some command line like PowerShell or Azure CLI. I will choose my public IP address. Private is not available with availability zone. Then if you specify DNS label zone, you can add a name for this DNS name for this container, and in the ports I will add this port 80 and TCP protocol 80. I will create this insight. This will create a new log analytics workspace for our logs, and these logs will be stored in this log analytics workspace. In that one option there is something called restart policy, so your container will be restarted on failure or other two options, as you can see. And then there is something called Microsoft managed key or customer managed key, you can see. But let's make it simple. I will not try to confuse you. Just hit review create and hit on create to create our first Azure container instance. And in the insight option I will uncheck this box, so we will not create our log analytics workspace. Just make it very simple. We will create our Azure container instance based on our hello world image. Our resource is complete. Let's go to our resource, and as you can see, this is our container with running. You can restart, stop or delete this container. You can see the name of our resource group, status is running, location in North Europe, zone 1 that we specified. This is our subscription ID. We don't have any tag. This is a standard option. There is a Linux operating system. We have one container, and there you can see these graphics for CPU, memory, network bytes received and transmitted. If you click on resource JSON, you can see your resource ID, version, and this whole resource in JSON file, JavaScript object notation, or simply JSON. And then, as I already told you, in these graphics you can see if there is any activity. If you go to settings, you can see your container. This is our container. This is our image. State is running. Previous state, we don't have any previous state, and this is our start time. In the events, you can see some activities when our container started, when this pulling image from Docker Hub started, and it is successfully pulled image, and by first timestamp and last timestamp. In the memory you can check your metrics, alerts and logs, and also if you want to see your public IP address, you will need to add this image or choose your image from Azure Container Registry. So in the properties you can see all fully qualified domain name or FQDN or domain name system. If you go to tags, you can add your tags here, and in your overview you can choose to stop, restart or delete this container. If I hit on restart and click on yes, I will restart this container. So we are restarting our container. And if you go to our container in the settings blade, you will see that our state of our container is running, but we are killing our container, and then it is count 2. You can track all your events, and after some time we successfully restarted our container and it's running again. If you go to containers, you can see that our state is running, and if you stop your container, yes, I want to stop, we successfully stop our container. Let's go to containers. You can see our previous state is running and our state is terminated. So you can track all your changes here. Let me now start my container instance, of course. So you can track your containers count, and in the CPU graphic you will see that we have some spike with the CPU, and every activity you can track with these graphics. As you can see, now we have again pulled and started our container and our state is running. In the control access IAM, I can have an option to add a role to my user. If I go to add role assignment, I can choose job roles and privileged administrator roles. If you have this contributor role, it will grant a full access to manage all resources, but does not allow you to assign a role for this service. Then you will go to members, choose access for user groups, service principal, choose your member, and add additional settings. Let's select one of our member. I will choose myself, click on select, click on next, and then you need to choose, for example, highly recommend privileges or fewer privileges, what user can do. And once that you're satisfied with your assignment, simply click on review and create, and this role will be added to myself. If I go to role assignment, you can see that I'm the owner of this resource. Later in this course we will learn more about role-based access control. So this is how can you add a role to this container instance. And that after some time you can see that we have some activity in our graphic, like CPU, memory, network bytes received, and network bytes transmitted. So every activity will be shown here. Now if I click on delete, I will delete these container instances in this group. Azure Virtual Desktop, formerly known as Windows Virtual Desktop, is a Microsoft Azure based system for virtualizing its Windows operating systems, securing virtualized desktops and applications securely in the cloud, over the internet, using a remote desktop protocol. It is intended for business users, not individual users. Windows 10 and 11 Enterprise Azure Multi-Session Virtual Desktop is a cloud-based alternative to an on-premise remote desktop server or RDS. Azure Virtual Desktop is deployed in the Azure cloud as a virtual machine. License costs are already included in the several Microsoft 365 subscriptions, including Microsoft 365 Business Premium or Microsoft 365 E3. Azure Virtual Desktops can be accessed using by Remote Desktop Client for Windows, also called Azure Virtual Desktop, on Windows and with Microsoft Remote Desktop on other platforms, including the web. Other clients that are not Microsoft Remote Desktop Protocol can also be used to connect to Virtual Machine Desktop. Azure Virtual Desktop support Windows 10 and 11 with multiple sessions, Windows 10 and 11 with a single session, and Windows Server 2012 R2 and later operating system. With Azure Virtual Desktop, you can set up a scalable and flexible environment, create a full desktop virtualization environment in your Azure subscription without running a gateway server. Flexible configuration to adapt to your different workloads, and you can bring your image for production, workloads or test from the Azure Gallery. You can reduce cost with federated resources for multiple sessions with the new multi-session capability for Windows 11 and Windows 10 Enterprise exclusive to Windows Desktop, Virtual Desktop or Windows Server. You can greatly reduce the number of virtual machine and operating system while providing the same resources to your customer. And also you can secure individual ownership through personal or permanent desktop. Automatically increase or decrease capacity based on the time of day, specific days of week, or as demand changes, with auto-scaling helping to manage cost. Then, if you use the Azure portal or Azure CLI PowerShell and REST API, you can create and configure host sets, application groups and workspaces. You can assign users and publish resources. You can publish the entire desktop or individual applications from a single set of hosts, create an individual application group for a different user group, or even assign users to multiple application groups to reduce the number of images. As you manage your environment, you can use built-in delegated access to assign roles and collect diagnostic to understand various configuration or user errors. You can get key information and metrics about your environment and the users connected to it with Azure Virtual Desktop Insight. You can manage only the image and virtual machine you can use for sessions in your Azure subscriptions, not the infrastructures. You don't have to personally manage supporting infrastructure roles such as a gateway or broker as you do with remote desktop services. Once assigned, users can connect to their published Windows desktops and apps using Windows App or the remote desktop client. Connect from any device through the native app on your device or using a web browser with the HTML5 web client, and then you can securely establish users via reverse connection to the service so you don't have to open any inbound port. Serverless computing allows developers or administrators to build applications faster by eliminating the need to manage infrastructure. With serverless applications, a cloud service provider automatically provisions, scales, and manages the infrastructure needed to run code. In understanding the definition of serverless computing, it is important to know that servers still use code. The name serverless comes from the fact that the tasks associated with securing the infrastructure and managing it are invisible to the developer. This approach allows developers to increase their focus on business logic and bring more value to the core of the business. Serverless computing helps teams increase their productivity and bring products to market faster, while enabling organizations to better optimize resources and stay focused on innovation. There are a large number of benefits that serverless computing brings, so we will list a few. Unmanaged infrastructure management is enabled. The use of fully managed services allows developers to avoid administrative tasks and focus on basic business logic. With a serverless platform, you simply upload your code and it works with high availability. Dynamic scalability. With serverless computing, the infrastructure dynamically scales in and out within seconds to meet demands of any workload. Serverless application reduce operational dependencies on each development cycle, increase the agility of development team to deliver more functionality in less time. Moving to serverless technologies help organizations to reduce total cost of ownership and relocate resources to accelerate the pace of innovation. Developers build serverless applications using a variety of application patterns, many of which are aligned with approaches already known to meet specific requirements and business needs. Serverless workflow use a low-code or no-code approach to simplify the orchestration of combined tasks. Developers can integrate different services either in the cloud or on-premises without coding those interactions, without having to maintain sticky code or learn new APIs or specification. Serverless function accelerate development by using an event-driven model with triggers that automatically execute code to respond to events, and binding to seamless integration of additional services. The pay-per-execution model with sub-second billing charges only for the time and resources required to execute the code. With the serverless application environment, both the backend and the front end are hosted on fully managed services that address scaling, security, and compliance requirements. Serverless API Gateway is a centralized, fully managed entry point for serverless backend services. It allows developers to publish, manage, provision, and analyze APIs on a global scale. Serverless Kubernetes developers bring their own containers to fully manage Kubernetes orchestrated clusters that can automatically scale up and down with sudden changes in traffic on high-speed workloads. Serverless access offers developers, team, and organization a level of abstraction that allows them to minimize the time and resources invested in managing infrastructure Every component of the application benefits from this approach, from computing and database engine to messaging, analytics and artificial intelligence, or AI. Using an end-to-end serverless platform that provides a comprehensive set of serverless technologies is the best way to ensure that organization gets the maximum benefit from going serverless. Now that we are familiar with the terms serverless and Azure, it's time to take a look at the two most important resources that are important to us to pass this exam. Azure Functions are serverless solution that allows you to write less code, maintain less infrastructure, and save on cost. Instead of worrying about setting and maintaining servers, cloud infrastructure provides all up-to-date resources needed to maintain your application. You focus on the code that matters most to you, in the most productive language for you, and Azure Functions take care of the rest. Azure Functions is a serverless computing service that allows a user to run code that triggers an event without having to provision or manage infrastructure. Because the service is trigger-based, it runs a script or piece of code in response to various events. Azure Functions can be used to achieve separation, high throughput, reuse, and sharing. Since it is more reliable, it can also be used for production environment. Azure Functions are individual functions created in a function application. Each function can be invoked using a configured trigger. The Azure portal provides capabilities for creating, managing, and tracking and integrating inputs and outputs of Azure Functions. Azure functionality can also be tested by providing some raw inputs. When it comes to monitoring functions, the portal offers solution as a live status monitoring app insight through call logs. Functions in a function app can be monitoring based on the metrics of the application. By default, for any Azure function, the execution of a single function has a maximum of 5 minutes to execute. If a function runs longer than the maximum timeout, the Azure Functions runtime can end the process at any time after the maximum timeout is reached. Azure Functions support multiple languages and is based on runtime versions. So we have Azure Functions that support 1.0, C#, F#, JavaScript. Then we have Functions point 2, Azure Functions 2.0 support C#, JavaScript, F#, Java 8, PowerShell Core 6, Python 3.7, and TypeScript. And then here we have Functions 3.0. This is a preview version that supports C#, JavaScript, F#, Java, PowerShell, Python, and TypeScript. Azure Functions can be invoked when triggered by events from other services. Because it is event-driven, the application platform has the capabilities to implement event-driven code that occur in the third-party service or on-premises systems. With slots, Azure Functions can work in different instances. A different environment or function can be exposed to the public by API provided by the slots. When functions need to be maintained in different environments, such as production, development, and scene, slots will be the choice. The instance will be mapped to the production environment and can be replaced on demand. Replacement can be done through the portal or Azure CLI. The pricing of Azure Function application is based on execution time and the total number of execution. It includes a free monthly consumption of 1 million requests and 4 million gigabytes or 4 gigabytes of resource consumption per month. Azure Functions are suited for smaller applications that have events that can run independently of other websites. Some of the common Azure features are sending emails, running backups, processing orders, scheduling tasks such as database cleanup, sending notification, messages, and processing IoT or Internet of Things data. The feature provides serverless computing for Azure, and you can use a lot of features of these functions to create web APIs that will respond to database changes, and then process ITO flows, manage message queues, and more. Because Azure Functions can connect to many other applications running on-premise or in the cloud, making it a serverless offering, it provides better scalability and efficiency. Azure Durable Function is an extension of an Azure function that is used to write functions with a state. It consists of an orchestrator function and an entity function that can be defined as a workflow. As a state-based service, it enables a checkpoint and restart point. Azure Durable Functions support languages such as C#, Java, and F. Azure functions are charged on a pay-as-you-go basis, but for the initial start, Azure provides you with 5 GB of free bandwidth. Everything above that, it will be charged as a use. However, Azure Functions can be used for free with Azure IoT Edge. When you create a functional application in Azure, you need to choose a hosting option for your application. Azure provides you with several hosting options for your function code. First is consumption code. Pay for computing resources only when your functions are up and running with automatic scale. On a consumption plan, host instances of function are dynamically added and removed based on the number of incoming events. Flex consumption plan achieve high scalability with selection, virtual networking, and pay-as-you-go billing. In the flex consumption plan, functions host instances are dynamically added and removed based on the configured concurrency per instance and the number of incoming events. And then we have premium plan, automatically scales based on demand using preheated workers who run applications without delay after they are inactive, runs on more powerful instances and connects to virtual networks. And last one is dedicated plan. In this plan, you can run your functions within the app service plan at the regular prices of the app service plan, best for long-term scenarios where permanent functions cannot be used. Container apps create and deploy features based on apps in containers in a fully managed environment hosted by Azure Container Apps. You can use the functions programming model to build event models, serverless native functions in the cloud. You can run your functions with the other microservices, APIs, websites, and workflows as program hosted in container. We are in our Azure portal, and let's see how can we create our function app. Let's go to create a resource. We are in our marketplace, and I will simply click on create to create this function. Then we need to choose our function app plan between consumption, flank consumption, functions premium, app service, and this container apps environment. In our theoretical part of this chapter, I'll introduce you with all of this function app plan, and now I will choose this function consumption plan, click on select, and then we need to fill this form to complete the creation of our function app. The first thing we need to do is to, as we already know, to choose our subscription, create our resource group, or simply choose one if you already have one. I will create a new one. Then I will add a function app name. As you can see, .azurewebsite.net is the full address of this function app name, and this name must be unique. Then I will choose my runtime stack. I will choose my Node.js, but you can choose from .NET, Node.js, Python, Java, PowerShell Core, or custom handler. I will choose my Node.js. This is 20 LTS version. Region is Canada Central. My operating system is Windows. Then from the storage, I will click on Next. This is a storage account, so when you create a function app, it automatically creates a storage account, because simply you need to have this account if you want to work with function app. Also, it is checked automatically to add an Azure Files connection. Let's go to networking. I will enable this public access. You can disable it. It was enabled by default, just to let you know. In the monitoring option, you can choose between enable or disable to enable application insight, and then it will create this application insight. Application Insight is a service for developers and DevOps professionals. It enables to automatically monitor your application, and you can also detect if there is some anomalies, and there is lots of powerful analytics tools that you can use to see if what actually is going on with the users and with your app itself. Let's go to the deployment. I will keep this disabled. Continuous deployment, we don't need GitHub account to authorize with this function app. And finally, we will go to tag and review and create our function app. Just like in any Azure resource, in the review and create, you can review all that you set up in the previous tabs. And finally, we are submitting our deployment. And after some time, our resource is complete. We will go to our resource. So as you can see, this is our function app, and just like with any other resource, we have option to see some essential information. Also, we have option to start or restart this function app. Our app is running in Canada Central. We don't have any tags. This is our default domain. As you can see, our operating system is Windows, and App Service plan is our App Service plan, and this is the runtime version. So you can see every little information that you need. I will just show you some basic information with these blades, but we need to go in the functions and click on create functions. First, we need to select a template, and we need to select a trigger. Trigger describe everything what you want for a certain service, and trigger describe the type of events that invoke your function. I will choose this HTTP trigger, and this function will be run whenever it receives an HTTP request, responding based on data in the body of query string. So let's choose our HTTP trigger. And click on next. As you can see, there is a various services that you can use with this function. If you want to learn more about functions and, for example, association with Cosmos DB trigger, then you can find it on my course for Azure Cosmos DB. Then this is a function template. We need to add function name and choose our authorization level from function, anonymous or admin. I will simply leave as it is and click on create, and we are creating our trigger function. our function is complete and we are automatically in code plus test page, where you can see everything like integration, functions key, invocations, logs and metrics. And now we are automatically connected to our application inside. And if you go back to our functions, you can see that we have our function that we created. And then this is an HTTP trigger, status is enabled, and if I click on three little dots, you can disable or delete these functions. So let's go inside our function in the code plus test page. We are connecting to application inside, and we are successfully connected. If I click to test and run this application, there will be an input that provides parameters to test this HTTP request, and request can be found in the output tab. Let's choose our post. In the query parameters, in the name, I will choose my value. Then you need to add the name. In the value, I will add this value as Azure, and then I will click on run. And then we are automatically in our output page. As you can see, hello Azure, this HTTP trigger function executed successfully in our response context. And then we have HTTP code, which is 200, and whenever it's 200, it is a good sign, so our app working. In the log, as you can see, in our application inside, you can see that our function run with and it's executing HTTP trigger 1, and what was sending, posting, JavaScript HTTP trigger executed, and the time it was succeeded, and duration is 4 milliseconds. So this is how can you get these logs and check more granularly how this trigger was executed, this operation. So this was a new demo. I hope you learned something new, and in the next chapter we will learn more about logic apps, so you can see how can we work with our logic apps. Azure Logic Apps is a cloud-based platform where you can create and run automated workflows with little or no code. By using a visual designer and choosing from pre-built operations, you can quickly build a workflow that integrates and manages your applications, data, services, and systems. Azure Logic App simplifies the way you connect outdated, modern, and the state-of-the-art systems across cloud, on-premises, and hybrid environments. You can use low-code, no-code tools to develop highly scalable integration solutions that support your enterprise and business B2B scenarios. The Azure Logic Apps integration platform provides more than 1,000 pre-built connectors, so you can connect and integrate apps, data, services, and systems more easily and quickly. You can focus more on designing and implementing the business logic and functionality of your solution, while spending less energy figuring out how access to your resources. To communicate with any service endpoint, run your own code, control the structure of a workflow, manipulate data, or connect to the most commonly used service with a better performance, you can use built-in connector operations. These operations are natively run in Azure Logic App runtime for faster performance. To access and interact with resources in services such as Azure, Microsoft, other external web applications and services, or on-premise systems, you can use Microsoft Managed Connector Operations. Azure Logic Apps is a fully managed by Microsoft Azure, which frees you from the hassle of hosting, scaling, managing, monitoring, and maintaining solution built with these services. When you use these services and capabilities to create serverless application and solutions, you can only focus on business logic and functionality. These services automatically adapt to your needs, make integration faster, and help you build a robust cloud application using little to no code. You probably wondered what's the difference between Azure Functions service and Logic App services. When it comes to triggers, Azure Functions can be run using a configured trigger such as HTTP trigger, timer trigger, queue trigger, and more, while Azure Logic Apps can be run using an API as a connector. It can also have more triggers in the course of work. Azure Logic App can be run using an API as a connector. It can also have more triggers in the course of work. Defining a workflow in Azure Functions can be defined using the Azure Durable function, consisting of an orchestration functions that has a workflow defined with several activity functions. A workflow for Azure Logic Apps can be defined using the Logic App Designer using various API as a connector. Both services can be monitoring via Azure Monitor and Log Analytics services. If you go to our marketplace in our Azure portal, I will search for Logic App, then hit on Create, and then we need to choose our hosting option. You have Consumption and Standard. There is Multi-Tenant, Workflow Service Plan, and App Service Environment version 3. I will choose my Workflow Service Plan and this single tenant runtime with app connectors and scaling features for dedicated with compute, VNET integration for networking, and pre-workflow service plan instance as a pricing. Then I will choose my Azure subscription, create a new resource group, click on OK, add a name for this Logic App, choose my region, choose my Windows plan. You can simply leave this by default. If you have some plan, you can select from drop-down menu or simply click on Create, add the name for this App Service plan, and hit on OK. This is our pricing plan. This is most popular plan. You can choose from one of these plan. I will choose this most this plan is good for me for now. And in the zone redundancy, you can choose to enable our service plan in the apps and disable. Then if you go to storage, there is an automatically selected to create a storage type. You can choose between SQL and Azure Storage or simply just Azure Storage. Then you can add your name, your account name, or simply choose leave to Microsoft to create a new one. I have one from our previous chapter when we created our function app, and I can choose that if I want, but let's use this default option, and I will not configure my diagnostic setting for Blob for now. In the later parts of the course, in this course, I will introduce you with the storage accounts. Then I will enable this public access, and I will leave this and off for enable network injection. So you can see what is this for. And if you go to monitoring, you can create enable application insight, and this will be our application insight created in the same region. Let's go to tags and review and create, and finally I will hit on create. and we are creating our logic app. Our resource is created. Let's go to our resource. As you already know, in this essential information, in the overview tab, you can see stop or restart this logic app. This is our resource group. Our status is running. This is our default domain, and you can see operating system, app service plan, and runtime version. Our domain and health check is not configured. Everything that we specified in our wizard when we created our logic app. And then if I click on create a workflow in a designer, or simply go to workflows, you can click on workflow blade and add a new one. You can choose to add a new one or add one from existing template. We need to add our name and choose our state type. Stateful is optimized for high reliability and ideal for process business transitional data, and stateless is optimized for low latency, ideal for request response and processing IoT events. So you can choose between these two workflow types, but first we need to add a name for our workflow for this logic app. Let's hit on create. Our workflow is successfully created. Let's go inside that workflow, and then in our workflow now we have some logic app. The name of our logic app, status is enabled, state type is stateful, we don't have URL for our workflow, trigger type is not setting, health status is healthy, and runtime version. If you go to developer and go to our designer blade, from here we can create our logic apps. But first we need to choose our trigger. As you can see, there is parameters and code view. If you go to code, you can add your code here and save this in JSON file, of course, or simply you can design from this. First we need to add a trigger. As you can see, there is a lot of triggers that you can choose from. I will choose my email. Let's choose our Gmail trigger. Every time when a new email arrives, we will now create a connection. First we will add our connection name, and then for authentication type you can choose to use default shared application. But first we need to sign in to create a connection to Gmail. Then next step is to add another action. So if you choose an action from here, you can search Gmail, and then I will choose my get email option. When a new email arrives, every time when new email arrives on my account, I will be using this action, and then I will add another action. Let me search Gmail connector, then get email, notify me, and then delete this email. And then I will click on save. So this is how can you build your logic app. So every time when a new mail arrives, notify me. Azure Virtual Network is a service that provides the basic building block for building your private network in Azure. A service instance or virtual network enables many types of Azure resources to securely communicate with each other, the internet and local networks. These Azure resources include virtual machines or VMs. A virtual network is similar to a traditional network that you can manage in your own data center, but it brings additional benefits to Azure infrastructure such as scale, availability, and isolation. By default, all resources in the virtual network can communicate with the internet. You can also use a public IP address, NET gateway, or public load balancer to manage outbound connections. You can communicate inbound with the resource by assigning a public IP address or a public load balancer. When you use an internal load balancer, outbound connectivity isn't available until you define how you want the inbound connections to work with an instance-level public IP address or a public load balancer. Virtual networks and subnet encompass all availability zones in a region, so you don't need to divide them by availability zone to customize zonal resources. For example, if you're configuring a zonal VM, you don't need to consider the virtual network when choosing an availability zone for the VM. The same goes for other areas. This is no charge for using virtual network, it's free. And then standard fee applies to resources such as VM and other products. Communication between Azure resources is done using virtual networks where, from a security point of view, we can be sure that our resources will communicate. An example in VMSS in AKS, virtual network service endpoints, and you can extend the private address space of your virtual network and the identity of your virtual network to Azure service resources through a direct connection. Examples of resources include Azure Storage accounts and Azure SQL database. Service endpoints allow you to provision critical Azure service resource only on the virtual network, and the virtual network peering, virtual network can connect to each other using virtual network peering. Resources in any VNet can then communicate with each other. The virtual network that you connect can be in the same or different Azure regions. One of the advantages of virtual network in the cloud is that we can connect with other virtual networks and computers in our on-premises environment. These types of connections can be point-to-site VPN. Communication is established between a single processor in our network and on-premises VNet, site-to-site VPN connection, communication between a VPN gateway in our network and a VPN device in an on-premise net environment, and ExpressRoute, a connection between our network in an on-premise environment and an on-express service partner. In our VNet environment, we can filter traffic between subnets using network security group. Network security groups and application security group can contain multiple inbound and outbound security policy. These rules allow you to filter traffic to and from resources by source and destination IP address, port, and protocol. A network virtual appliance is a virtual machine that performs a network function such as a firewall or WAN optimization. By default, Azure routes traffic between subnets, connected virtual networks, on-premises network, and on the internet. You can apply one or both of the following options to override the default routes that Azure creates. Route tables. You can create a custom route table that controls where traffic is routed for each subnet. Border Gateway Protocol routes or BGP routes. If you connect your virtual network to your on-premises network by using Azure VPN Gateway or an Azure ExpressRoute connection, you can propagate your on-premises BGP routes to your virtual networks. Subnets or subnets allow you to segment a virtual network into one or more subnet and assign each subnet of portion of the virtual network address space. You can then deploy Azure resource to a specific subnet. Just like in a traditional network, subnets allow you to segment the address space of a virtual network into segments that are appropriate for an organization's internal network. Segmentation improves the efficiency of address allocation, and you can provision resources within subnet by using network security groups. Address space. When you create a virtual network, you must specify a custom private IP address space using public and private addresses, RFC 1918. For example, Azure assign resource to a virtual network a private IP address from an address space that you allow. For example, if you deploy a virtual machine in a network with address space 10.0.0.0/16, the virtual machine is assigned a private IP address such as 10.0.0.4. The virtual network is limited to a single region or location. However, multiple virtual networks from different regions can be connected together using virtual network peering. The virtual network peering is limited to a subscription, and you can deploy multiple virtual networks within each other with each Azure subscription and Azure region. However, before you start getting acquainted with virtual networks and the listed resources, it is necessary to note a few things that need to be taken into account. Be sure to make your virtual network address space or CIDR block does not overlap with other network brands of your computer. Your subnet should not cover the entire address space of the virtual network. Plan ahead and reserve some address space for the future. It is recommended that you have fewer large virtual networks rather than more small virtual networks to prevent unnecessary management costs. Secure virtual networks by assigning network security group or NSG to the subnet below them. Let's see how can we create our first virtual network. I'm in my Azure portal, and let's go to our create resource, to our marketplace, and then I will type virtual network. And finally, I will choose Microsoft as a publisher. This is our virtual network. Click on create, and again a virtual network. And we are now able to create our VNet. The first thing, as you already know, is to add some project details like subscription and a resource group name. If you don't have a new, create a new. Then we need to add our instance details such as VNet name and choose our region. This is our VNet name, and finally I will choose my region. And then in the security option, we have option to create virtual network encryption. To enable, we need to encrypt traffic traveling within the virtual network, and virtual machine must have accelerated network enabled for this. Then if I check this, it will create something called Azure Bastion. This is a paid service that provides secure RDP and HTTP SSH connectivity to our virtual machine over TLS over our browser. And then if we want to, we can check this box to enable Azure Firewall, which is a managed cloud-based defender. In the IP addresses, we can configure our address space and our subnets. Once you, in the security blade, enable all of these services, then will be automatically added here. As you can see, we have our default subnet and we have Azure Bastion subnet and Azure Firewall subnet. Our address space is default address space is 10.0.0.0/16, so we can create 65,536 address in this address space. And finally, this is our subnet 10.0.0 with 10.0.0/.255/24, so we have here 256 address, but Azure using the first 3 and the last 2. Also, if we click on this little pen, I can choose my subnet purpose for Azure Bastion, firewall management, force tunneling, virtual network gateway, or route server. And then if I choose one of these options, one of these subnet purpose, then it will create a separate subnet with that name. I will change my default subnet with the subnet A name, and this is my starting address 10.0.0, as you can see. And I will create my subnet, choose the size of my subnet /24, and I can have 256 addresses. IPv6 is included. There is something called private subnet. I can create my private subnet. Also, I can create a net right from here and simply click on save to save this subnet. Also, you can have this security to add your net gateway, network security group, or route table, so you can add all of this to your VNet. Also, you can create a service endpoint, create service endpoint policies, and so on. And finally, this is our subnet A. And as I already told you, if you check in the security tab, if you check this option to create some of these services like Azure Bastion or Firewall subnet, it will automatically create these subnets. But I will now delete all of this and go to tags, and finally I will click on review and create, and then we need to click on create. Finally, after seeing these settings, you can click on review and create, and you can also add a new subnet here if you want. You can also add IPv4 address space or IPv6 address space. And as I already told you in the theoretical part, it's very easy to work with the subnet in Azure. If I want to add a new subnet, I will click on add a new subnet, and I can also create 2 subnets in this VNet. Let's finally click on create to create our resource. And we are inside our resources. inside our resource, inside our virtual network, and you can see we have resource group, location, our address space, DNS servers. You can configure your flow timeout or BGP community strings. You can move this to another resource group, another subscription, or to another region. You can also delete this virtual network direct from here. And this is our virtual network ID. And there is some additional services that we can set up, like DDoS protection, Azure Firewall, peerings, Microsoft Defender for Cloud, and private endpoints. I have a separate course for virtual networks, AZ-900, so if you are interested to learn more about networks or networking in the Azure, you can find that course. And finally, this is our virtual networks ID. This is our services that we can create. And in the AZ-500 course, I explain in detail Defender for Cloud. If you go to topology, you can see that we have only one resource. This is our VNet. And if you go to settings blade, there is an address space. This is our address space that we created by default when we create our resource. You can add additional address space if you want. And this is the address space for virtual network is composed of one or more non-overlapping address ranges that are specified CIDR notation. If we go to connected devices, we don't have any connect devices, but if you're looking for example with Azure Kubernetes services, then there will be a lot of connected devices. Trust me, there is a lot of connected devices. Then we need to go to subnet. Also, you can export connected devices to CSV file if you need. If you go to subnet, there is our subnet A. This is our IPv4 subnet 10.0.0.0/24. There is 251 available IP addresses. As I already mentioned, 5 of them is already taken by Azure, so it said 256, but in the reality you can use 251. And this is very important from the exam perspective. And also you can see that we don't have any IPv6. We are not have delegated this subnet to any resource. There is no security group and there is no route table associated with this subnet. If I click on these 3 dots, you can pin this to dashboard, delete or manage users to add some role to this rollback access control to this subnet. So this is how you can create a VNet. Also there is something called gateway subnet, but let's focus our attention on this subnet. In the general purpose, I will choose this default subnet, then I will add a name for my subnet. As already mentioned, you can choose these pre-configured subnets. If you choose default, then you have option to add, for example, subnet B name. I will include IPv4 address space, and this is my address space that I want to use, and the starting address for this subnet B will be 10.0.1.0/24. So this is how can we create another subnet in our address space, in our virtual network, sorry. And you can choose your size. We successfully added another subnet to our virtual network. It is IPv4, and if you want to add another subnet, there will be 10.0.0.2.0/24. Let's create another subnet. Just for example, I will add this subnet C name. Then, as you can see, our starting address is 10.0.0, and now I can add this size. You can change the size, for example, /29, and then I will click on add. No matter what, there will be 10.0.2.0/29, and now we have 3 available IP addresses for this subnet. So, as you can see, it's very easy to manage all these properties, and if we want, we can create our subnet D. Choose our starting address and click on to add, and after that our subnet will be 10.0.6/24 with 251 address space added, and then I can add a new address space 10.1.0.0/16. I will click on save, and this will be new address space that we added, and then new address space for this virtual network. Address count is exactly the same like the first one, but it is important that this address space is non-overlapping. And if I go to our subnets and go to subnet to create a new one, let me add a name for this subnet. This will be subnet E, and then I can choose my IPv address range. I will choose this 10.0.0.0/16, and then click on OK, and we will have our subnet A, which is 10.1.0.0/24. So this is how can you work with various subnets and address spaces, and you can choose the size of your subnet, choose the name of your subnet, choose your address, and also you can edit your subnets. And choose the size of your subnet if you want to edit this, and simply click on save. And this subnet ID is very useful when we need to work with some other resources. As you can see in this settings blade, we have more options like Bastion, DDoS protection. You can enable this option, then go to firewall, but we don't have any firewall. There is a Microsoft Defender for Cloud option, network manager, DNS server. You can set up peerings from here, create a service endpoint, create a private endpoint, or see the list of your private endpoint. You can go to properties to check the properties of your VNet. You can see the name, location, resource group, subscription ID, resource ID, and resource GUID for this virtual network. Also, in the monitoring option, you have option to see to set alerts, to see metrics, diagnostic settings, logs, virtual network logs, and so on. But let's stick to basic, and in the overview option you can see everything else. An Azure VPN Gateway is a service that can be used to send encrypted traffic between an Azure virtual network and on-premises sites over the public internet. You can use a VPN gateway to send encrypted traffic between Azure virtual networks over a Microsoft network. A VPN gateway uses a specific type of Azure virtual network gateway called a VPN gateway. Multiple connections can be created on the same VPN gateway. When you create a multiple connection, all VPN tunnels share the available bandwidth on the gateway. Because you can create a multiple gateway configuration, by using VPN gateway, you need to determine which configuration best suits your need. Point to site, site-to-site, and coexisting ExpressRoute site-to-site connections that all have different instructions and requirements for configuring resources. VPN gateway can be deployed in Azure Availability Zone. This brings resiliency, scalability, and greater availability to virtual network gateways. Deploying gateways in Azure Availability Zones physically and logically separate the gateway within the region, while protecting your on-premises network connectivity to Azure from zone-level errors. A VPN gateway connection relies on multiple resources that are configured with specific settings. In some cases, resources must be configured in a specific order. The settings you choose for each resource are critical to creating a successful connection. When you create a VPN gateway, you need to specify the SKU of the gateway you want to use. Choose a stock keeping unit or SKU that meets your requirement based on load, types, throughput, features, and service level agreement. For more information about gateway, including supported features, performance tables, configuration steps, and production workload versus dev test, you can see the official pages of that Microsoft offer. You pay two things when you create your VPN gateway: the hourly calculation cost for the virtual network gateway and the data output from the virtual network gateway. Each virtual network gateway has an hourly compute cost. The price is based on the gateway SKU that you specified when you create a gateway for a virtual network. The cost is for gateway itself and is in addition to the data transfer that flows through the gateway. The cost of active-active is the same as active-passive. The cost of data transfer is calculated based on the outbound traffic from the source virtual gateway. If you are sending traffic to a local VPN device, it will be charged at the speed of the outgoing data over the internet. If you are sending traffic between virtual networks in different regions, pricing is based on the region. If you are sending traffic between virtual networks that are located in the same region, there are no data charges. Traffic between VNets in the same region is free. You can send encrypted traffic between the Azure virtual network and on-premises sites over the public internet. You can do this by using the following types of connection: location to location, the connection between IPsec or Internet Key Exchange VPN tunnel between the VPN gateway and the on-premises VPN device, and point-to-point location, VPN via OpenVPN, Internet Key Exchange version 2 or SSTP. This type of connection allows you to connect to your virtual network from a remote location such as a conference or home. You can send encrypted traffic between virtual networks, and you can do this using the following types of connections: VNet to VNet, and IPsec Internet Key Exchange VPN tunnel connection between a VPN gateway and another Azure VPN gateway that uses VNet to VNet connection type. This type of connection is designed specially for VNet to VNet connection, location to location connection, and IPsec Internet Key Exchange VPN tunnel connection between a VPN gateway and another Azure VPN gateway. This connection type, when used in the VNet to VNet architecture, uses the site-to-site IPsec connection type, which allows interlocal connection on the gateway as additional connection between VPN gateways, and you can configure VPN from location to locations as a secure path to overcome the ExpressRoute error. You can do this by using ExpressRoute plus VPN gateway. a combination of ExpressRoute plus VPN Gateway connection, coexisting connection, use location-to-location VPN to connect to locations that are not connected via ExpressRoute. Virtual network peering allows you to seamlessly connect two or more virtual networks in Azure. Virtual networks appear as one for connectivity purposes, and traffic between virtual machines in peering virtual networks uses Microsoft backbone infrastructure. Like traffic between virtual machines on the same network, traffic is routed only through Microsoft private network. Azure supports the following type of peerings. Virtual network peering, connect virtual networks within the same Azure region, and peering global virtual network, connect virtual networks in Azure regions. For peering virtual networks, resources in any network can connect directly to resources in the peering virtual network. Network latency between machines in virtual network in the same region is the same as latency within a single virtual region. Network bandwidth is based on the bandwidth allowed for a virtual machine in proportion to its size. There is no additional bandwidth with a limit within peering. Traffic between VMs in peer-to-peer virtual networks is routed directly through Microsoft backbone infrastructure, rather than through a gateway or the public internet. You can deploy network security groups in any VNET to block access to their virtual networks or subnet. When you configure a virtual network, open or close the security network group policy between the virtual networks. If you open full connectivity between peer-to-peer virtual networks, you can use network security groups to block or deny specific access. Full connectivity is the default option, and chaining services allow you to route traffic from a single VNet to a virtual network appliance or gateway in a peering network via user-defined routes. To enable service chaining, you can configure user-defined routes that point to virtual machines in virtual network that are used as the next IP address. User-defined routes can also point to virtual network gateway to enable service chaining. You can deploy a hub network where the node virtual network contains infrastructure components such as virtual network appliance or a VPN gateway. All voice virtual network can then peer to the virtual network hub. Traffic flows through a network virtual appliance or VPN gateway in the virtual network of the hub. Virtual network peering allows the next hop in a user-defined route to be the IP address of the virtual machine in the virtual network for peering or VPN gateway. You can't route between the virtual networks by using a user-defined route that specifies the Azure ExpressRoute network gateway as the next hop type. So we are in the same subnet from the previous chapter, and there is an option to create a gateway subnet. If I click on gateway subnet, as you can see, there is automatic subnet purpose to create virtual network gateway. First, we need to create this gateway if we want to create our subnet. I will click on add to add this gateway, and you can see that availability depending on dynamic groups. And this is our IPv4 address. And if we go to our marketplace, we can create our network gateway. And as I already told you, we need to create a separate gateway called gateway subnet. If you add some other name, it won't work. Simple as that. Let's go to search and type gateways, and you can see we have virtual network gateway in the marketplace. Let's click on that link, and I will open it in another tab. I will choose my subscription. Resource group will be the same as virtual network. So we need to select our virtual network to get a resource group for this virtual network gateway. I will add a name for this gateway. choose a region. Then in the gateway type, you can choose between VPN or ExpressRoute. If you check ExpressRoute, then you can choose your SKU and again virtual network. As you can see, this is our stock keeping unit. And if you choose our VPN, we can choose a different SKU. The first one, VPN Gateway 1, is the cheapest one, but the connection will be slower than others. If you can see, if I go to VPN Gateway, then I can choose between generation, and then you can choose your generation 2, but for some SKUs they have only generation 1. Then I will choose my existing VNet, and as you can see, our resource group is now exactly the same like our virtual network, sorry. And then subnet will be automatically selected, and this is the gateway subnet that we previously created when we start this demo. If we go to overview, you can see that this is our resource group name, and the same resource group is now added to our resource, to our virtual network gateway. And then we need to add a public IP address. First, you can create a new or use existing one. We need to add a public IP address name. Simply copy this and I will paste it here and add IP or public IP. Then we need to choose our availability zone. I'll choose the first one. If you want, you can enable active mode, configure BGP, broader gateway protocol. You can enable authentication information with your key vault access. And if you go to next, you will go to tags, go to review and create, and if you hit on create, you will create this virtual network gateway. So this is how can you create a virtual network gateway. I won't create this resource because we don't need this resource. Just wanted to show you how it can be set up. And as you can see, you can choose a different SKU. The more down you go from this list, the more powerful SKU you will get, but the price will go up. As you can see, and it's depend of your choice and need, or your company needs. So it is up to us to choose our SKU and generation. If you want to try this resource, simply choose the most cost-effective resource. If I go, for example, to peering in our VNet, in the settings blade, you can add a peering and set a peering with 2 VNets. First, we need to add remote virtual network peering. First, you need to add a name, link name for this peering. Choose your subscription, choose your virtual network, and then you can leave this remote network virtual peering to allow the peered virtual network. You will choose a different virtual network. From here, for example, VNet AZ-900, and then in the local network peering, you will add a name for your local network peering and click on OK. And then both networks will be created and peering state will be connected. Azure Application Gateway is a web traffic load balancer OCI level 7 that allows you to manage traffic to your web applications. Traditional load balancers work on transport layer OSI, layer 4, TCP, and UDP, and route traffic based on source IP address and port to the destination IP address and port. An application gateway can make a routing decision based on additional HTTP request attributes such as path URI or host headers. For example, you can drive traffic based on the incoming URL. So, if images is the incoming URL, you can direct traffic to a specific set of servers known as a set, configured for images. If video is in URL, the traffic is routed to another set of optimized for the video. This type of routing is known as application layer load balancing or OSI layer 7. Azure Application Gateway can do URL-based routing and more. Traditional load balancers work on transport layer OSI layer 4 and route traffic based on the IP source IP address and port destination IP and port. However, you can do more with application gateway like SSL, like for example layer 7 load balancing, distribute incoming application traffic to multiple targets such as VMs, containers, and IP addresses at the application layer. SSL termination handles SSL termination at the gateway level, freeing up SSL protection or processing from backend servers and improving performance. Then you have URL-based routing. It routes traffic to backend servers sets based on the URL path of the request. Multi-site hosting, support hosting multiple websites behind a single application gateway, web application firewall or WAF. WAF provides a centralized protection for your application from common exploit and vulnerabilities. Session affinity, use cookies to maintain session affinity, which is necessary for user session in scenarios where session state is stored locally on a backend server. Connection draining helps elegantly remove backup servers and set members during scheduled service updates, and it has custom health probes and provides customizable health probes for more precise control over traffic to background resources. The architecture of Azure Application Gateway consists of several components that work together to provide a robust and flexible solution for managing web traffic. First is front-end IP configuration. An application gateway can be configured with a public IP address, a private IP address, or both, depending on whether you want to expose the application gateway to the internet or keep it internal to your virtual networks. Then we have listeners. Listeners are responsible for handling incoming traffic to the app's gateway. A basic listener listens for traffic on a single IP address, port, and protocol, while a listener from multiple locations can handle traffic for multiple domain names or host headers. Then we have Backend Pools. Backend Pools consist of backend servers to which application traffic is forwarded. This can include Azure VMs, set of VMs, public IP addresses, internal IP addresses, fully qualified domain name or FQDNs, and Azure App Services. Then we have rules. Routing rules determine how traffic is routed from listeners to backend clusters. These rules can be based on URL paths, host headers, or HTTP attributes. And the last one is health probes. Health probes monitor the health of backend pool and ensure that traffic is only redirected to healthy instances. When deploying Azure Application Gateway, there are a few factors that we need to consider. First is virtual network integration. An application gateway must be deployed within a virtual network subnet that is specifically dedicated to it. Then, when you choose sizing and scaling, you need to choose the right size and configuration for your application gateway, and it is crucial for optimizing performance and cost. Azure offers a variety of sizes and the ability to auto-scale based on traffic load. Then, to ensure high availability, application gateway can be deployed across multiple availability zones in supported regions, and security is a top priority when deploying any internet-facing service. Azure Application Gateway provides a variety of features to improve security, including web application firewall, SSL termination, and end-to-end SSL. Then we have route-based routing. Azure application allows you to route traffic based on specific URL paths. This feature is essentially useful when you have multiple applications that are behind the same gateway. By defining routing rules based on path patterns, you can route requests to appropriate backend set, like request to https myapp.com/API can be routed to the backend set of API, and for example, request to https myapp.com/admin can be routed to the administrative backend set. Then, to ensure fault tolerance and high availability, you need to consider deploying an application gateway across multiple availability zones. This configuration provides fault tolerance in those and ensure uninterrupted service even during maintenance or downtime. Application gateway support auto-scaling based on requirements. You can configure auto-scaling rules dynamically, adjust the number of instances based on traffic patterns. Auto-scaling helps optimize cost by increasing during peak hours and decreasing during off-peak hours. Custom error pages allow you to display user-friendly error messages when backend servers return from HTTP error codes. You can create custom error pages for common errors such as 404 not found or 502, which represent bad gateway. And then you can choose between standard gateway and web application firewall. And application gateway comes in two types. I just mentioned standard and web application firewall. The WAF or WF version includes additional security features such as protection against OWASP top 10 vulnerabilities. Note that WAF incur higher costs due to its enhanced security capabilities. And then you have pay-you-go. So you can choose between pay-as-you-go pricing or reserve instances. Reserve instances offer cost savings if you commit to a specific duration, for example, for 1 or 3 years, and assess the workload and budget requirements to make an informed decision. You can take advantage of the application gateway for SSL termination. By switching SSL processing to the gateway, you can reduce the load on backend service and improve overall performance. Then you need to adopt a consistent convention on naming listeners, background sets and rules, and this simplifies management and troubleshooting, especially in complex settings. You can set up monitoring and alerts for your application gateway. Azure Monitor provides insight into performance, health, and potential issues. You can use metrics and logs to proactively address any anomalies. Microsoft Azure Application Gateway is a powerful tool for managing web traffic, improving security, and ensuring high availability. By understanding its features, architecture, and deployment configuration, you can effectively leverage it to optimize cloud-based application. And once again, we are in our Azure portal, and as you can see, I will go to my create a resource from marketplace, and then I will choose my application gateway, and we need to choose this first one, Microsoft as a publisher, and let's click on create to create this resource. As you already used to by now, and you already know that we first need to add some details like subscription and resource group. Then we need to add our instance gateway name, choose our region, and choose our tier. I will do that. And let's move on. We need to choose standard v2 or a WAF version 2. Then I will choose enable autoscaling. Minimum instance is 0, maximum is 10. Then we are choosing our availability zone. If you want, you can choose only IPv4 address or dual stack of both of them. And as already mentioned, we need to create our virtual machine right from here or choose this existing one. This is our subnet A. Let's click on next. We are now go to the next tab called frontends. I will choose my frontend IP address. You can choose public or private or choose both. Let's choose our public. Then if we click on add new, I will add a new public private address. We need to add a name. And I will simply click on OK. And that's it. Let's go to next to backends. Then we need to create our backend pool. I will add a name for this backend pool. And then you have option to create backend pool without targets or with targets. In the target type, you can choose your IP address or fully qualified domain name of your, for example, virtual machines, or simply virtual machine scale set or app service. And for the target, you will add this IP address of your VM or your VMSS or app service. Then I will click on OK to create this backend pool. You can add more than one target type. Let's create without target type, so we don't have any targets. You can also delete this pool if you want. Let's go to configurations. And now as you can see, we are already have our public set up our public IP address and our backend pool, but we need to add something called routing rule. In the theoretical part, I already explained what is routing rule. First we need to do is to add our name for this rule and priority. And when you configure a routing rule, it will send a traffic from a given front-end IP address to one or more our backend targets that we already create. Then you must choose from 1 to 20,000, and 1 represents the higher number. I will add 100. Then we need to add a listener name, choose our front IP protocol, HTTP port 80 or HTTPS port 443. And then for the listener type, you have option to choose from basic to multi-site. This is our listener name. This is our front IP, public IPv4, and I will choose this. Make it simple, HTTP port 80, basic listener type. And we need to go to our backend targets. I will not use this custom error pages. Target type is our backend pool. This is our backends, as you can see. You can use your redirection if you want. And then from the backend target, I will choose my backend that we created. And from our backend settings, we need to create a new one. First, you will add a name. Backend protocol is HTTP and port is 80. And to make this simple, I will not enable cookie-based affinity and connection draining option. Simply request timeout is 20 seconds. And you can click on Add to add this backend rule. And finally, you can add, if you don't want to use multiple targets, to create a path-based rule. If you want to create a path-based rule, then you need to add your path, target name, backend settings, and backend target. And then I will click on Add to add this routing rule. And then I will go to Tags, Review and Create, and you are set to create this resource. So this is how can you create your application gateway. Azure Content Delivery Network is designed to send audio, video, applications, photos and other files to your customers faster and more reliably using the server closest to each other. Acceleration data transfers provide dynamic acceleration of a site of a dynamic content that is not cached by your web application. Azure Content Delivery Network offers a global solution for fast content delivery, save bandwidth and improve responsiveness when coding or distributing game software, firmware updates and IoT endpoints. It reduces load time for website, mobile apps and streaming media to increase customer satisfaction globally. A content delivery network is a distributed network of servers that can efficiently deliver web content to users. A content delivery network stores cached content on edge servers at point of presence or POP locations that are close to end users to minimize latency. The Azure Content Delivery Network offers a developer a global solution to quickly deliver high bandwidth content to customer by caching their content on strategically placed physical nodes around the world. Azure Content Delivery Network can also accelerate dynamic, non-cacheable content by using various network optimization using Content Delivery Network POP, for example, route optimization to bypass the Broadband Gateway Protocol or BGP. To use the Azure Network Content Delivery Network, you must have at least one Azure subscription. You also need to create a Content Delivery Network profile, which is a collection of Content Delivery Network endpoints. Each endpoint of a Content Delivery Network is a specific configuration that users can customize with the required content delivery, behavior and access to organize the endpoints of a network for delivering content by internet domain, web application or other criteria. You can use multiple profiles. Because Azure Content Delivery Network pricing applies at the Content Delivery Network profile level, so if you want to use a combination of price tiers, you need to create a multiple Content Delivery Network profiles. Each subscription has default limits of the following resources: the number of Content Delivery Network profile created, the number of endpoints created in the Content Delivery Network profile, and the number of custom domains mapped to the endpoint. The basic agenda of the Azure CDN is to distribute user requests and serve content directly to end users from edge servers. In this way, there is less traffic sent to the source server, which reduces latency and optimizes loading time for the end users. Azure CDN starts when a user requests a file or resource with the help of a URL. They use a specific domain name to set up their request, which can also be a custom domain or an endpoint host name. DNS is then responsible for routing request to the nearest POP or point of presence location and automatically selects a POP that is close to the user's geographic location. If files are available in the edge server cache, it extracts them immediately and processes the request. But in case the edge servers within the POP don't have those files in their cache, POP will then make a request from the source server for that file. The source server to which POP requests the file can be Azure Cloud Service, Azure Web App or Azure Storage account. The source can also be a web server that has public availability. The source server then processes the POP request for the file and transmits it to the edge server within the POP. Now, the role of the Edge server is to cache the file and then return it to the user who requested. It caches the file within the point of presence to make it available to the other users who request it in the next time. But there is a limitation that this file remains in the cache. It will be available within up to time to live, or TTL, which is the expiration time for it as specified in the HTTP headers. In the event that the source server does not specify any TTL for file processing POP, then default TTL or time to live is specified as 7 days. As long as TTL does not expire, POP or POP can process the request for the file directly from the cache without having to call the source server again. Other users who want to access the same file or material prefer to use the same URL to redirect the same POP where the file is cached for even faster access. Azure has specific billing structure for its content delivery network services. The entire Azure CDN billing depends on the region. The billing region is specified as the geographic area used to determine the rate charged for the delivery of object within the Azure CDN. Currently, Azure has specified some of its billing zone and their respective region for ease of billing. Azure CDN billing regions are based on the location of the source server that delivers context as requested by end users. The physical location of the user requested the file is not considered a billing region. Point-of-presence sites within the regions are used to process user requests for file or resources, such as use of regions as replicated in Azure CDN billing. All HTTP and HTTPS requests that terminate on the content delivery network are transactions that will be charged within a Microsoft Azure CDN. There are both successful and unsuccessful answers. Different responses can generate different traffic numbers, which will affect the overall billing of Azure CDN services. Using Azure CDN also comes with some additional fees for using the services used as object sources. These are small costs that add up the total cost of using the CDN or the final bill. For example, if you are using Azure Blob Storage as your source content server, then you'll have to pay storage cost to fill the cache, depending on the gigabytes of storage used, the transaction required to fill the cache, and the data transfer as part of the process. ExpressRoute is a service that allows you to create private connections between Azure data centers and infrastructure located on your premises or in a co-location environment. ExpressRoute connections do not go over the public internet and go over greater reliability, higher speed, lower latency, and greater security than typical connections over the internet. The ExpressRoute service requires the application of ExpressRoute circuit. ExpressRoute circuits are deployed at peering sites or dating sites and are mapped to different zones. Azure Route Gateway. The ExpressRoute Gateway is deployed in an Azure region. ExpressRoute is an Azure service that allows you to create a private connection between Microsoft data centers and the infrastructure that resides on your premises or in a co-location facility. ExpressRoute's connection do not go over public internet. They offer great security, reliability, and speed with a lower and consistent latency than typical internet connections. In some cases, using ExpressRoute connections to transfer data between on-premises devices and Azure can bring significant cost benefits. You can select a regional carrier and establish Ethernet connection to one of the supported Exchange provider location and then connect to Microsoft at the provider's location. Be sure to check the connection to another service provider to see if your service provider is present at any of the Exchange sites. You can order an ExpressRoute circuit through a service provider to connect to Azure. If you are connecting to a service using Microsoft peering with unlimited data, ExpressRoute won't charge only for outbound data. Output data will continue to be charged for services such as computing, storage, or any other service accessed through Microsoft peering, even if the destination is a Microsoft public IP addresses. The ExpressRoute circuit, once set up, allows you to access services within the virtual network and other Azure services simultaneously. You connect to virtual network through a private peering path and to other services through a Microsoft peering path. The ExpressRoute gateway advertises the address space of the Azure virtual network, and you cannot turn on or off at the subnet level. A virtual network address space is always advertised. If virtual network peering is used, and peer-to-peer virtual network has the use remote gateway option enabled. The virtual network address space for peering are also advertised. There are a maximum of 1000 IPv4 prefixes advertised on the single ExpressRoute connection or through virtual network peering using a gateway transit. For example, if you have 999 address spaces on a single virtual network connected to an ExpressRoute circuit, all 999 prefixes will be advertised in the local location. Alternatively, if you have a virtual network that is enabled to allow the transit of a gateway with one address space and a virtual network of 500 spoke that is enabled using allow remote gateway option, the virtual network deployed with the gateway advertised as 501 prefix on the local location. If you are using a dual stack circuit, there are a maximum of 100 IPv6 prefixes on a single ExpressRoute connection or through virtual network peering using gateway transit, and this restriction is in addition to the restriction described above. Private peering virtual network, including all virtual machine and cloud services such as virtual network desktop RDP short path. If your ExpressRoute circuit is enabled for Azure Microsoft peering, you can access the public IP address bands used in Azure over the circuit. Azure Microsoft peering provides access to services that are currently hosted in Azure. In short, use ExpressRoute to create private connections between Azure data center and infrastructure on premises or in co-location environment. ExpressRoute connections do not route over the public internet and offer higher reliability, higher speed, and lower latency than typical internet connections. The domain name system, or DNS, is responsible for translating a service name into an IP address. Azure DNS provides DNS hosting, resolution, and load balancing for your application using Microsoft infrastructure. Azure DNS supports Azure DNS domains and private DNS zones and provide the following services. Azure Public DNS is a hosting service for domain DNS. If you host your domain in Azure, you can manage your DNS records using the same credential, APIs, tools, and billing as other Azure services. Azure Private DNS is the DNS service for your virtual networks, and Azure Private DNS manages and resolves domain names in a virtual network without the need to configure a custom DNS solution. Azure DNS Private Resolver is a service that allows you to search for Azure DNS private zones from your on-premises environment and vice versa without setting up VM-based DNS servers. Azure Traffic Manager is a DNS-based traffic load balancer. This service allows you to distribute traffic to your public application across global Azure regions. Azure DNS is one of the useful and good cloud services that Microsoft offers to its users. With Azure DNS, users, especially web administrators or Azure administrators, can use it to host website, manage DNS zones, and keep track of the website DNS domains, applications, API, and cloud services that are already hosted in the cloud, such as Microsoft Azure, can use Azure DNS for hosting, all in one place and a group of resources, and this favors better service management. A domain name system, or DNS, is a hierarchical and distributed name service that provides a naming system for computers, services, and other resources on the Internet or other Internet protocols, IP networks. It associates various pieces of information with the domain names, identification strings assigned to each of the related entities. Most notably, it translates easy-to-remember domain names into numeric IP addresses needed to locate and identify computer services and devices with basic network protocols. The domain name system has been an essential component of the functionality of the Internet since 1985. A domain name system delegates responsibility for assigning domain names and mapping those names to Internet resources by designating authoritative names servers for each domain. Network administrators can delegate authority over subdomains of their allocated namespace to other named servers. This mechanism provides a fault-tolerant distributed service and is designed to avoid a single large central database. In addition, DNS specifies the technical functionality of the database service that underlies it. It defines the DNS protocol, a detailed specification on the data structure and data exchange used in DNS, as a part of the Internet Protocol suite. The Internet maintains two namespaces: the domain name hierarchy and the IP address space. A domain name system maintains a hierarchy of domain names and provides translation service between any address spaces, Internet name servers, and communication protocols implement a domain name system. A DNS server is a server that stores DNS records for a domain. The DNS name server responds to query responses to its database. The most common types of records stored in a DNS database are authority originators or SOA, IP addresses like A and 4As, SMTP mail exchange or MX, name servers or NS, reverse DNS lookup, pointers, PTR, and domain name aliases, CNAMEs. Although it is not intended to be a general-purpose database, DNS has been expanded over time to store records for other types of data for automatic lookups such as DNSSEC records or human queries such as responsible person or RP records. As a general-purpose database, DNS has also been used to combat spam by storing a real-time list of black holes or RBL. A DNS database is traditionally stored in a structured text file, a zone file, but other database systems are common. The domain name system originally used the User Data Protocol or UDP as transport over IP. Concerns about reliability, security, and privacy have led to the use of the Transmission Control Protocol, TCP, as well as a number of the other protocol developments. A common use analogy to explain DNS is that it serves as a phone book for the Internet by translating the names of human-friendly computers into IP addresses. For example, a host name www.example.com within a domain name example.com translate to 93.104.216.34. This is our IPv6 address, and the long one is IPv6. DNS can be updated quickly and transparently, allowing the location of the service on the network to change without affecting end users, who continue to use the same host name. Users use this when they use meaningful uniform resource locators or URLs and email addresses without having to know how the computer actually locates the services. An important and ubiquitous function of DNS is its central role in distributed internet services such as cloud services and content delivery networks. When a user accesses a distributed internet service using a URL, the domain name of the URL is translated into a server IP address that is proximal to the user. A key DNS functionality used here is that different users can receive different translations for the same domain name at the same time, which is a key point of departure from the traditional view of DNS from the phone book. This process of using DNS to assign proxy servers to users is crucial for providing faster and more reliable responses on the Internet and is widely used by most major Internet services. A name server or name server is a computer application that implements a network service to provide answers to queries against a directory service. It translates an often human meaningful text-based identifier into a system internal, often numeric identification or addressing component. This service is performed by the server in response to a request from the service protocol. An example of a name server is the server component of the domain name system or DNS, one of the two main namespaces of the Internet. The most important functions of a DNS server is to translate human memorable domain names and host names into corresponding numeric Internet protocol addresses. The second main namespace on the Internet that is used to identify and locate computer systems and resources on the internet. The internet maintains two main namespaces, as we already know, but let's repeat it again. The domain name hierarchy and IP address system. The domain name system maintains the domain namespace and provides translation service between these two namespaces. Internet name servers implement a domain name system. The topmost hierarchy of a domain name system is served by underlying name servers delegated by the Internet Corporation for assigned names and numbers, or ICANN. DNS servers located all over the world translate domain names into IP addresses, giving them control over which server a user can access through that domain. Below the root, Internet resources are organized into a hierarchy of domains which are managed by the respective registrars and domain name owners. A DNS name server is a server that stores DNS records, such as address records, name service records, and mail exchanger records for a domain name, and responds to query responses to its database. If you own or administer a domain or website, it's pretty normal that you're familiar with setting up DNS zone and record settings in a website domains. On every website we visit, there is a public IP address behind it, also called DNS or domain name server. In the world of internet that we know, that we all rely today, DNS technology plays an important role. Azure DNS provides a globally distributed high availability name server infrastructure that you can use to host your domain. By hosting your domains in Azure DNS, you can manage your DNS records with the same credentials, APIs, tools, billing, and support as other Azure services. Azure DNS support not currently support the purchase of domain names. If you want to buy a domain name, you need to use a third-party domain name registrar. The registrar usually charges a small amount annual fee. The domains can then be hosted in Azure DNS to manage DNS records, and DNS zone is used to host DNS records for a specific domain of a website. For example, if I have a website called vladimir.com and it contains some of DNS records for my mail server and for my website. So if I could host my existing domain in Azure, I have to use the Azure DNS service. The service would allow me to host my own DNS zone and manage my DNS records and provide name servers. Name services are used for DNS queries. To create a DNS zone in Azure, you need to be an Azure administrator or an Azure user with a valid subscription. You can create a new resource and search for a DNS zone. Select the right subscription, then resource group and instance details. An A record is the primary record is created first. So, what is an A record? An A record is a record that contains a pairing between an IP address and a domain name. It can have more than one entry, commonly referred to as record sets. In record sets, the domain name remains constant while the IP addresses are different. In a practical real-world situation, you should update the name server's record on the domain name registrar to delegate the domain to Azure after you created a DNS record. So, even without an official registered domain name, it is possible if you have done the Azure DNS configuration correctly. One way to verify this is to use NSLookup tool directly using a cloud-based command line tool such as the Azure CLI in the Azure portal. Using the NSLookup command with the name of your DNS zone and one of your Azure name servers, you'll be able to verify that your configuration for the Azure DNS zone was correct. You should get back the IP address you set when you started. If you're new to Azure or just starting to learn about all aspects of networking, then this lesson is a very important start for you to complete understanding of this part of Azure. Once you learn everything mentioned in the text, it will be extremely easy for you to navigate all the terms and functions, as well as very easy work with all services such as Azure public or private DNS, etc. If you go to our Azure portal and go to our marketplace, we will be able to search and find our Azure DNS zone service and then we will choose this Microsoft public DNS zone. There is a private DNS zone. We will create this DNS zone. It is very easy to create a DNS zone. You need to select your subscription, choose your resource group, then you can check this if this zone is a child of an existing zone already hosted in Azure DNS. This is not our case, and then we need to add a name for our for example Vladimir Z.net, and resource group location is the same for our DNS. Also, there is a DNS editor, so you can upload your DNS zone. I will not do this. Let's go to tag and review and create. Finally, I will click on create. So we are creating a DNS zone and our resource is complete. Let's go to our resource. You can see that we have option to create child zone, record sets, import or export, or move this. If you go to overview, there is our resource group, location is global, subscription, our subscription ID, we have 2 record sets already, we don't have any tags, number of record set is 10,000, and this is our name server 1, 2, 3 and 4. These name servers you need to copy on your domain registrar to connect this zone with your address, with your host site. And then, as you can see, you have this get started blade. You can learn more about DNS record sets, how to import record sets from a file, learn more about access control, and check Azure DNS documentation. As already mentioned, direct from here you can select to go to child zone, create child zone, and add record set. If you go to settings and properties, you can see all other information, and you can even see your value as a JSON for your name servers. If you go to DNS management and click on record set, you will see that we have our name servers, time to live, and this is the value of our record set. These values we must copy in domain register, as I already told you. Then we have state of authority. Time to live is 3060. This is our email. Host master is microsoft.com. Host is our NS1, name server 1, and this is our time to live. Then there is a definition of record set. There is a collection. Record set is a collection of records in a zone that have the same name and are the same type. Record set will be automatically fetched in batches of 100 as you scroll through the existing record set. If you want to add a record set, just click on add a name for this record set, and this record set will be my name, my address. For example, VM1, I will add a type. As we already mentioned in our theoretical part, you have different type of address record. This is our A address record for IPv4. Time to live is 1, time to live unit is in hours, and then I need to add the IP address of my VM. I will now open a new tab. Go to my virtual machines, and then I will create a new virtual machine. You already know how to create a virtual machine. I will choose existing resource group, choose my VM name, for example VM DNS, choose my region. I will choose no infrastructure redundancy required. For the image, I will leave this Windows 2022 and the size is good, standard DS1 version 2. Then we need to add our username and password. For administrator account, I will confirm my password. And then we need to add our ports. RDP 3389 and HTTP 80. Let's go to disk. Let's go to networking, management, monitoring, advanced tags, review and create, and finally let's click on create. So we are creating a new VM, simply Windows Server 2022. And finally our VM is created and I am inside my VM, and I will download my RDP file from this connect option. Let's double click on this file, click on connect. I will add my password and username, of course. Click on OK, click yes, and we are signing in to our virtual machine. So we are waiting for our machine to boot up, and Server Manager will be automatically starting. You just need to be patient. I will click on yes, and as you can see, our Server Manager is finally loading. If you want to use your Server Manager, you need to wait for this blue thing to finishes loading, and then we can use our roller features if you want. Sometimes Azure is really slow with loading, and finally we are able to add roles and features. I will click on add roles and features, click on next, choose my role based or feature selection. This is my VM, and then in the roles I will choose my web server, IIS. I already showed you how can you install Internet Information Services, but let's go to next, next, and finally install. Our installation is starting, and we will wait for this Internet Information Services installed on our VM DNS 10,000, which is our destination server. you can track the progress, installation progress. And finally, we will be able to finish this installation of this role. And I will not stop this video just to show you the whole process of how can we install everything, so that you can practice on your own environment. And finally, we installed our VM, we install our Internet Information Services on our VM, and then simply copy public IP address and paste into this address bar, and you can see that we are successfully installed. If I go to our DNS zone and go to add record set, I can add, for example, some of my name, add my A address record, and then I will copy this public IP address of my VM and click on add. And you can see we are just created our record set. This is the name, this is the type, time to live, and value is public IP address of our VM. If you click on this little pen, you can edit this feature, and you can also delete this if you click on trash can. Let's go to my command prompt. I will run this as an administrator, and then we need to run nslookup command, and then I will add the name of my DNS zone, and after that we will copy our first name server and paste it here and type enter. As you can see, we can find our address, but let me try this again, and as you can see, server is unknown, address is here, and name, this is our DNS zone, and this is the address of our public IP address of our virtual machine. So this is how can you work with your virtual machine and DNS zone and use this record set for this. And this is our record set. If you go to our public IP address, in the DNS label, if optional, you have option to add your DNS name. For example, my computer .northeurope.cloudapp.azure.com. This is our location. .cloudapp.azure.com is the name of this DNS that Azure provide this name, and if I copy this address here, it will copy exactly the same. We will get exactly the same result as we did with our public IP address, thanks to our DNS. Let me just copy this whole address, this DNS label. This is optional, but you can use this. As you can see, you can create an alias record in Azure DNS, and we created this alias DNS zone with our DNS zone and our VM. So this is how can you replace your public IP address with this alias, and this is how can you create your alias. Of course, you can create more alias with type A. Then you will need to add your name. Let's add, for example, Vlada1. Click on create, and this will create a new record set right from here, and it will be placed here, as you can see. And if I refresh this, there it is. We have another record set added. A service endpoint or virtual network service, VNET endpoint, provides secure and direct connection to Azure service over an optimized route over the Azure backbone. Endpoints allow to secure critical Azure services resources only in virtual networks. Service endpoints allow private IP addresses in VNet to reach the Azure service endpoint without the need for a public IP address on VNet. This service is available in Azure Storage and Azure Storage cross-region, Azure SQL Database, Azure Synapse Analytics, Azure Database for PostgreSQL and MySQL Server, Azure Database for MariaDB, Azure Cosmos DB, Azure Key Vault, Azure Service Bus, Azure Event Hubs, Azure App Service, Azure Cognitive Services, while in preview for Azure Container Registry. It's important to note that enabling a resource is from the subnet side as we configure the service endpoint for our service. Improve security of your Azure service resources. VNet private address space can overlap. You can't use overlapping spaces to uniquely identify traffic originated from your VNet. Service endpoints allow you to secure Azure service resources on your VNet by extending VNet identity to the service. After you enable service endpoints in a virtual network, you can add a virtual network rule to provision Azure service resources in the VNet. The policy add-on provides improved security by completely removing public access to internet resources and allowing traffic only from your virtual network. Optimal routing for Azure service traffic from your VNet. Today, all routes in your VNet that force internet traffic to your on-premise and or virtual appliance also force Azure service traffic to go the same route as internet traffic. Service endpoints provide optimal routing for Azure traffic. Endpoints always transfer traffic directly from your virtual network to a service on the Microsoft Azure backbone network. Maintaining traffic on the Azure backbone network allows you to continue auditing and monitoring outbound internet traffic from your virtual network through forced tunneling without impacting service traffic. It's easy to set up with vast management cost. You no longer need reserved public IP addresses in your virtual network to secure Azure resources over an IP firewall. No network address translation or NAT devices or gateway are required to set up service endpoint. You can configure service endpoint through a single choice on the subnet. There are no additional costs for maintaining the endpoints. In addition to the benefits, there are also a number of limiting factors. This feature is only available to virtual networks that are deployed through Azure Resource Manager or ARM deploy model. Endpoints are enabled on subnet configured in Azure virtual networks. Endpoint can't be used for traffic from your on-premises services to Azure services. For Azure SQL, the service endpoint is only applied to Azure service traffic within the virtual network region. For Azure Data Lake Storage or ADLS Generation 1, the VNet integration capability is only available for virtual networks within the same region. Also note that virtual network integration for ADLS Gen 1 leverages virtual network endpoint security between your virtual network and Microsoft Entra ID to generate additional security requests in the access token. These claims are used to authenticate your virtual network to your Data Lake Storage Gen 1 account and allow access. A virtual network can be connected to up to 200 different subscription and regions by each supported service with active VNET policies configured. The virtual network endpoints provide the Azure service with the identity of your virtual network. After you enable service endpoints in your virtual network, you can add the virtual network rule to provision Azure resource or service resources in the virtual network. By default, Azure service resources provided by virtual networks are not accessible from on-premises network. If you want to allow traffic from a local location, you must also allow public, usually NAT, IP address from your local or ExpressRoute. You can add these IP addresses through IP firewall configuration for Azure service resources. You can configure endpoints on a subnet in a virtual network. Endpoints work with any type of computer instances that operate within your subnet. You can configure multiple services endpoints for all supported Azure resources. For all Azure SQL databases, the virtual network must be in the same region as the Azure resource. For all other services, you can provision Azure services resource on virtual network in any region. The virtual network on which the endpoint is configured can be in the same or different subscription than the Azure service resource. So for supported services, you can provision new or existing resource on virtual network by using service endpoints. There is no additional charge for using the endpoints of the service, and the current pricing model for Azure services is applied today as it is. There is no limit to the total number of service endpoints in a virtual network. Certain Azure services, such as Azure Storage accounts, may apply limits on the number of subnet that are used to provision resources. VNET service endpoint policies allow you to filter virtual network traffic to Azure services. This filter only allows certain Azure service resource through service endpoints. Service endpoint policies provide granular access for control your virtual network traffic to Azure service. If I go to Azure portal and go to my marketplace, I will search for virtual network, and then I will create a new virtual network. We need to choose our Microsoft Virtual Network as a publisher and create. Simply create a new resource group, choose your subscription, choose your name for your virtual network and a region. And click on OK. Then add the name for your VNet. I will choose my region. I will go to next, go to IP addresses, leave everything as it is, and finally go to review and create and click on create to create a new VNet. Our deployment is complete and succeeded, so we will now go to our resource, but first let's go again to our marketplace and search for storage account. So we are creating one storage account and one virtual network. As you already know, I will choose my existing resource group, choose my subscription, add the name, unique name for this storage account, choose my region, select my primary service as Azure Blob Storage and Azure Data Lake Storage Gen 2, choose standard performance and choose my redundancy as LRS. or locally redundant storage, go to next, 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 next again, next, tags, review and create. If validation is successful, I will click on create, and we're creating our storage account. After some time, our resource is complete. I will go to our storage account, and then let's go to our resource group, to our virtual networks. In the settings blade, I have this option called service endpoints. I will click on add to add a new service endpoint, choose my service as Microsoft Storage, and then I will choose my subnets. I don't have any service endpoint policies, so I won't add this policy, but you can, in the later part of your journey, cloud journey, you will learn how to create these service endpoint policies, and we are now creating service endpoint for this virtual network for our storage. Then I will open a new tab, go to our storage account, let's go to networking, in security plus networking blade, and then as you can see there is a enable public network access for all networks. I want to use this enable from selected virtual networks and IP addresses, and I will click on add existing virtual network, choose my subscription, choose my virtual network, and then I will choose my subnet and click on add to add this service endpoint to this storage account. So this is how can you create service endpoint and add to this storage account, and simply click on save. As you can see, this is our subnet, address range, status endpoint status is enabled, our resource group and our subscription, and that's it. It's very useful and very easy to set up, so I hope this was helpful and you can try it in your own environment. Also, if you click on three dots, you can remove this. A private endpoint or private endpoint is a network interface that uses a private IP address from your virtual network. This network interface connects you privately and securely to a service powered by Azure Private Link. By enabling a private endpoint, you are bringing a service to your virtual network. A service can be Azure service, such as Azure Storage, Azure Cosmos DB, Azure SQL Database, or your own service using Private Link service. Azure Private Endpoint are a powerful tool that allows you to securely access your Azure services through a private endpoint. With private endpoints, you can connect to Azure services without exposing your data to the public internet, improving the security and compliance of your applications. Azure Private Endpoints are typically used in scenarios where users want to access Azure services from a private network, such as on-premises network or a virtual network in Azure. In this scenario, customers can use private endpoints to connect to Azure services over a private connection without having to expose their data to the public internet. There are several use cases for private endpoints, including secure data access. By using private endpoints, you can ensure that all data access to your Azure services is secure and isolated from the public internet. And this can be especially important for highly sensitive data, such as financial or health data. Then, connect to Azure services from on-premises network. Private endpoints can be used to securely connect to Azure services from on-premises network, allowing users to take advantage of Azure services while keeping their data private. You can connect to Azure resources from Azure virtual networks. Private endpoints can also be used to securely connect to Azure services within Azure virtual networks, providing an extra layer of security for your application. When a private endpoint is activated, the communication method and IP addresses used to access the Azure service change. In case of Azure Storage, for example, when a private endpoint is active, the communication between the client and the storage account takes place over a private IP address instead of a public IP address. This IP address is associated with the private endpoint and is only accessible from the same virtual network as the private endpoint. In addition, the method of communication is changing from a public internet to a private, dedicated connection. This means that all data transmitted between the client and the Azure service is encrypted and travels to the private network, which improves the security and isolation of communication. Private endpoints incur additional costs compared to accessing Azure services over a virtual network. There is a cost that is associated with the private endpoint itself, as well as the cost of data transfer. The cost of data transfer can vary depending on the region in which the private endpoint is located and the amount of data transferred. However, using private endpoints can also help reduce costs by reducing the amount of data that needs to be transmitted over the public internet. This can lead to lower exit fees and improved network performance. In summary, while there are additional costs associated with Azure private endpoints compared to accessing Azure service over a virtual network, the increased security and performance benefits can outweigh those costs in many scenarios. It's important to carefully evaluate your specific use case and weigh the costs and benefits of using private endpoints versus methods of communication. Azure private endpoints are an important tool for providing access data to Azure services. Which private endpoint you can connect to Azure services through a private endpoint without exposing your data to the public internet. This can improve the security and compliance of your application and provide an extra layer of security or protection for your sensitive data. Azure Storage Platform is Microsoft Cloud storage solution for modern data storage scenarios. Azure Storage offers highly available, massively scalable, resilient and secure storage for a variety of data objects in the cloud. Azure Storage data objects are accessible from anywhere in the world via HTTP or HTTPS via the REST API. Azure Storage also offered client libraries for developers who build applications or services with .NET, Java, Python, JavaScript, C++, and Go. Developers and IT professionals can use Azure PowerShell and Azure CLI to write data management scripts or configuration tasks. The Azure Portal and Azure Storage Explorer provide user interface tools for interacting with Azure Storage. Azure Storage Services offer the following benefits for application developers and IT professionals. It's durable and very accessible. Redundancy ensures that your data is safe in the event of transient hardware failures. You can also choose to replicate data across data centers or geographic regions for additional protection against a local disaster or natural disaster. The data that is replicated in this way remains very accessible in the event of an unexpected downtime. It is secure. All data written to an Azure Storage account is encrypted by the service. Azure Storage gives you granular control over who has access to your data. Scalability. Azure Storage is designed to be massively scalable to meet the data storage needs and performance of today's applications. Managed. Azure takes care of hardware maintenance, update and critical issues for you, and it's very affordable. Data in Azure Storage is accessible from anywhere in the world via HTTP or HTTPS. Microsoft provides client libraries for Azure Storage in a variety of languages. As I already told you, include .NET, Java, Node.js, Python, Go, and others, as well as a major REST API. Azure Storage supports scripting in Azure PowerShell and Azure CLI. Also, it's easy to use if you use Azure Storage Explorer or Azure Portal. The Azure Storage platform includes the following data services. Azure Blob. It's massively scalable object storage for text and binary data. It also includes support for big data analytics through data lake storage. Azure Files. Manage file shares for cloud or on-premises deployments. Elastic SAN. A fully integrated solution that simplifies that deployment scaling, management and configuration of SAN in Azure. Azure Queues, a messaging store for reliable messaging between application components. NoSQL Azure Tables, of course. NoSQL storage for schema-free storage of structured data. Azure Managed Disk, block-level storage volumes for Azure VMs. And Azure Container Storage, a volume management, deployment and orchestration service that was originally built for containers. Each service is accessed through a storage account with a unique address. In addition, Azure provides the following specialized storage. Azure NetApp Files. Enterprise file storage powered by NetApp makes it easy for business individuals and storage professionals to migrate and run complex file-based applications without changing the code. Azure NetApp files are managed through a NetApp account and can be accessed via NFS or SMB in dual protocol volumes. Azure Storage offers several types of storage accounts. Each type supports different features and has its own pricing model. Standard General Purpose version 2, Blob Storage 2 include Data Lake Storage 1, Tables, Storage and Azure Files. A standard type of Azure account for blobs, file shares, queues and tables, recommended for most scenarios that use Azure Storage. If you want support for network file system or NFS in Azure Files, you need to use premium file share account type. Then there is a premium block blobs, a type of premium storage account for block blobs and adding blobs. It is recommended for scenario with high transaction rate or block blobs and append blobs, or use that smaller facilities or require consistently low storage latency. Then we have Azure Premium File Sharing, a file sharing premium storage account type recommended for high performance business or application. You can use this type of account if you want a storage account that supports both service message block or SMB and NFS file sharing. When naming your storage account, you need to keep this rule in mind. Storage account names must be between 3 and 24 characters long and can only contain numbers and lowercase letters. The name of your storage account must be unique within Azure. No two storage orders or account can have the same name. A storage account provides a unique namespace in Azure for your data. Each object that you store in Azure Storage has a URL that includes a unique account name. The combination of the account name and the service endpoints makes the endpoints for your storage account. There are two types of service endpoints that are available for storage account. Standard endpoints. By default, you can create up to 250 storage accounts per region with standard endpoints in a given subscription. With increasing quotas, you can create up to 500 storage accounts with the standard endpoints per region. Azure DNS zone endpoints, you can create up to 5,000 storage accounts per region with Azure DNS zone endpoints in a given subscription. With a single subscription, you can create accounts with standard Azure DNS zone endpoints for up to 5,250 accounts per region per subscription. With increasing quota, you can create up to 5,500 storage accounts per region per subscription. Also, you can configure your storage account to use a custom domain for the Blob Storage endpoint. When your account is created with standard endpoints, you can easily construct a URL for an object in Azure Storage by adding the location of the object in the storage account to the endpoint. For example, a URL for the blob will be https your storage account name .blob.core.windows.net / the name of your container and / the name of your blob. All data in your storage account is automatically encrypted on the service side. All storage accounts based on the usage in your storage, all objects in storage order are built together as a group. Storage costs are calculated based on the following factors. Region, it refers for the geographic region in which your account is located. The account type refers to the type of storage account you are using. The access level refers to the data usage pattern that you specified for your general purpose V2 or blob storage account. Capacity refers to how much of your data storage account you use for data storage. Redundancy determines how many copies of your data are maintained at the same time in which locations. And transaction refers to all read and write operation in Azure Storage. The output data refers to all data transferred from the Azure region when an app that isn't running in the same region accessed data in your storage account. You are charged for data output. For more information about how to use a resource group to group your data and services in the same region to limit outbound fees, you must go to official Microsoft pages. I'm in my Azure account, in my Azure portal, and I will now show you how can you create a storage account. If I go to my marketplace, I will search Azure Storage account and choose Microsoft Publisher for my storage account. As you can see, this is Microsoft, and then I will hit on create. There is a large number of storage accounts that can you use in this you can choose from this marketplace, but we need this Microsoft Publisher. Let's click on create storage account, and then we need to specify our resource group. I will create a new resource group name. Then add my account storage name and add some install details, like to choose my region, choose my primary service, you can choose between Azure Blob and Data Lake Storage, Azure Files, and other, which includes tables and queues. I will choose my Azure Blob Storage or Azure Data Lake Storage Gen 2. Then from the performance, also you have this primary workload, but it isn't, this is optional. If you want to add something from here, you can choose from this list, and as I already told you, it is an option. If you want, you can add some big data analytics, backup and archive, cloud native, high performance computing or HPC, machine learning and artificial intelligence, or some other. But for this demo, I will leave this as a blank, and in the performance I will choose, you have option to choose from standard and premium. Standard is recommended for most scenarios. This is general purpose V2 account, and in premium it is recommended for scenarios that require low latency. If you choose standard, it will be a general purpose V2 account, as I already told you. And if you choose premium, you can choose your premium account type, which includes, as you can see, page blobs, file shares, and block blobs. Block blocks is best for high transaction rate or low storage latency. File shares is best for enterprise high performance application that needs to scale, and page blobs are best for random read and write operations. I will choose my standard, and then in the redundancy you have option to choose from a locally redundant storage, geo-redundant storage, zone redundant storage, or geo-zone redundant storage. In the next chapters we will get to know redundancy in much more granular, but for now I will choose my locally redundant storage, and then I will go to next. But for now, let's make it simple and keep it simple just to understand how we can create our storage account. We are added subscription, resource group name, storage account name, region, primary service, and so on. Let's go to advanced option. In the advanced option, we have these security settings that impact our storage account. By default, it is checked for, these boxes are checked for require secure transfer for REST API operations and enable storage account keys. If you want, you can allow enabling anonymous access on individual containers, and if you want, you can check default Microsoft Entra authorization in the Azure portal. You can choose between TLS versions. Version 1.2 is now actual, and permitted scope for copy operations is from any storage account. As I already told you, you can check this box if you want integration with Microsoft Entra authorization. Then there is something, as you can see, this is minimum TLS version. There is something called hierarchical namespaces. When you check or enable this box, it will create data lake storage gen 2, and you can use this for database purposes, for example. Also, there is something called access protocol. You can enable SFTP or enable network file system, but this is available only for data lake. Then, if you want, you can allow cross-tenant replication for your Azure Storage Blob. You can choose your access tier, hot or cold, and file shares are enabled by default. This is all on our advanced tab. If I go to networking, by default, enable public access for all network is checked, but you can check enable public access for selected virtual networks, and you can choose your virtual networks and Azure subscription. If you don't have Azure subscription virtual networks, you can create right from here. If you disable public access and user public private endpoint, you have option to create a private endpoint, but let's make it simple and choose our enable public access for all IP, for all networks. Also, you can create something called private endpoint, and you can check how to route your traffic as it all travels from the source to its Azure endpoints. You can choose between Microsoft and internet routing. Then in the data protection tab, you have option to protect data from accidental deletion or modification. By default, it is checked enable soft deletes for blob. You can, if you delete your blob, you can retain this blob from 7 days, enable soft delete for containers, and soft delete for file shares. By default, it's all 7 days. Then you can enable endpoint in time restore for containers if you want. You can use this to restore one or more container to an earlier state. Then you have something called tracking. You can manage versions and keep track of changes made to your blob data. If you want, you can enable a version for blobs or enable blob change feed. And there is something called access control. You can enable version immutability support, and with this access control, you are not allowing anyone to change your object in your blob. Then in the encryption blade we have encryption type. We can choose, by default is Microsoft Managed Keys, and if you want to manage your own keys you can choose Customer Managed Key, which you can choose your encryption type by the help of Azure Key Vault, and that's it. It's very easy to set this up. First you need to create a key vault and choose to manage this Customer Managed Key. Also you can enable support for Customer Managed Key. All support blobs, types, files, tables and queues, or simply blobs and files. And we have tags, review and create, and finally I will click on review and create to create our storage account. And finally, if I'm satisfied with all, I will click on create. So we are creating our storage account. And after some time our resource will be deployed. Our deployment is complete. Let's go to our resource. And in the overview blade you can see the name of your resource group. You see your location, what is your subscription ID, disk state is available. You can add tags. Performance is standard, replication is LRS, account is storage 2, general purpose v2, provision state succeeded, and the name, the date when your storage account is created. Also, in the properties page, you can see more granular information about Blob service, file service, queue service or table service, about your security and networking. As you can see, we have this TLS version 1.2 and access to trusted Microsoft service is yes. In these other tabs you can choose to see monitoring capabilities and so on. Also you can move this to another subscription or another resource group, this storage account. I already showed you how can you move resources in Azure. You can also delete this storage account or upload something, open in Explorer, and that's it. If you go to our data storage, we can create a new container, file share, queues or tables. Let's go to our container, for example. Or you can also work with integrated storage browser. For example, if I go to Blob containers, you can add a container right from here. By default, there is something called logs container, and all your logs will be found here. Also, you can switch between access key and Microsoft Enter user account, switch between these two authentication methods, but for now let's make it simple. Let's see our file share and tables, and you can add right from storage browser if you don't want to download Azure Explorer, Storage Explorer. In the, as I already told you, security and networking blade, you can set up your public network access, network routing, create your firewalls and virtual networks. Public network access is enabled from all networks. If you choose enable from selected virtual networks and IP addresses, you can add some VNET or side range. This is how can you create a private endpoint or add custom domain. There is integration with front door and CDN. Also there is something called access key. Access key authenticates your application request to this storage account, and this is our storage name. We have two keys. We have key and connection string, and you can rotate this string. Also there is more granular shared access signature grants restricted access right to Azure storage resources, and allowed services is blob, file, queue, and table. Also there is encryption. We already mentioned that we have two types of encryption. By default it is Microsoft managed key, and if you want there is custom encryption key. Then in data management there is various options that you can work with. Some of them we will see in the next chapters. Storage task provide a framework for large multi-execution. Redundancy, you can check your redundancy, and you can change your redundancy. For example, if you want, you can add zone redundant, and this is our primary data center, East US, as you can see. In data protection, you can recover your data when it's deleted. There is something called object replication. If you want to copy blob asynchronously, blob inventory, static website, lifecycle management, and you can use Azure AI search. Also in the settings there is a configuration where you can choose your secure transfer, allow blob anonymous access, allow storage key access, choose to allow recommended shared, but you can change this performance. You can change performance, of course, but when you're creating your storage account you must be careful to choose standard or premium, and after that you can change that option. But you can change blob access tier from hot or to cold. Hot is default, and there is something called endpoints. In the endpoints you can see your resource ID or blob service. This is your storage account resource, and also resource ID and file service, queue service, and blob service. Also there is data lake storage address, and you can use these endpoints for your applications. In the monitoring you have option to see insight, create alerts, see metrics, logs, and so on. In the automation you can explore this template if you want. Right now Azure is generating this template, and when it's finished with generating you can download or redeploy this storage account, or simply download this in JSON parameter, this template. As you can see, this is our template. This is our template of our storage account in JSON format. As you can see, it's standard LRS located in ESUS. This is our type, API version, name, using parameters and properties, and so on. In the later part of this course we will get familiarize ourselves with JSON templates and so on, with ARM templates and so on. Also there is a help. You can choose to see your resource health, connectivity check, or if you type support troubleshooting, you can write a support if you have some problem with this storage account. Finally, if I go to data storage, if I go for example to containers, I can create a new container, upload some object, but for now I just want to show you this storage account, how it looks to create storage account, and simply I will now delete this resource, and I will see you in the next chapter. Azure Storage always store multiple copies of your data to protect it from planned and unplanned events. Examples of these events include transient hardware failures, network or power outages, and major natural disasters. Redundancy ensures that your storage order meets its availability and durability goals even when it comes to failures. When deciding which redundancy option is best for your scenario, consider the trade-offs between lower cost and higher availability. Factors that can help determine which redundancy option you should choose include how your data is replicated within the primary region, whether your data is replicated from a primary region to another geographically distant region to protect against regional disaster or geo-replication, and whether your application requires read access to replicated data in the secondary region during an outage in the primary region. Geo-replication with read access. The data is in an Azure Storage accounts is always replicated 3 times in the primary region. Azure Storage offers 2 options for how your data is replicated in the primary region. Local Redundancy Storage, or LRS, copies your data synchronously 3 times within a single physical location in the primary region. LRS is the cheapest replication option, but it is not recommended for applications that require high availability or endurance. Zone Redundant Storage, or ZRS, copies your data synchronously across 3 Azure availability zones in the primary region. For applications that require high availability, Microsoft recommends using ZRS in the primary region as well as replication in the secondary region. Redundancy options can help provide high durability for your application. In many regions, you can copy that data within your storage account to a secondary region that is hundreds of miles away from the primary region. Copying your storage account to a secondary region ensures that your data remains persistent during a complete regional outage or disaster in which the primary region cannot be recovered. When you create a storage account, you select the primary region for the account. The paired secondary region is determined based on the primary region and cannot be changed. Azure Storage offers 2 options for copying data to a secondary region. Geo-redundant storage, or GRS, copies your data synchronously 3 times within a single physical location in the primary region using LRS. It then asynchronously copies your data to a single physical location in the secondary region. Within the secondary region, your data is copied synchronously 3 times using LRS. And we have geo-redundant storage, or GZRS, replicates your data to another physical location in a secondary region to protect against regional disruption. With an account configured for GRS or GZRS, data in the secondary region is not directly accessible to users or application when there is an outage in the primary region, unless there is a failover. To the overcoming process, update DNS entry provided by Azure Storage so that the storage service endpoints in the secondary region become the new primary endpoint for your storage account. During the error process, your data is inaccessible. When the error transition is complete, you can read and write the data to the new primary region. If your application requires high availability, then you can configure your storage account for read access to the secondary region. When you enable read access to a secondary region, your data is always available to read from the secondary, including when the primary region becomes unavailable. Read access geo-redundant storage, or array GRS, or read access geo-zone storage, or array GZRS configurations allow read access to the secondary region. Azure Files does not support read access geo-redundant storage or read access geo-redundant storage. All data for all storage account is copied from primary to secondary according to the redundancy option for the storage account. Objects, including block blobs, append blobs, page blocks, queue, tables, and files are copied. Data at all levels, including the archive level is now copied from primary to secondary region during geo-replication. The archive tier for Blob Storage is currently supported for LRS, GRS, and Array GRS accounts, but not for ZRS, GZRS, or Array GZRS accounts. A local redundant storage replicates your storage account 3 times within a single data center in the primary region. LRS provides at least 99.11 durability of building over a given year. The LRS is the cheapest redundancy option and offers the least durability compared to other options. LRS protects your data from server rack and disk drive failures. However, if a disaster such as fire or flood occur in the data center, all replicas of the storage account used by LRS may be lost or unoperable. To mitigate this risk, Microsoft recommends using zone redundant storage, geo-redundant storage, or geo-zone redundant storage. The write request to the storage account used by LRS happens synchronously, and the write operation is returned successfully only after the data has been written to all 3 replicas. Availability zone in the primary region. Each availability zone is a separate physical location with independent power, cooling, and networking. ZRS offers a storage resource lifetime of at least 99.129% over a given year. When you use ZRS, your data remains available for read and write operations even if the zone becomes inaccessible. If a zone becomes unavailable, Azure takes network updates such as repointing the domain name system DNS. These updates may affect your app if you access the data before the updates are complete. When designing application for ZRS, you need to follow transient error handling practices, including implementing retry policies with exponential pullback. A write request to a storage account that uses ZRS happens synchronously. The write operation is returned successfully only after the data has been written to all replicas in 3 availability zones. If the availability zone is temporarily unavailable, the operation is successfully rolled back after the data is written to all availability zones. Microsoft recommends using ZRS in the primary region for scenarios that require high availability. ZRS is also recommended to data replication to a specific region in order to meet data governance requirements. Also, Microsoft recommends using ZRS for Azure file workloads. If the zone becomes unavailable, you don't need to remount the Azure file share from the linked clients. ZRS provides excellent performance, low latency, and resiliency for your data if it becomes temporarily unavailable. However, ZRS alone may not fully protect your data from a regional disaster in which multiple zones are permanently affected. Geo-zone redundant storage, or GZRS, uses ZRS in the primary region and also geo-replicates your data in the secondary region. GZRS is available in many regions and is recommended for protection against regional disaster. The archive tier for Blob Storage isn't currently supported for ZRS, GZRS, or Array ZRS accounts. Also, unmanaged disks do not support ZRS or GZRS. Geo-redundant storage, or GRS, copies your data synchronously 3 times within a single physical location in the primary region using LRS. Then, it copies your data to a single physical location in the secondary region that is 100 miles away from the primary region. GRS offers storage resource lifetime of at least 99.169% over a given year. The write operation is first handed over to the primary location even and replicate using LRS. The update is then replicated asynchronously of the secondary region. When data is written to a secondary location, it is also replicated within the location using LRS. And finally, geo-zone redundant storage combines the high availability provided by redundancy in availability zone with the protection against regional outage provided by geo-replication. The data in the GZRS storage account is copied to 3 Azure availability zones in the primary region. In addition, it is also replicated to a secondary geographic region to protect against regional disaster. Microsoft recommends using GZRS for applications that require maximum consistency, endurance and availability, excellent performance, and disaster recovery resiliency. With a GZRS storage account, you can continue to read and write data if an availability zone becomes unavailable or irreversible. In addition, your data also remain persistent during a complete regional outage or disaster in which the primary region cannot recover. GZRS is designed to provide at least 99.169% durability of object over a given year. If you go to our Azure portal and choose to create a new storage account, in this first tab, we need to provide some details like our subscription, resource group, then instance details, storage account name, region, primary service, performance, and then our redundancy option, as you can see. I already show you the most important thing when you create a storage account, but for now I just wanted to show you how can you see your or change or choose what redundancy you need to choose. We already know that we have 4 types of redundancy: LRS, or our local redundant storage. Then we have zero redundant storage or ZRS, geo-redundant storage, and geo-zone redundant storage. Also, if you check this box below geo-redundancy options menu, if you check this box, you can make read access to available data in the event of regional data unavailability. But this read access is only available to geo-redundant storage and geo-zone redundant storage. And then it really depends if you choose performance, standard and premium, then you will have different redundancy options. So let's see, for example, if we choose standard performance, this is for our general purpose V2 accounts, we have all 4 redundancy options and we can make read access to data available in the event of regional unavailability. As you can see, we have LRS, GRS, ZRS and GZRS, and we can make read access for GRS and GZRS. Then, if I, for example, need a premium performance, which is recommended for scenarios that require low latency, we will see a different redundancy options, but for now, let's see. As already told you, in the premium performance, we have options for blob account type, and we can choose from blob file shares and block blobs, file shares, and page blobs. And if I choose page blobs, I only have LRS and ZRS option, redundancy option. If you choose block blobs, we have also LRS and ZRS option, and if I choose file shares, we have also LRS and ZRS option. So only in standard performance we have option to choose between 4 redundancy options. Once again, LRS, GRS, ZRS and GZRS, and then we can make our read access to GRS and GZRS. Azure Blob Storage is Microsoft cloud-based object storage solution. Blob Storage is optimized to store huge amount of unstructured data. Unstructured data is data that does not adhere to a specific data model or definitions, such as text or binary data. Blob storage is designed for storing images of documents or documents directly to the browser, storing files for distributed access, streaming video and audio, write logs to files, data retention for backup and restore, disaster recovery and archiving, and storing data for analysis by on-premises or Azure hosted service. Users or clients application can access object in Blob Storage via HTTP or HTTPS from anywhere in the world. Objects in Blob Storage are accessible through Azure Storage REST API, Azure PowerShell, Azure CLI, or the Azure Storage Client Library. Client libraries are available for a variety of languages, including .NET, Java, Node.js, Python, and Go. Customers can only securely connect to Blob Storage using SSH File Transfer Protocol or SFTP and mount Blob Storage containers using the Network File System or NFS 3.0 protocol. Blob Storage supports Azure Data Lake Storage Gen 2, Microsoft Enterprise Big Data Analytics solution for the cloud. Azure Data Lake Storage Gen 2 offers a hierarchical file system as well as Blob Storage benefits, including low cost, multi-tier cost, high availability, strong consistency, disaster recovery capabilities. Blob Storage offers three types of resources: storage account, container store account, and blob in a container. A storage account provides a unique namespace in the Azure for your data. Each object that you store in Azure Storage has an address that includes a unique account name. The combination of the account name and the Blob Storage endpoints form the base address for the object in your storage account, like HTTPS myStorageAccount, .blob.core, .windows.net. A container organizes a set of blobs similar to a directory in a file system. A storage account can contain an unlimited number of containers, and a container can store an unlimited number of blobs. The container name must be a valid DNS name, as it forms parts of the unique URI, or unique resource identifier, that is used to address the container or its blob. Also, you need to follow some rules when naming a container. Container names can be between 3 or 63 characters long. Container names must begin with a letter or number and can contain only lowercase letters, numbers, and a hyphen. 2 or more consecutive hyphens are not allowed in the container's name. The URI, or unique resource identifier, for the container is similar to, for example, myaccount.blob.core.windows.net/mycontainer. Azure Storage supports three types of blobs. Blob stores text and binary data. Block blobs are made up of blocks of data that can be managed individually. Block blobs can store up to 200 terabytes. Additional blobs or append blob consist of blocks like block blobs, but they are optimized for append operation. Append blobs are ideal for scenarios such as logging data from virtual machine, for example. Page blobs store random access files up to 8 terabytes in size. Page blobs store virtual hard disk or VHD files and serve as disk for Azure virtual machine. The name of a blob can contain any combination of characters. The blob name must be at least 1 character long and can be longer than 1024 characters for blob in Azure Storage. The name of blobs are case sensitive. Reserved URL characters must be displayed correctly. There are limits on the number of path segments that contain the blob name. A path segment is a string between consecutive separator characters, for example a slash, that corresponds to a directory or virtual directory. The following path segment constraints apply to blob names. If a storage account doesn't have hierarchical namespace enabled, the number of path segments that contain the blob name can't be more than 254. If the storage account has hierarchical namespace enabled, the number of path segments containing the blob name cannot exceed 63, including the path segment for the container name and the account host name. Currently I am in my marketplace, in my Azure portal. Let's find our storage account and create a new storage account. I will create a new resource group, then add a name for my storage account. I will choose my region, choose my primary service, choose my performance and redundancy option. Finally, I will choose my primary service as Azure Blob Storage and Azure Data Lake. And I will choose my standard performance. Then I will leave everything that already is by default. If you enable hierarchical namespace, you will create data lake storage Gen 2. I already told you that. And let's go to networking. I will leave this as enable public access from all networks. Let's go to data protection, encryption, tags, and then review and create. And finally, after validation, I will click on create to create our storage account. Our resource is completed. And then, as I already told you, we have this overview section where we can see all properties for our storage account. If you go to configuration, you can configure additional settings, but you can switch to premium performance because you can do that only when you're creating a storage account. Maybe I am repeating myself, but this is very important from the exam perspective. Also, you need to remember that in data storage we have containers, file shares, queues and tables. If I go to Control IAM, choose to add some role assignment, I will find or search contributor, and then if I scroll down I can add this Blob Storage data owner, and then I will click on next, and this role allows me the full access to Azure Storage Blob containers and data, including assigning POSIX access control. Let's go on next, choose my user group or service principal. I will select my members, then I will add to myself this role, select, click on next, and finally I will click on review and assign to add this role for this storage account. Let's go to role assignment, and if you can see I am currently storage blob data owner, and I already have the owner role for this resource. If you click on storage role data owner, you can see that this is a built-in role, and you can see all permissions and descriptions. Also, if you go click on JSON, you can see all of this in JSON file, and in the assignment you can remove this role. Let's go to container. We have only log container here. This is by default, and if I click on container, I will add a name for my container, and I can choose private, blob, or container, no anonymous access, or anonymous read access for only blob, for blobs only, or container to anonymous read access for containers and blob. You can choose between these three options. I will choose to anonymous level, access level to a container level. This is, I already told you, anonymous read access for container and blobs. And let's choose our blob, anonymous read access for blobs only. I will click on create, and we're creating our first container. Our container is created, and when you check this container, check this box, you can change an access level, and you can see, for example, private, no anonymous access level, and anonymous access level is changed to private. When you click on these three little dots, you have option to see container properties, generate SaaS, configure access policy, acquire lease, change access level, edit metadata, or delete this container. I will go now inside this container, and let's click on upload. But first, you can also change an access level on a blob level. Let's click on upload, as I already told you. Let's click on browse for files, or simply you can drag and drop files in this option, and if you upload some object, they will be shown here. Let me find some files. I will add this for slide. Click on upload. There is an option to overwrite these files if already exist, and in the advanced option you can choose your blob type, block, page or append blob. You can choose a block size, choose your access tier. In the next chapter we will talk about access tiers in detail. And then you have hot, cold, cool, and archive. You have option to upload to folder, choose blob index tags, choose your encryption mode, and so on. But let's keep it simple, and I will click on upload. After some time we successfully upload blobs, and you can see all objects listed here in our container. You have name, date when it's modified, access tier, archive status, block type, what is the size of your blob, and so on. Also, if I check this first object, I have option to change tier, I have option to acquire lease, view snapshot, or create some snapshot, or simply delete this object. Then if you go to our three dots, we have even more option. We can view or edit this file, download this file, and see properties. Let's go to our blob, and in the edit option you can see what is our file. You can check your version, check your overview, generate a SaaS, or simply copy this URL of this object. Also, you can check your when the last time this file is modified, when is creation time, version ID, type of blob, what is the size of this file, access tier, where is access tier last modified, and so on. As you can see, there is a lot of options and details. In the version and snapshot you can see all these options, and this is our object 1. Also, you can create this URI to grant access to Azure Storage blob, but more about that in later chapters. I will now click on delete to delete this object. You have option to also delete blob snapshot. If I delete this blob, there is an option to show deleted blobs. If I toggle this option to yes, you have see that we have 6 days to retention, and in that 6 days we have option to undelete this blob. I will now check this option and simply click on 3 dots and click on undelete, and we successfully undeleted our blob. This is called soft delete, and as I already told you, you can do a lot of things. You can diagnose and solve problem. You can add RBAC roles to container level. Also, you can add access policy or shared access token. If you go to our add role assignment, I can add more role assignment to this container. So this is more granular. As I already told you, there is 45 roles, and you can do exactly the same thing with RBAC roles as we already know. Let's go back to our container. And if I go again in this container, just to remind you, we have 4 objects. You can change the access level to private. Let's choose our blob, and we are changing the access level for containers. Then, if I, for example, of course, if we check this anonymous access level, then it will be blob. If you go to our endpoint, you can see that we have unique resource ID and blob service address, and this is address for our blob. As I already told you, the name of our storage account, blob.core.windows.net, then it will add the name of our container, and finally slash the name of our object. Let's go to our container. I will now edit or view my first object. Go to overview. I will copy my URL of this object, open a new tab, copy this address, and you can see that we have our unique address for this object 1. First is HTTPS, then this is the name of our storage account, then we have .blob, and then unique address .core.windows.net slash the name of our container slash the name of our object and the extension of this object. So it's very easy to understand how can you work with blobs, how can you work with files, and so on. Also, you can see if we check our second object and go to view and edit, let's copy our second address, paste it here, and you can see that we have exactly the same address, but the name of our object will be different. In Azure, it's all about cost. If you save or download the data, some charges will be incurred. While using Azure, we must also pay attention to cost savings. Azure offers 4 levels of access for this: hot, cool, cold, and archive. To make it easier to understand access tiers, we need to know that they are hot, cool, and cold online, while archive is offline access tier. Data stored in the cloud is growing at an exponential pace. To manage cost for your growing storage needs, it can be helpful to organize your data based on how often it will be accessed and how long it will be retained. Azure Storage offers different levels of access so that you can store your blob data in the most cost-effective way based on its use. The level of access to Azure Storage includes hot layer, a level on the network optimized for storing data that is frequently accessed or changed. The hot tier has the highest storage cost but the lowest access cost. Cool level, a level on the network optimized for storing data that is rarely accessed or changed. Cold level data should be stored for at least 30 days. The cool level has lower storage for cost and higher access cost compared of the hot layer. Then we have cold level. That is a level on the network optimized for storing data that is rarely accessed or changed, but still requires a quick download. Cold level data should be stored for at least 90 days. The cold level has lower storage cost and higher access cost compared to the cold layer. And fourth one is archiving level, an offline level optimized for storing rarely accessed data and having flexible latency requirements in order of hours. Archive level data should be stored for at least 180 days. Azure storage capacity limits are set on the account level, not at the access level. You can choose to maximize capacity utilization at one level or distribute capacity on two or more levels. Setting the access level is only allowed on block blobs. They are not supported for page append or blobs. Or containers. The archive level is the off-grid level of data storage that is rarely accessed. The archive level has the lowest storage cost. However, this tier has higher data download cost with higher latency compared to hot, cold and cold tiers. Example of usage scenario for the archive level include long-term backup, secondary backups and archival datasets. On the account that has soft delete enabled, the blob is considered deleted after it is deleted and the retention period expires. Until this period expires, the blob is only lightly deleted and it's not subject to a penalty for premature deletion. While blob is at archive level, it cannot be read or modified. To read or download an archive level, you must first rehydrate it to an online level, either hot, cold or cool. Archive level data can take up to 15 hours to rehydrate depending on the priority you prioritize for rehydration. Storage accounts have a default access level setting that indicates the network level at which the new blob was created. The default access level setting cannot be set to hot or cold. Users can override the default setting for an individual blob when uploading a blob or changing its tier. The default access level for the new general purpose storage account version 2 is set to hot by default. You can change the default access level when you create a storage account or after it's been created. If you don't change this setting in the storage account or explicitly set the level when uploading the blob, then the new blob is uploaded to the hot tier by default. A blob that doesn't have an explicitly assigned tier infer its tier from the account default access level setting. If the blob access level is inferred from the default account access level setting, then the Azure portal displays the access level as hot, performed, cold or cool. Changing the default access level setting for a storage account applies for all blobs in the account for which the access level is not explicitly set. If you change the default access level to a cooler level in a general purpose V2 account, then you are charged for write operations to 10,000 for all blobs for which the access level is assumed. You also be charged for read operations per 10,000 and download operations per gigabytes if you switch to a warmer tier on a general purpose version 2 account. If you go back to our storage account and go to configuration, I already showed you that you have this blob access tier by default. We have hot and cool tier. Also, you can specify this when you create your storage account, but if I choose now cool and click on save, this changing the access tier may result in additional charges, as you can see in our message. But if you want to have a cool tier, then just go to configuration, choose your cool option and click on save. If you go to containers, if you remember, we have our container, and in this if I click on three little dots or go to our inside our container, we have the four objects. Let me choose my first object. I can change my tier, and I can choose my to optimize my storage cost and choose my tier: hot, cool, cold, or archive. Let me choose my cool tier, and then I will click on save, and after some time we will have a notification that our object number 1 is now in cool tier. If I check my number 2 object and change my tier, I can, for example, choose my cold tier and click on save, and again our object 2 is now in cold tier. Let me check my third object and go to change tier. I will now choose my archive tier, click on save, and after some time our object number 3 will be in archive access tier. Then if I again try to change my tier, first we need to if I choose, for example, hot tier, then we need to rehydrate our priority for standard and high. If you choose high, then it will be a higher cost for this object to rehydrate, but it will be faster than if you choose standard. Then if you see archive status, it's pending to hot. So this is how can you change access tiers and work with your objects in your container. It's very easy, as you can see, but you need to check this box or simply click on three little dots and change your access tier. I will now upload my new object. Let's find some new file, this number 6 file, and then you can choose in the advanced option, you can choose between block size, and then you can choose access tier. So I will choose hot, for example, or some of other option. Then you have option to change check your blob. If you use page blob, then you don't have the options for tiers, just like in page blob. Only in the blob you have option to choose between tiers. And then let's choose, for example, cool tier and upload this object, and our object is uploaded. As you can see, our number 6 object is in the cool access tier. And then if you click on three little dots and go to edit this file, you can see and edit or generate your SAS. So you can jump back and forth to your access tiers. It really depends on your needs or your organization needs. And now we are in the Azure Table Storage is a service that stores non-relational structure data, also known as structured NoSQL data, in the cloud, providing a key attribute store with a schema-free design. Because table storage is schema-free, it's easy to customize your data as your application needs to evolve. Access to table storage data is fast and cost-effective for many types of application and is typically lower than traditional SQL for similar amounts of data. You can use table storage to store flexible data sets such as user data for web applications, address books, device information, or other types of metadata that your service requires. You can store any number of entities in the table, and a storage account can contain any number of tables. up to storage account's capacity limit. Azure Table Storage stores large amount of structured data. The service is a NoSQL data warehouse that accepts authenticated calls inside and outside the Azure cloud. Azure Tables are ideal for storing structured, non-relational data. In the common use of table storage include storing a terabyte of structured data capable of serving web-sized applications, storing data that do not require complex corrections, foreign keys, or stored procedures and can be denormalized for quick access, fast data examination using a clustered index, data access using the OData protocol, and link queries with the VCF data service.NET libraries. You can use table storage to store and query huge sets of structured, non-relational data, and your tables will grow as demand increases. Accounts. All access to Azure Storage is done through a storage account. All access to Azure Storage DB is done through the Azure Cosmos DB for table account, for example. Table is a set of entities. Tables don't apply a schema to entities, which means that a single table can contain entities that have different property sets. Entity is a set of properties similar to a database row. An entity is Azure Storage can be up to 1 megabyte in size. An entity in Azure Cosmos DB can be up to 2 megabytes in size. A property is a name-value pair. Each entity can include up to 252 data storage properties. Each entity also has 3 system properties that specify a partition key, a row key, and a timestamp. Entities with the same partition key can be examined and inserted or updated faster in atomic operations. An entity row key is the unique identifier within a partition. If you've been following the Azure Cosmos DB tutorial on my course of Azure Cosmos DB, you have the possibility to see a demo of difference between table and storage account or table storage account and Azure Cosmos DB for table, where I explain in detail everything related to working in both services. But for now, let's stick to this table storage, and I will show you how can you work with table storage. So once again, we are in our storage account, and if I click on tables, you see that I don't have any tables yet. But first, let's go to our storage browser and click on this storage browser, and then I will go to tables, click on add table, and I will add a name for my table, and then click on OK. Once that we created our table, we will have the name and unique URL for our table. As you can see, this is our table A. Just like Blob service, you can see that we have our storage account name .table.core.windows.net/table A. You can generate SAS, create access policy, delete this table, or add some role-based access control if you want. But for now, let's stick with the basics, and you can also delete this. Let's go inside our table. So we have partition, key, timestamp, and row key. If I click on add entity, I will add a new entity for this table. Let's click on add entity, then I will add my value. For example, company A. Then I need to add my row key. You can have something like helmets, for example, and then I will click on insert. We successfully added our first entity. Partition key is company A, row key is helmets, and you can see we have our timestamp when this entity was added. If I click on 3 dots, I can edit or simply delete this entity. Then if I add a new entity, I have option to add a new value. For example, company B. Then for the row key, I will add helmets again. And then I have option to add a property. I need to add a name for my property. Let's say choose our type, and in the type you can choose between, name, and in the type option column we have option to choose from string, boolean, datetime, double, GUID, and so on. And then I will add a value, for example, Rydell. And then let's click on insert, and we have our second entity, but there is a new column with our name that we just add this value. Then I will add a new entity. Let's see, company C, for example. I will again choose my row key, this helmets. Then in the name, property name, I will add something like, let me see, I will add some value, some random value. For example, Nike. I will choose on properties and add a new property name. Let's, for example, add number. I will choose type as a string and number 12. And as you can see, we have a new column with the number. So this is how can you work with these entities. And for authentication method, you can switch between Microsoft Entra and access key. Also, if you want to delete some of these entities, you can simply check this box and click on delete. And then I will click on these three dots, click on edit, and I can edit these values. For example, I can change to 10 and click on update, and our number or entity is successfully. I can even add a new property. So it is very easy to manipulate with and work with these property names, type, and values. I can even edit a column and choose to add or remove column. Simply check this box in front of your column and you can move it down or up or simply reset, and that's it. Click on save, and now the row key is before timestamp. Also, if I click on delete, I will now permanently delete this company C entity. Also, I can do exactly the same for my table A. I can edit my column and choose my URL and so on. As I already told you, it's very easy to manipulate and work with tables in Azure Storage account. Simply try and you will see for yourself. If I go to table again, you can see that we have our table, and I have option to add a policy. You can add stored access policy. Again, I will now click on delete and delete our table, or simply you can add a new table. Just add a name, click on OK, and the name of your table, new table, and the new URL will be shown here, as you can see. Simply delete this table and your table will be deleted. Thank you for watching. Qtable or Azure Q Storage is a service for storing a large number of messages. You can access messages from anywhere in the world through authenticated calls using HTTP or HTTPS. A queued message can be up to 46 kilobytes in size. A queue can contain millions of messages, up to the total storage capacity limit of the account. Rows are commonly used to create a queue are commonly used to create a backlog jobs for asynchronous processing, as in the web queue worker architectural style. Storage account is all access to Azure Storage is done through a storage account. Then we have queue. The queue contains a set of messages. The name of order must be in lowercase letters only. Message in any format is up to 64 kilobit in the prior version. The maximum time is now and allowed to live 7 days. And for a new version, the maximum duration can be any positive number or -1 that indicate that message is not expiring. If this parameter is omitted, the default lifetime is 7 days. Azure Queue works by providing a simple, efficient way to send and receive messages between different parts of your application. Here how does it work. First, you create a queue in the Azure Queue repository. This queue can be thought of as a container that contains messages. You can then send message to the queue using the Azure Storage SDK on the Azure portal. Each message can be up to 64 kilobytes in size. When a message is okay, it can be downloaded by any part of your app that has access to. Messages are downloaded in order in which they are added to the queue. When a message is downloaded from a queue, it becomes invisible to other parts of the app for a certain amount of time, known as visibility time limit. This prevents multiple parts of the app from processing the same message at the same time. Once the message has been processed, it can be deleted from the queue, marking it as complete. If the message is not deleted, it will become visible again after the visibility timeout expires. Here are some of the benefits of using Azure queues. Highly scalable, Azure Queue can handle large volumes of messages, making it easy to build applications that can scale to meet changing requirements. Fault tolerant, Azure queues are designed to be highly available and fault tolerant, with built-in redundancy and automatic fault rollover. Distributed, Azure Queue can be accessed from anywhere, making it easy to create distributed applications that can span multiple regions or data centers. Simple and efficient, Azure Queue provides an easy, efficient way to send and receive messages between different parts of your application. Azure queues can be used for a variety of scenarios, including separation. Azure queues can be used to separate different parts of your application, allowing them to communicate asynchronously without having to know about each other. Workload processing, Azure Queue can be used to distribute workloads across multiple application instances, making it easier to scale processing, event-driven architectures, and Azure queues can be used to implement event-driven architectures where events are stored in order and processed by different parts of the application based on their subscription. Azure queues can be used to process large amounts of data, such as log files or sensor data, by sending messages to an application or processing service. Azure queues can be used to implement trusted messaging patterns such as storage and forwarding, where message delivery is guaranteed even if the recipient is temporarily unavailable. You can use Azure queues to send messages between different Azure regions, but you'll need to make sure that the storage account and queues are in the same Azure subscription. You can store up to 500 terabytes of messaging in Azure Storage, but there is a limit of 64 kilobytes per message. The cost of using Azure queues depends on factors such as the number of messages, the size of the message, and the number of transactions. Azure queues is a powerful and flexible message queuing service that can help you build highly scalable, resilient, and distributed applications in the cloud. By providing an easy and efficient way to send and receive messages, Azure queues can help you separate different parts of your application and distribute your workloads across multiple instances, whether you're building event-driven architectures, processing large amounts of data, or implementing reliable messaging patterns. Azure queues can help you achieve your goals in a reliable and scalable way. If you go to our storage account and go to queues, you have an option to create a new queue. But I will go to my storage browser in the storage account. Let me expand this and I will add a new queue. First, we need to add a queue name. For example, company A, but we need to be only in lowercase letters. Company A, and finally I will click on OK. We successfully created our queue, and as you can see, we have a unique URL with queue.core.windows.net/company A, just like in the table, just like with the tables, as you remember. Then, if I go on three little dots, I can edit metadata, generate SES, create access policy, add role-based access control, add to favorites, or delete this queue. Then, if I go inside I can even add this to favorite if I want. If I go inside my company A, I have option to add my message, and I will simply add a message. You have this body to add message text. For example, this is just a sample or test, and then you need to, or simply test. I will choose when my message expires. You can choose units in days, minutes or seconds, and then or even hours. And then if you check your message never expires, then the message will never expire. Also, you can encode this message body in base 64. And simply I will choose OK, and I will add my message to queue. As you can see, we have our message text ID for this queue, and you can see the message properties, what is insertion time, ID, expiration time, and the queue count. So if you remember, we add this 15 seconds, and now if I refresh, I don't have this message, because this message, you can also clear queue or edit this column. Exactly the same, just like in our table storage. You can move up or down these columns, but if you remember, you can have option to add for how much this message will expire, and I added 50 seconds, and then this message just simply expire. And then if I add this 7 days, after I click on refresh, there will be our new text message. I can now dequeue my first message. If I click on yes, then I don't have this message anymore in my company A. So this is just simple. You can also dequeue your all messages. This is just a simple demo how can you work with your queue storage, queue table. Azure File Shares or Azure Files offers fully managed cloud file sharing that is available through the industry standard Server Message Block or SMB protocol, Network File System Protocol or NFS, and Azure REST File API. Azure File Share can be mounted simultaneously using Azure Cloud or on-premise deployment. SMB Azure File Share is available with Windows, Linux, and macOS clients. NFS Azure File Share are available from Linux clients. In addition, SMB File Share can be cached on Windows Server, and with Azure File Sync for quick access close to where the data is being used. You can use Azure File Share to replace or supplement local file servers. You can use Azure File Share to replace or supplement traditional on-premises file servers or network-connected storage devices or NAS, popular operating systems such as Windows, macOS, and Linux can directly mount Azure File Share whenever they are located in the world. SMB Azure File Share can also be replicated using Azure File Sync to Windows servers, either on-premises or in the cloud, for performance and distributed data caching. With Azure Files Entra ID authentication, Azure File Share can work with Microsoft Entra ID hosted or Azure Active Directory domain services hosted on premises for access control. Also, you can lift and shift your application. Azure Files make it easy to boot and move applications to the cloud that expect file sharing to preserve the application or user data. Azure Files enable both a classic lift and move scenario, where both the application and its data are moved to Azure, and a hybrid lift and move scenario where the application data is moved to Azure Files and the application continues to run on premises. You can use Azure Files to simplify new cloud development project. It's easy to use. Once Azure File Sharing is mounted on your computer, you don't need to do anything special to access the data. Just navigate to the path where the file share was mounted and edit the file. Azure File Share support industry standard SMB and NFS protocols, which means you can seamlessly replace your own on-premise file share with Azure File Sharing without worrying about application compatibility. The ability to share a file system across multiple machines, applications, and application instances is a significant advantage for applications that need the ability to share. It is a fully managed, and Azure File Shares can be created without the need for hardware or operating system management. This means you don't have to deal with patching your server's OS with critical security upgrades or replacing faulty hard drives. Also, you can script creation and tools, and you can use PowerShell commandlet and the Azure CLI to create, mount, and manage Azure File Shares as part of the administration of Azure applications. Also, you can create and manage Azure File Share using the Azure Portal or Azure Storage Explorer. Azure File Shares are designed to be available at all times, replacing all servers and on-premises file shares with Azure Files means you are no longer have to wake up to deal with local power outages or network issues. It's a well-known programmability. Applications running in Azure can access shared data through the file system I/O APIs. Developers can therefore leverage their existing code and skills to migrate existing applications. In addition to the system I/O APIs, you can use Azure Storage Client Libraries or the Azure Files REST API. Azure File Shares offer two standard protocols for mounting Azure File Sharing: Service Message Block (SMB) and Network File System Protocol or NFS. Azure Files allows you to choose the file system protocol that best suits your workload. Azure File Shares don't support access to individual Azure File Shares with both SMB and NFS protocols, although you can create SMB and NFS file share within the same storage account. For all file sharing, Azure Files offers enterprise-level file sharing that can be scaled up to meet your storage needs and can be accessed by thousands of customers at the same time. All data stored in Azure Files is encrypted at rest using Azure Storage Service or SSA encryption. The encryption of the storage service works similarly to BitLocker on Windows. Data is encrypted below the file system level. Because the data is encrypted under the Azure File Share file level, because it's disk encoded, you don't need to have access to the base key on the client to read or write to Azure File Sharing. Encryption and REST apply to both SMB and NFS protocol. By default, all Azure storage accounts have encryption enabled in transit. This means that when you mount file share over SMB or access it over file REST protocol, Azure Files will only allow the connection if it was created using SMB 3.0 with encryption or HTTPS. Customers that don't support this SMB 3.0 with SMB channel encryption won't be able to mount Azure File Share if encryption in transit is enabled. I will use my existing storage account, but first let me delete my queues from previous chapter. I will now go to File Share and let me expand this for a little. Click on file share, and let's create a new file share. First, I will add a name. Choose my access tier. Transaction optimized is the new term. It is the lowest transaction cost pricing for transaction heavy workloads that don't need the low latency offered by premium file shares. It is recommended while migrating data to Azure files. You also have option for hot and cool access tier. Then we have this performance and maximum capacity. And the most important thing, that SMB protocol with this file share you will communicate over port 445. If I want a backup, I will leave this box checked, but I will uncheck this box. Let's review and create, and finally let's create our new file share. As you can see in the properties, you have this option to see size, performance, feature status, and the rest of our essential information. Our resource group, subscription, location, this is a unique URL. Now it is a name of our storage account, .file, .core, .windows, .net / the name of our file share. And our redundancy is LRS, and when is configuration modified, the date of our creation of this file share. Then in the feature status, the soft delete is 7 days. If I click on this 7 days, you can choose these retention policies up to 1 year or 1 day. Also, you can enable or disable soft delete for all file shares. I will click on save, and we successfully updated the file share soft delete settings to 1 day. Large file share is enabled option, and then we have this option for SMB protocol settings, where you can choose SMB protocol versions, authentication mechanism, and so on, and profile. I will now discard this option. Also, you can see that we have 0 snapshot for our backup. Access tier is transaction optimized. Maximum storage is 100 terabytes. And that's it. This is just our properties, our essential information. And now if I, for example, click on add directory, I have an option to add my directory. First we will add a name. I will click on OK, and then if you go to browse, you can see that we have our directory. If I go inside the directory, I can add another directory. Let's add, for example, dir2 like directory, and here it is. We have directory inside our first directory, and then I will upload some objects to this file share. Let's choose my slides, for example. Let's click on upload, and we have 2 objects. And if you click on these 3 little dots, you can edit, download this file, edit metadata, delete, and so on. You can see your file properties. Also, you can download or delete right from here, and that's it. Also, you have option to delete directory or change these properties, or simply see these properties, the date of last modified, and so on. And then you can upload or add directory. If you want, you can go back 1 step up, for example, and if I click on connect button, you see that we have option to connect with Windows, Linux and macOS. Then you need to choose your drive letter, and to connect to this Azure file share for Windows, you need to choose the following authentication methods. For example, storage account key or Microsoft Enter ID. This is a simple script, PowerShell script, that I will now copy, and I will now go to my local computer, go to my start, go to PowerShell. I will run this as administrator or not if you want. Paste this code here and simply install this to my local computer. As you can see, the credentials are successfully added, and now if I go to my File Explorer and if I scroll down, you can see that I have this file share 1000 on my local machine, and I can use all these objects from cloud and copy all of these files directly to my local machine thanks to this connection button. Also, if I create a new directory in my file share in the cloud, for example dir3, I can see this dir3 file. Let's upload some new objects. Click on upload. You can see that I have access to this file right from my desktop from my laptop, and if I go to my file share, you can see that I have this dir3 and the file or objects within our cloud file share. I can copy this and do exactly what I want. Exactly the same thing I can, for example, create some new notepad or some text file on my laptop, and if I check my cloud and click on refresh my FS1000 in my cloud, you can see that I have this txt file right in my file share in the Azure cloud. If I want, I can disconnect from this cloud share. Simply right click on file share name, click on disconnect and click on yes, and the connection will be lost. And if we now check our File Explorer, we don't have any file share from our cloud. Microsoft Azure Storage Explorer is a standalone application that makes it easy to work with Azure storage data on Windows, macOS and Linux. In this chapter, I will demonstrate several ways to connect to and manage your Azure storage accounts. Storage Explorer can use your Azure account to connect to the following types of resources: Blob containers, Azure Data Lake Storage containers, Azure Data Lake Storage directories, queues. Microsoft Enter ID is the preferred option if you have data layer access to a resource but don't have access to the management layer. Storage, you can first sign in to at least one Azure account using the signing steps. In the resource selection panel, if you choose to connect to storage account dialog box, you have option to select container, ADLS Gen 2 container. Then you need to select sign in with Microsoft Enter ID, select next, choose your account and tenant, then account and tenant must have access to the resource you want to join, then you want to click on next, enter a display name for your link in the resource, select next, review information, and if the connection information is correct, simply click on connect. Storage Explorer can connect to a storage account using the name and key of the storage account. You can find your account keys in the Azure portal. Open the storage account page on the select settings and access keys. Enter a display name for your link, an account name, and one of the account keys. Select appropriate Azure environment and then select Next. Storage Explorer can connect to a storage account by using shared access signature or connection string. In the Resource section panel of the Connect to Azure Storage dialog box, you need to select your storage, select Shared Access Signature, click Next, enter your display name, add a SES connection, choose Review Information and simply click on Connect. Storage Explorer can connect to following types of resources using SES URI, Blob Container, Azure Data Lake Storage Container or Directory, File Sharing, Queue Table. In the Selected Resources panel of the Connect to Azure Storage dialog box, simply select the resource you want to connect, select Share Access Signature and select Next. Enter a display name for your connection and a SES URI for the resource. Select Next, Review Information and click or select Connect. Let's see how can we work with Azure Storage Explorer. Once again, I am in my Azure portal, in my marketplace. I will simply search for storage account, choose my Microsoft storage account as a publisher, Microsoft, and then I will click on Create New Storage Account. First, I will create a resource group. Add a name for my storage account. We already know how to create a storage account. Then I need to add my region. Choose my primary service. For Azure Storage or Azure Data Lake Storage, choose my performance, choose my redundancy as LRS, go to Next, 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 and simply click on Review and Create. And finally click on Create. I will open a new tab. Go to my marketplace again. Choose another storage account. I will create another one. Choose my existing resource group. Add a name for this account. Choose my region, primary service. Let's find some appropriate region. For example, I want West US. Then I will choose my redundancy, local redundant storage. Choose my primary service. Go to Review and Create, and finally click on Create to create our second storage account. Then I will go to Containers, click to create a new container. I will add a name, for example, Source Container 1, click on Create, and in this container I will upload some files or objects if you want. Click on Upload, and we have our objects uploaded. In my second storage account, I will create a new container. This will be Destination Container 1. Let's click on Create. And as you already can see, we don't have any in our container. Then I will go to azure.microsoft.com and find my Storage Explorer, click on download and choose my Windows 64. I will click on download, then I will simply download this file, and once the download is finished, I will simply install this Storage Explorer. Choose to accept the agreement, click on install, next, yes, next, and it's pretty straightforward installation, as you can see. And then I will click on finish, and we are launching our Azure Storage Explorer. Once that our Azure Storage Explorer is launched, I will go back to my storage account, source storage account. Let me go to my storage account. Then I will need to go and choose my what kind of Azure resource I want to connect. I will choose my, for example, you can choose between subscription, storage, account or service, blob container, data lake, file share, and so on. And you can choose account name and key, for example. Click on next. Let's go to our security and networking tab. Choose my access key. I will first copy the name of my storage account, and then I will copy this key. We have two keys, if you remember from the earlier chapters. Let me copy my storage account name. This is our storage account name. Also, you can set a reminder to rotate these keys. You have to check this enable key rotation reminder, and you will choose how many days, or do you want to remind you. For example, every 60 days Azure will remind you to rotate this key if you enable this option. Finally, I will go back to my storage account, to my Storage Explorer, copy my name of my storage account, and finally I will copy this storage account key and paste it to account key. Let's do it again. And let's paste it here. Click on next, click on connect, and we are now connected to our storage account, our source storage account, with the help of access key from Azure Storage Explorer. As you can see, if I go to blob containers, we have our source container, and if I go to our source container, we have our 4 objects, so we can work with our 4 objects. You can upload new objects, create a new folder, for example, delete, undelete, do everything what you want with the help of Microsoft Azure Storage Explorer. You can copy, clone, refresh, delete. You can see even properties for this object, change access tiers. If we click on the right click on our first object, we have even more option to change access tier, download this, copy, clone, undelete, get share access signature, acquire lease, see properties, edit tags, and so on. I will click on change access tier. For example, you can change from hot to cool, cold, or archive. Our current access tier is hot, and simply if you choose to cool, you can choose this access tier to cool. Also, you can work with other offers, and then if I go to my storage account, you can detach this connection, and we are now logged out from this storage account. And if I go and try to connect to my blob container, I can do it with the help of shared access signature URL SAS. Then I will click on next, and if I go to my source container, click on these three little dots, click on generate SAS. I have option to add some permissions, and simply click on generate SAS token URL. You have option to set start and expiry date. Let me click copy this link, choose my shared access signature URL as SAS, copy this on our blob container, and display name is automatically added, and simply click on next, next, and connect. And you can see we are now connected on the blob level, and we have see our container on our container level. As you can see, we have now see our source container, and our source container, as you can see, we are now connected with the help of our SAS shared access signature. Also, you can do everything just like in previous. You can change this to hot, for example, just like with access keys, but this is more granular. And you can also detach from this storage account by simply click right button on your mouse and click on detach. Also, you can choose to connect with shared access signature URL SAS. If you go to Storage Explorer, go to shared access signature, choose allow services, choose allow resource types, choose allowed permissions, simply click generate SAS connection, and you need to copy this SAS connection string or shared access signature. Let me copy, for example, blob service SAS. Click on next, connect, and we are connected with our SAS, but on a storage account level with SAS. And also you can do everything what you want with your blobs and objects. I will now detach from this storage account and also you can choose whatever you want to connect. Also, you can sign in with Azure. I will choose sign in with Azure, choose my environment. My available environment is Azure. Click on next, click on connect. I will now sign in with my username and password from my Azure portal, and I'm authenticated, and I can now return to my storage account, but it might ask you to authenticate again. If you go back, we are signed in. As you can see, I have all my directories. This is my home tenant, and I can choose my default directory, for example, and manipulate and work with my storage account if I want. Also, if you click on remove, it will remove my user account from this storage explorer. So this is how can you work with Storage Explorer in many ways with the help of access key, shared access signature on blob blob level, container level, and storage account level, and with a Azure File Sync allows you to centralize your organization file sharing across Azure files, while maintaining the flexibility, performance, and compatibility of Windows file servers. While some users may choose to keep a full copy of their data locally, Azure File Sync additionally has the ability to transfer Windows Server into a fast cache of your Azure file sharing. You can use any protocol that is available on Windows Server to access your data locally, including SMB, NFS, and FTPS. You can have as many caches as you need around the world. In the era of cloud computing, effective data management is essential for doing business in dynamic digital environments. Azure Microsoft Cloud Platform offers a powerful solution known as Azure File Sync, designed to simplify data synchronization and management in hybrid cloud environments. Benefits of using Azure File Sync: centralized file sharing. Azure File Sync allows the organization to centralize file sharing and storage by synchronizing files between on-premises server and Azure file sharing. This allows users to access and collaborate on files from anywhere while ensuring data consistency and integrity across distributed environments. Multi-tier storage. Azure File Sync offers multi-tier storage capabilities, allowing organization to optimize cost by automatically sorting files that are less frequently accessed into Azure files. This helps reduce on-premises storage requirement and ensure efficient use of cloud storage resources. Synchronization in multiple locations. Azure files support synchronization in multiple locations, enable seamless replication of file in multiple locations. This ensures high availability and disaster recovery, as well as improved performance for distributed workloads by reducing latency and improving access times. Integration with Azure Backup. Azure File Sync integrates seamlessly with Azure Backup, providing an all-in-one data protection solution for hybrid cloud environments. Organizations can leverage Azure Backup to schedule regular backups of synchronized files, ensuring data resiliency and recoverability in the event of data loss or corruption. Conflict resolution and change tracking. Azure File Sync includes conflict resolution and change tracking mechanism to ensure data consistency across synchronized endpoints. Administrators can define conflict resolution policies and track file changes in real time, enabling efficient collaboration and version control for shared files. Azure File Sync integrates with Microsoft Entra ID to provide granular access controls and permission management for synchronized files. Administrators can define access policies based on user roles and responsibilities, ensuring secure access to sensitive data and compliance with regulatory requirements. Azure File Sync offers centralized management and monitoring capabilities through the Azure portal, allowing administrators to configure synchronization settings, monitor synchronization status, and troubleshooting issues from a single interface. Deep insight and reporting help organizations optimize performance, identify bottlenecks, and ensure reliable data synchronization in hybrid environments. Azure File Sync is a powerful solution for simplifying data management, improving collaboration, and ensuring data consistency in hybrid cloud environments. By leveraging its centralized file sharing, multi-tier storage, multi-site synchronization, and integration with Azure Backup and Entra ID, organization can achieve seamlessly data synchronization, enhance data protection, and improve operational efficiency. Whether you're managing file server, branch offices, or distributed workloads, Azure File Sync provides a scalable and cost-effective solution to meet the growing data management needs of modern enterprise in the cloud era. Once again, we are in our Azure portal, and let's see how can we work with Azure File Sync. The first thing I want to do is to create a virtual machine. I will go to my virtual machine, or simply, if you go to your storage account, you can see that we have one storage account already in place, but as I already mentioned, let's create our virtual machine. I will choose or create a new resource group. or simply you can choose existing one. I will choose existing one. Then I will add a name for my VM. Let's add VM 0001. Then we need to choose a region. Our availability option is no infrastructure redundancy required. I will choose my image as Windows Server 2022 Data Center Azure Edition. Choose my size. Standard DS1 version 2 is fine. Then I will need to add my administrator account, Azure user username, and I will add my password, confirm my password, and finally let's add our inbound port roles. I will add only 3389, and in the networking section I will leave everything as it is, and finally let's go to review and create our first VM. I will open a new window. And then we will create a new virtual machine. This time, this VM will be the same resource group, but this is our VM 002. I will choose exactly the same region. No infrastructure required. For the availability zone, choose exactly the same image, exactly the same size. Add my username and password for this VM 002. Then I will confirm my password. Choose my RDP 3389, go to disk, go to networking. I will go to review and create, and finally we are creating our virtual machine. And click on create. I will open another tab. And then I will go to Marketplace and find Azure File Sync. I will choose Microsoft as a publisher. Azure File Sync. Let's click on create, choose Azure File Sync. And then I will deploy this Azure File Sync by adding my subscription, username, name for this sync service, storage service sync service name, and the region. Then I will open another tab, and then I will go to my existing storage account. Let's see, because our file sync must be in the same region as our storage account. I will allow access from all networks for our file sync, and finally let's click on review and create. So we are deploying two VMs. We already have storage account, and we are now deploying our Azure File Sync. And after some time, all deployments are completed. Let's go to our file sync, and in the overview tab you can see some additional information, or some basic information, sorry. In the sync tab there is something called sync group and registered servers. As you can see, we have our two VMs, but first we need to create something called sync group. If you go to our file share, I will first create file share in our storage account. we need to add a name, fs2 for example, choose my hot access tier, and I will disable backup, click on review and create a new file share. We successfully created our new file share. Then this is our file share. Then I will go back to our storage sync service, go to sync group, click on create a new sync group, add a name for our sync group. So this sync group is a cloud endpoint. This is very important for the exam perspective. I will add my storage account, and finally I will add my file share that we previously create. And we are creating cloud endpoint. Our sync group is created, status is healthy, and cloud endpoint creation is in progress. Once that we finished with creation of our sync group and cloud endpoint, we need to register our servers. So let's go to our server 1 or VM1. I will now connect to my VM. Let's download our RDP file. Double click on our RDP file, click on connect. I'll add my username and password. Let's click on OK, click on yes. So we are logging into our VM 001. Exactly the same thing we will do for our VM 002. First, we need to download our RDP file for this VM, then double click on this icon, connect, add my username and password, and click on OK. Then let's click on yes. So we are officially connected to our both VMs. And as you can see, if you go to our sync group, we have something called cloud endpoint and server endpoint. Our file share is our cloud endpoint, and then we need to register our server endpoint. We need to wait for our machine to boot up, and we will continue with this demo. As you can see, in the registered service tab, we need to download this agent, Azure FileSeek agent, and after finishing the agent install, we need to register our server. Our VM1 is officially boot up, and we can continue with our working. I will now turn off this enhanced Internet Explorer security configuration, but it really doesn't matter, just wanted to show you this option. Let's open our Microsoft Edge. We need to configure our Microsoft Edge because this is the first time we are working with Microsoft Edge on this VM. Let's continue without this data, confirm and start browsing. Let's click on next. And finally, I will copy this link for our Azure FileSeek agent to download this agent. We can click on download. Choose the latest version. Storage Seek agent. And this agent is now downloaded on our VM 001. Double click on that link and we are officially installing our Storage Seek agent. As you can see, next. Let's click again on next. Do not use Microsoft Edge this time. Let's click on install. And we are installing Storage Sync agent to VM 001. I want to show you the whole process, so this may be a long demo, but trust me, it will be useful for you when you take the exam. I will now minimize my VM 001. Let's go to 002 VM. I will minimize my server manager. Again, I will turn off this enhanced security configuration, and then we will run our Microsoft Edge. Again, we need to configure our Microsoft Edge because this is the first time to run this browser on our VM 002. After that, I will copy my link to download this agent, and again we will install this agent exactly the same like on our first VM, like we did in our first VM. Let's click on download, choose this storage sync agent VS 2022, double click on our, or simply click on open file, and then we will install our agent, storage sync agent setup. Let's try again. And if you go back to our VM1, you can see that we completed our installation of this agent. Let's click on finish, and now our file sync agent is up to date. Then we need to sign in and register this server. I will choose my Azure Cloud. I will sign in as a cloud solution provider. I will simply click on sign in, and I will now sign in with my account. I will add my account. And finally, I will add my subscription. Choose my resource group and choose my storage service. Sync service, this is our FS file share if you remember, and click on register. So we are doing a server registration with the help of our Azure File Sync agent. Our registration is successful and network connectivity test is passed. Let's click on close. I will do exactly the same thing for our VM 0002. I will first sign in with my account, add my password or code. Let me open my Gmail on my phone and I will add this code. Zero 82813. Let's click on sign in. I will choose we'll sign in. I will now choose my subscription, my resource group and storage sync service, our file share. So we are registering our second server as server endpoint. Finally, if I go to my File Explorer and if I go to C drive, I will create a new folder and add a name, for example VM001 folder directory. Exactly the same thing I will do for our second server. If you go inside our directory, we need to copy this path, and I will add this path. Our registration is successful for our second server. And then if you go to our storage sync service, to our registered servers, you can see that we have successfully registered VM001 and VM002. State is online, operating system is Windows Server 2022, and if you go to sync group, you can see that we have our cloud endpoint, and now we need to add our server endpoint. I will choose my registered server. First is VM001, and then we need to add a path. Files to the server head can be brought to the cloud via data box. Let's click on create. So server endpoint creation is in progress. Status is accepted. Exactly the same thing I will do for my VM002, our second server. Let's go to C drive. I will right click on my mouse and then create a new folder. This is VM0002 directory, and we need to copy this path and add to our server endpoint in our cloud as our server endpoint. In our sync group, I will register my second server 002 and add my path. Our server 001 is successfully added, and health is pending. Upload to cloud waiting for initial upload to start. Download to server, exactly the same thing, exactly the same message. So we are waiting for initial download to start. Let's wait until our second server being registered, and after some time I pause my video, and as you can see we have healthy servers, and complete upload to cloud is complete on this day, just like the server name. And then if you go to our server 001, and I will minimize this, and I will do exactly the same for our second VM, so we can track our servers. Let's go to VM001. And we need to, for example, create simple text document. Let's add 001, and after some time, as you can see, if we refresh our page on directorium or on 002 machine, we will have exactly the same file on our 002 machine, thanks to Azure File Sync. So our servers are synchronized and everything is working due to file share. If I go to our file share, go to browse, you can see that exactly the same document or text file we have on our file share. If I, for example, delete this file and create a new one, let's create a folder This is a new folder, and inside that folder I will create a new text document. Let's check our file share. As you can see, we have our folder, and if we hit on refresh, we had our new text documentation in our file share, exactly the same folder and file we will have on our VM002 directory in our VM002. Let's click on refresh, and after some time there will be our new text document.txt file. So this is how can you set up a file sync. This is how can you work with file sync, documents and folders, and file share. I will now close my connections for both of my VM, and then I will show you how can you unregister your servers from file sync group. First, we need to go inside our server group. Then we need to delete our sync group, but first we need to delete all server endpoints and then delete the cloud endpoint. So we must first delete our server endpoints. Let's click on these three dots to delete our server endpoint for 001. I'm ready to delete the server endpoint. Let's check on this option. Server endpoint deletion is in progress. Let's delete our second endpoint, server endpoint. After we delete our endpoint, we need to delete cloud endpoint. This is our file share 2. Let's click on delete cloud endpoint. Server endpoint deletion succeeded, and we are now waiting to server endpoint deletion is in progress for our second VM or our second server. And after that we can delete our cloud endpoint. And finally, our second server is deleted, and then let's delete our cloud endpoint, and this deletion is in progress. And finally, if you check our registered service, you can see that we have now deleted all server endpoints, cloud endpoints, and now we can delete our sync group. If you refresh this, you can see that we don't have any sync group, and now in the overview section we can now delete our storage sync service. And then we need to unregister our servers again. Let's confirm with VM0002. We need to enter the name to register of our registered service to unregister our service. Exactly the same thing I will do for my VM001. And as you can see, this deletion is in progress, and after that we will be able to delete this storage sync service. It's not complicated, but you must follow the right execution and follow some order. Let's go to our overview, and we are waiting for our VM001 to unregister this server. And then, as you can see, we have 0 sync groups and 1 registered service in the properties. And finally, we will be able to delete our file servers. Let's check again. Is there anything else we need to delete? Let's click on refresh. And now we can delete our FS. Simply choose one of the reasons, copy your sync storage name in this and click on delete. Thank you for watching, and I hope this was helpful. And our storage service is officially deleted. Then the Azure Import-Export service is used to securely import large amounts of data into Azure Blob Storage and Azure files by shipping drives to an Azure data center. This service can also be used to transfer data from Azure Blob Storage to disk drives and send them to your on-premise location. Data from one or more disks can be imported either into Azure Blob Storage or into Azure files. You can get your own disk drives and transfer your data using Azure Import-Export service, and you can also use disk drives supplied by Microsoft. If you want to transfer data using Microsoft's supplied disk, you can use Azure Data Box disk to import data into Azure. Microsoft ships up to 5 encrypted solid-state drives, or SSD, with a total capacity of 40 terabytes per order to your data center through a regional carrier. You can quickly configure disk drives, copy data to disk drives via USB 3.0, and send drives back to Azure. Consider using Azure Import-Export when uploading or downloading data over a network is too slow or getting additional network bandwidth is expensive. You can use this service in the following situations. Migrate data to the cloud. If you want to move large amounts of data to Azure quickly and cost effectively. Content distribution. You can quickly set data to your client's website. Backup. You can backup your on-premises data for storage in Azure Storage. Data recovery. Recover a large amount of data stored in storage and deliver it to your local location. The Import-Export service using the following components. Import-Export service. This service, available in the Azure portal, helps the user to create and track import, upload and export download jobs for data. VA Import-Export tool. This is a command line tool that does the following. Preparing your disk drives that are shipped for import. It makes easy to copy your data drive to a disk drive, encrypts data on disk using AES 256-bit BitLocker. You can use an external key protector to protect your BitLocker key. Generates disk drive log files that are used during import creation. It helps in identifying the number of disk drives required for export jobs. The VA Import-Export tool is available in 2 versions, version 1 and version 2. Microsoft recommends that you use V1 for import-export to Azure Blob Storage and version 2 for importing data into Azure files. The VA Import-Export tool is only compatible with 64-bit Windows. Disk drives. You can send your solid-state drives or SSD or hard drive disk or HDD to an Azure data center. When you create an import job, you are sending the disk drives that contain your data. When you create an export job, you are sending empty disk to an Azure data center. The Azure Import-Export service allows you to transfer data to Azure blobs and Azure files by creating jobs. You can use the Azure portal or the Azure Resource Manager REST API to create jobs. Each job is linked to a single storage account. Jobs can be import or export jobs. The import jobs allows you to import data into Azure blobs or Azure files, while the export job allows you to export data from Azure blobs. For the import job, you send the disk that contain your data. When you create an export job, you are sending empty disk to an Azure data center. In any case, you can deliver up to 10 disk drives per jobs. At a high level, the import business involves the following step. Specify the data to be imported, the number of disks you need, the destination blob location for your data in Azure Storage. Then you can use VA import-export tool to copy data to the drive, encrypt the drive using BitLocker. Create an import job on the target storage account in the Azure portal, upload the drive log files, provide the return address and carrier account number for restoring the disks, send the drive units to the shipping address you provided during job creation, update the shipment tracking number in the import job details and submit the import job. Disks are received and processed in the Azure data center. At a high level, the export business involves the following step. Specify the data to export, the number of disks you need, the source blobs or the container path of your data in Blob Storage. Create an export job in source storage account in the Azure portal. Specify the source blob or container path for the data that will be exported. Provide the return address and carrier account number for restoring the disk. Send the drive units to the shipping address you provided during job creation. Update the shipment tracking number in the export job details and submit the export job. Disks are received and processed in the Azure data center. Disk drives are encrypted using BitLocker and the keys are available through the Azure portal. The disks are sent using your carrier account to the return address specified in the import task. The data on the drive is encrypted using AES 256-bit locker drive encryption. This encryption protects your data while it is in transit. When you ship disk to Azure, you pay shipping costs to the carrier. When Microsoft returns disk to you, shipping costs are charged to the carrier account that you specified at the time of opening the business. The standard fee for storage transaction is applied during the import and export of data. Standard output costs are also applicable along with the cost of storage transaction when data is exported from Azure Storage. AzCopy is a command line utility that you can use to copy blobs or files to or on from your storage account. In this chapter, we will download AzCopy, connect our storage account, and then transfer some data. From the initial website, we can download the latest version of AzCopy, and AzCopy supports the use of SAS tokens, so if you know how to generate them, then you can use them for operations. But it also has an authorization option for Enter ID or Azure Active Directory, formerly known. You just have to run the AzCopy login command and follow the instructions. Also, the full command is AzCopy login --tenant -id, and you can add your ID from your Azure portal. Of course, you will need to ensure that your user has permission to write to the container, which entails putting yourself in a role like storage blob data associate. Then, once that you authenticated, it is as simple as calling the AzCopy command, specifying the source file and the destination file. It will create a log file that gives you detailed information about the upload, including all the calls it made as well as statistics regarding performance. Of course, the speed depends on your local network. However, I was personally impressed that AzCopy was able to go almost 10 times faster than some of the other upload techniques I tried. The way it achieved this is by breaking the file into blocks and upload it in parallel. It can use a block list operation to connect all of those blocks into a single block. Otherwise, AzCopy can do much more than upload a single file. You can upload multiple files, download files, and copy between storage accounts using it. It's definitely worth considering all the situations where you need to move large amounts of data to our Azure Blob Storage. The latest version of AzCopy you can download from official Microsoft pages. I will choose my Windows 64-bit zip package to download AzCopy 10, version 10, in moment of recording this video. Then, after that, I can work with AzCopy, and if I go to my Explorer, I already downloaded this AzCopy. As you can see, this is my application, and I made a new folder, and in that folder I put AzCopy and some of my files. For example, this is file 1 and file 2. It's simple PNG file, and AZ-900 file. This is JPEG file. You simply you already saw this when we work with our containers, when we copy our object from source to destination container. So I will use the same file in this demo. So I already download this copy, make a new folder, add this AzCopy to that folder and files that I want to copy. I will now go to my startup, simply try to run my command prompt, and then I will copy this destination where the AzCopy is, and then I will go to this folder, cd, and that path. I'm in that file, and I will run simply AzCopy make or mlist if you want. You can list all files from that folder. But for now, let's try to work with storage account. In my first storage account, I have this source 1 and a container, and in second tab I have this destination container, which contains only one object. So I will try to copy my two files or object from source to our destination folder with the help of AzCopy. Let's see how can we do that. I will go and copy this shared access signature, and then if I, for example, run AzCopy list -h, this is a command that I'll be using. And it will list the whole list of command for AzCopy. But first I will add this service and generate my SES connection string, and then you can copy your blob service SES URL from storage account level. Then I will copy my I will open my Cloud Shell, and then simply I can run commands right from here, or I can do it from command prompt. The choice is yours. Then I will copy this command, AzCopy list -h. Let's try again. I will copy again. As I already told you, this is a copy, the list, account, and help that you can use. All of these commands you can use to work with AzCopy. In this case, I will use this AzCopy, copy, then I will add SES from my source. This is AZ-1000 account, and then I will add SES URL for my destination account -- recursive. That means that I want to copy all files from that container to our destination. Let's see how can we do that. I will now copy this command and paste into my Cloud Shell, and I will run enter, and our job is done. We transferred 2 files, as you can see, and 2 is done, 0 failed, 0 pending, 0 skip, total 2. Let's check our destination folder. I will minimize this. Let's go first to our source folder. As you can see, we have 3 and 5 object, name 3 and 5. And if you go to our destination folder, if I click done, refresh, you can see that we have successfully copied 3 and 5.png with our Azure Migrate provides a simplified migration, modernization and optimization service for Azure. All pre-migration steps such as discovery, estimation and appropriate sizing of on-premises resources are included for infrastructure, data and application. The extensible Azure Migrate framework allows for the integration of third-party tools, expanding the scope of supported use cases, and it provides the following: unified migration platform, a single platform to start, launch and track your migration to Azure. Scope of tools, a range of assessment and migration tools. Azure Migrate tools include Azure Migrate, discovery and assessment, and migration and modernization. Azure Migrate also integrates with the other Azure services and tools, as well as with third-party software vendors' offerings. Assess, migrate and modernize. In the Azure Migrate Hub, you can evaluate, migrate and modernize servers, databases, web applications. You can evaluate on-premises server, including web applications and SQL Server instances, and migrate them to Azure. Databases, as I already told you, you can move your databases, then web apps, access on-premises web apps and migrate them to Azure App Service and Azure Kubernetes Service, virtual desktops, access your on-premises virtual desktop infrastructure and migrate it to Azure Virtual Desktop, then data, transfer large amounts of data to Azure quickly and cost-effectively using Azure Data Box products. Azure Migrate, a discovery and assessment tool that discovers and evaluates on-premises VMware VMs, Hyper-V VMs, and physical servers for migration to Azure. Azure Migrate is free to use with your Azure subscription and provides several features to optimize cost. You can start by determining the appropriate size of resources based on usage trends, which can lead to the need for smaller and faster core in Azure. And to help you stay on budget, take advantage of Azure hybrid benefits, reserved instances, and Azure saving plan incentives included with the business case feature. Microsoft Azure Data Box is a hardware appliance designed to allow users to import or export large amounts of data, more than 40 terabytes, in and out of Azure offline. It is especially useful when there is zero or limited network connectivity. Microsoft provides customers with a proprietary data box storage device with a rugged enclosure to protect and secure data during transit. The customer can choose a data box for one-time or periodic migration to the cloud, or an initial mass data transfer followed by periodic transfers. Microsoft is also promoting Data Box as a solution for exporting data from Azure back on premises to recover from a disaster or other need, or to move to another cloud provider. There are three different types of physical data box solutions based on data size. Data box: this device has a capacity of 100 terabytes and uses standard NAS protocols and common copying tools. It has AES 256-bit encryption for more secure transit. Data box heavy: this larger device is designed to raise 1 petabytes of data onto the cloud. Data box drives: the drives have a capacity of 8 terabytes SSD with a USB SAT interface with 128-bit encryption, and customers can purchase in packs of 5 for a total of 40 terabytes. Azure Data Box is a good solution for considering whether network data transfer is not possible because network bandwidth is limited or because it may take too long. But offline transfers can be very tedious and error-prone if done manually. Selecting data to migrate, moving the data to Azure Data Access to Data Box, and then ensuring the data reaches the cloud can be time-consuming to manage. Managing access control and file data security, as well as ensuring that all metadata and file permissions are transferred, can be very tedious. Businesses often want to move some files data to the cloud and keep the rest on premises. In such situation, using Azure Data Box manually without any automation becomes even more difficult, as it yet can disrupt users and applications. Azure also offers a virtual appliance called Azure Data Box Gateway that sits on premises and allows users to write data to it using NFS and SMB protocols. The device then uploads the data to an Azure blob, or Azure file. But the Azure Data Box Gateway has a few limitations and can only be used for very small amounts in data-limited circumstances.